behind the warm front is called the warm sector. Is the area behind the warm front. This will be the tip of the warm front. And again, what you should know about the warm front is that the warm front hardly ever, or it never affects the weather of South Africa during summer or during winter. The warm front never affects the weather of South Africa. Why? Because it is always further south. So it is further south during winter. It is even further or furthest during summer. So it never affects. So it's a common examination question. They can ask you between these two fronts, which front never affects the weather of South Africa. You must know the front that never affects the weather of South Africa, it is the warm front. The reason that it is further south every time. Now, our next, the weather station model at X, we said it is in the warm sector. Why warm sector? Because it is found behind the warm front. Then the temperature in Lesotho will be mostly probably be high. Why will the temperature in Lesotho be high? Here is our Lesotho here. Why will the temperatures be high? Because we said temperature and pressure are inversely proportional. And the letters that you see here, the L and H, are representing pressure. So when you see L, it shows low pressure. And low pressure is created because the air is warm and it is rising. So here, the temperatures here will be warm because you see the pressure being low. The area of constant pressure between two highs and two lows at W. So we're looking at this W here. We're looking at this W here. Then we say the pressure, the area of constant pressure between two highs and two lows here. This is what we call a saddle. The area between two constant pressure is called a saddle. So which means now you have your high pressure that side, you have your high pressure this side. The area between these two high pressure cells is called a saddle. And the pressure cell found at U is the U. The pressure found at U. So here is the pressure found at U. I believe you studied your high pressure cells. So you have this one over here. You have the other high pressure here. So what will be the pressure cell then? It is the South Atlantic because it is found in the Atlantic Ocean. And then the next question, the pressure reading at the cut-off low in Mozambique is HPA. What HPA? Is it 10, or is it 1008? So what do? You go there, you say this Mozambique, the isobar is not given. So it is given here. But what you should know is that the difference from one isobar, what is an isobar? Is a line that joins places with the same atmospheric pressure. So difference between one isobar to another is 4 millibars. So when you go there, you're going to say 10, 12 minus 4, then this one is going to become 1008. That's how you get to that 1008. And then you could do the same if they ask you what is the air pressure at any, okay, you can see here this is a low pressure and the pressure here is 1600 millibars. And then because this is a low pressure, it means when you move away, the pressure will increase. But this one is a high pressure, meaning that when you move away from U, the pressure will increase. When you move away from U, you're moving outwards, the pressure will increase because this is a center of higher pressure. So it's 1020, it will be 1024. So it will increase like that when you move away from high pressure. But you must know it will increase by 4 millibars or 4 hectopascals. So what is the correct answer there? Is 1008. The wind direction from U to X will most likely be in which direction? So this is the direction from U to X. From U to X, what is this direction? So it's an easy direction. It's a grade 10 content. It's simple. a map direction. So the direction there will be to southeasterly direction. The direction is in the southeasterly direction. Okay, now let's go to the next short objective question. This is Eben Heat Island. These are the questions on Eben Heat Island. It says here, evapotranspiration is dash in the rural area because open spaces reflect dash energy out to space. So it means now evapotranspiration in is it low or is it high? Is it solar or is it terrestrial? So you have to mix these ones. Now, what is the correct answer there? The evapotranspiration is higher in rural areas because open spaces reflect solar energy into outer spaces. And now, cities experience less wind circulation because, number one, remember tropical cyclones. Why do tropical cyclones die over the land? Because of high friction. So what do tall buildings do? Tall buildings reduce the wind speed. So the cities experience less wind circulation because of the tall buildings. So there is less wind circulation there. It is not because buildings have more glass. More glass will influence Eben Heat Island. It is not because buildings are of darker materials. Darker material will also favor Eben Heat Island, and therefore, because dark material absorb heat, and then buildings are built of concrete, it will also favor the development of Eben Heat Island. So the only answer here that is going to influence the wind circulation will be tall buildings. All these other factors are factors that influence the development of Eben Heat Island. Let's go to the next question. This is not a reason for the development of the heat island. Number one, we have artificial surface. No, artificial surface does contribute to that. Artificial source of heat does contribute to heat. Density of buildings, yes, it does contribute to Eben Heat Island because it provides larger absorption area. So which one is incorrect is the slope aspect. It doesn't matter where the sun is coming from. It doesn't matter. Remember, slope aspect refers to the direction to which the slope is facing. So this is not a reason for the development of the heat island. It doesn't matter where the slope is facing to. So all these other factors favors. All these other factors favors the development of heat island. There's only one that does not favor the development of Eben Heat Island, which is the slope aspect. And then they say the pressure gradient that exists between the rural area and the city is mainly because. Now, this is an important question because you speak of pressure gradient. So you need to define what is pressure gradient. Then HP minus LP is equals to PG. So what do I mean by that? I say high pressure minus low pressure is equals to pressure gradient. So which means now the pressure gradient that exists. So when speaking of the pressure gradient, we're referring to that there is high pressure somewhere and there is low pressure somewhere, and that results in pressure gradient. So pressure gradient simply means the difference between high pressure and low pressure. So they say the pressure gradient that exists between the rural area and the city is mainly because the first answer is there is high pressure in the city. Now you ask yourself, why will there be high pressure in the city? What is the difference between cities and rural areas? Cities are warmer. So because they are warmer, the air rises. Because the air is rising in the city, so it means there is no high pressure in the city. The pressure is lower. So this one is going to fall out because of low pressure in the rural area. Now you're saying, what creates low pressure? Low pressure is created by high temperatures. Now, are temperatures low in urban areas? No. Remember, we're talking about Eben Heat Island. So when you define Eben Heat Island, you're saying the warmer urban area than its surrounding rural areas. So which means now the rural areas must be cooler. So if the rural areas are cool, it means they cannot have low pressure. Because they are cool, the air is heavy, so the air is sinking. So this one cannot be the correct one. Now the next one says high pressure in the rural area. Now, high pressure, what will create high pressure in the rural area is because the air is cooler. So the air is subsiding. So this is the correct one. Now this one says high temperature in rural area. No. Now, why are rural areas not cooler? Because in rural areas, there's less industrial activities. There's low building density. There is a lot of short buildings. There's natural surfaces. So the rural areas are cooler. So this one says high temperatures in rural areas. So this one is incorrect because rural areas have got lower temperatures because of the natural surfaces, because of open water masses, because of the trees that are absorbing heat. So rural areas are cooler. So because rural areas are cooler, they are going to have high pressure. Then the air will be blowing from rural areas to urban areas. So high pressure in rural areas and low pressure in urban areas. So the correct one here will be number C. Now, let's look at this other one. The dash is or are responsible for the reduced insolation in the city. So what is this statement telling us? That there is less insolation, there is less solar energy that is able to reach the city. So now, when you look up here, you can see a line there. You can see a line there of pollution dome. You can see the line that represents pollution dome. What is pollution dome, by the way? It is the polluted air in or around the city, but it is a concept. It is a concept you can define in any way. You can say a parcel of polluted air in the city. It can be defined in a number of ways. So the area responsible for the reduced insolation in the city, can it be pollution dome? Can it be tall buildings? Will tall buildings reduce insolation? How will they do that? Can the sun reduce insolation? The sun is the source of insolation. Can reflection be the source of reduced insolation? What will be the correct answer? The pollution dome. So this is the pollution dome. So the sun's rays are bouncing off the pollution dome, and therefore they reduce insolation in the city. And then the pollution dome expands during the day mainly. So what does it mean? It means now the shape of the pollution dome. The shape of the pollution dome during the day will be a little bit higher. The shape of pollution dome during the day, it will expand during the day and it will go lower during the night. So the question is, the pollution dome expands during the day mainly because of more human activities, cloud cover, heat islands, or evaporation. So why will temperatures be higher and make this pollution dome to go higher during the night, during the day? It is because of more human activities. The main cause of the dome in the diagram above. So this is the diagram above. What is the main cause of this pollution dome? Now we're looking at reflection, we're looking at air circulation, we're looking at ebb and flow, we're looking at solar radiation, we're looking at reflection, we're looking at infrared, we're looking at dome dust. So the main cause of the dome. So what is causing pollution? So pollution dome, remember we're talking about polluted air in the city. So of all these answers, what is pollution? Which one create pollution here? So the answer becomes dust. That's the main cause of pollution here. The dust is the one that is causing pollution here. Okay, let's move on to the next question. This is another short objective question. The climatic phenomenon represented by AB is the katabatic or moisture front. This is your line AB. What is this line AB? It is a moisture front. So moisture front, you need to define what is a moisture front. Is a line that separates warm, moist air from cold, dry air. So this is your warm, moist air from the Atlantic Ocean, and this is your cold, dry air from the South Atlantic Ocean. So this is your moisture front. The reason or the season represented in the figure is winter or summer. What is a line thunderstorm? What is the moisture front going to do? Is going to give us line thunderstorm. During which season do we receive line thunderstorm? Or during which season do we experience this heavy rainfall? We experience this heavy rainfall during summer. So the correct answer there will be summer. It says line AB indicates a ridge or a trough. Now you need to know the difference between a ridge and a trough. Now, what is this? This is a low pressure, and the low pressure is extended. So an extended low pressure, a trough is an extended low pressure. Low pressure is a trough. Once it is extended like this, it's called a trough. Now, this one over here is a high pressure. So once the high pressure becomes longer like that, or it is extended like that, what do you call it? We call it a ridge. So now you know two concepts here. You know what is a ridge. A ridge is an extended high pressure, and you know what is a trough. A trough is an extended low pressure. So what is the correct one now? The line thunderstorm occur along the trough line. So this line thunderstorm, this moisture front here is a trough line, because the reason why we have clouds is because the air is rising, and the air will only rise when the temperatures are high. And then this is going to result in what you call trough line. This is a trough line, and it occurs during summer. And then the air mass at D is influenced by here is your D, is influenced by the warm Mozambique or cold Benguela current. It is influenced, okay, I think I skipped 1.1.4, I'm sorry. At C, there is cold and dry, warm air, cold and dry, or warm and moist. At C, here is your C. So this is Atlantic Ocean, influenced by the cold Benguela current. So the air here is cold and dry. The air mass at D is influenced by the warm Mozambique current or cold Benguela current. This is grade 10 syllabus. So you know the ocean current on the east will be the warm Mozambique current. Air mass C. Air mass C. Here is the air mass at C. Undercuts or overrides. So undercuts meaning that it goes underneath, or override meaning that it goes on top. Air mass D along the AB, which is the moisture front. This line over here is called the moisture front. This trough line is called a moisture front. This trough line over here is your moisture front. So the question is, the air mass at C is going to undercut. Now you need to know the characteristics of this air mass. This air mass is cold and dry. So it's cold and dry, therefore it's denser. So what will be the answer there? The answer for this question will be, it is going to undercut. It's going to go beneath. It is going to go beneath because it is heavier. This one over here on the east is warmer, so it will override. It is the one that's going to go above. Now, the air at D originates from the South Atlantic or Indian Ocean. At D, is it South Atlantic or Indian Ocean? It comes from the Indian Ocean. And lastly, the common type of precipitation east of line AB will be advection or a thunderstorm. So on the east of moisture front, this is where you're going to get this line thunderstorm. This is where you're going to get the line thunderstorm on the east of the moisture front. So the common type of precipitation east of the line AB will be line thunderstorm. And why? Why are we getting line thunderstorm on the east? Because on the east, the air is warmer. Because the air is warmer, it rises, and it rises rapidly. And because the air rises rapidly, it condenses. On the east, the air rises, it rises rapidly, and it rises higher. resulting in the development of cumulonimbus cloud, the CB clouds. And then what is the weather associated with cumulonimbus clouds? It is heavy rainfall and thunderstorm. Weather associated with cumulonimbus cloud is heavy rainfall and thunderstorm. So because the air on the east is going to rise rapidly, and after rising rapidly is going to rise even higher, is going to result in the clouds that have vertical extension. The clouds that have got vertical extension and that are heavily laden with moisture. They've got a lot of moisture, and then therefore is going to result in the development of thunderstorms and heavy rainfall on the east of the moisture front. Now, let's look at the long questions here. The first long question that I want us to quickly look at is the tropical cyclone here. State one condition that are required for the development of tropical cyclone. Give two pieces of evidence from the sketch to indicate that the tropical cyclone is in the mature stage. Now, let's look at the first question. State one condition required for the development of tropical cyclone. So, what is it that tropical cyclones need? Tropical cyclones need the temperatures of 27 degrees and above, plus 27 degrees temperatures above. But it must not just be temperatures of 27 degrees and above. It must be ocean temperatures, because it doesn't matter what temperatures are. So long as they are not on the ocean or in the ocean, that will not favor the development of tropical cyclone. It must be surface water temperatures or ocean temperatures of 27 degrees and above, not just temperatures of 27 degrees and above. And number one. Number two, what do tropical cyclones need to develop before 27 degrees temperatures and above? They also need Coriolis force. They need Coriolis force because Coriolis force is the one that results in the rotation of the winds. They need Coriolis force. And then they also need high level of evaporation. What is the importance of high level of evaporation? Is to create low pressure or create intensive low pressure, because the air is rising. Now the pressure is getting lower and lower. And then where will this tropical cyclone get their energy from? They will get their energy from latent heat. So those are the conditions that are necessary or that are required for the development of tropical cyclone. You said 27 degrees Celsius and above, but ocean temperatures of 27 degrees and above, they also require what? Tropical cyclones also require Coriolis force. Coriolis force. What is the importance of Coriolis force? Is for the air to be able to rotate or to spin. And then also it requires high level of evaporation. What is the importance of evaporation? Evaporation, remember, is going to result in low pressure or intense low pressure created on the surface. And again, this is the low pressure, that is the evaporation that will further result in the release of latent heat to the tropical cyclone as the energy source for the tropical cyclone. Because the tropical cyclone needs energy. And where does tropical cyclone get their energy from? From the latent heat. Give two pieces of evidence from the sketch to indicate that the tropical cyclone is in a mature stage. How do you tell that this tropical cyclone is in a mature stage? Number one, you can see it has got an eye. It is well developed here. You can see from the cross section. You can also see from the sketch here that it has got an eye. That's number one. Give pieces of evidence from the sketch to indicate that the tropical cyclone is in the mature stage. So you can see there is an eye there to indicate that it's in a mature stage. It's clearly visible there. It is clearly visible also in the cross section. What else can you see there? What else can you see there? You can see the pressure, which is below 1000. The pressure is below 1000. So the pressure in the center here is 970. Is 970. So the isobaric interval in this case, it is it is 2 millibars. In this case, the isobaric interval here is 2 millibars. So the pressure in the center there will be 970 millibars or hectopascal. So it's indicating that the tropical cyclone is in a mature stage. What is the evidence? This is the evidence. And then again, it is important that sometimes the examiner can ask you to draw a symbol to represent the eye of the tropical cyclone. You see, that is the eye of the tropical cyclone. That is the eye of the tropical cyclone. This is the symbol for the eye of the tropical cyclone. It must be represented like that. Give a reason. Okay, what influence will subsiding air at A have on the cloud cover in the eye? So if the air is subsiding here in the eye, what influence will the subsiding air at the eye have on the cloud cover in the eye? So what are the conditions in the eye of a tropical cyclone? Number one, the conditions is that there is clear skies. It's clear skies. Why do we have clear skies in the eye of a tropical cyclone? Because of the subsiding air. So subsiding air will not condense because subsiding air is heated adiabatically. So the adiabatic heating that we experience when we're talking about air, it will occur when we're talking about, number one, the berg winds. The berg winds, why are berg winds hot and dry? Berg winds are hot and dry because they are heated adiabatically, meaning that as the air descends, it is heated. So during the occurrence of berg winds, do we have clouds? We don't have clouds. So it's the same condition. That is the same condition with the eye of the tropical cyclone. In the eye of the tropical cyclone, the air is subsiding. So a subsiding air is heated, and because the air is heated, there is no condensation. So I'm bringing these two concepts together because now we are doing revision. We have already done berg winds. We know they are hot and dry winds. Why are they hot and dry? Because the air is subsiding. Now, what's happening with the subsiding air? The subsiding air is heated. So those conditions are the same in the eye of a tropical cyclone and also with the berg winds. The air is subsiding, and what is the behavior of subsiding air? It is heated. And now when the air is heated, there is no cloud formation because the air is not going to condense. The air will only condense when it rises. And rising air is going to cool. And then the cooling is the one that is going to result in condensation. But the subsiding results in heating. Rising results in cooling. So I hope you understand why we are going to have I hope you understand what will be the influence of subsiding air in the eye of the tropical cyclone. It's going to result in clear skies, and then other conditions that we are going to get in the tropical cyclone's eye is that there is no precipitation. You cannot expect precipitation without clouds. And then another condition that you'll get in the eye of a tropical cyclone is that it's going to be calm condition. The conditions will be calm in the eye because this is what we call the eye wall. These cumulonimbus clouds here, they form what we call the eye wall. Because of the eye wall, the strong winds cannot go through the eye. The strong winds cannot go through the eye. That is why one of the conditions is that it is calm or wind still. It is calm or wind still in the eye of the tropical cyclone is because of the strong cumulonimbus clouds or thick cumulonimbus clouds that stops the wind from blowing into the eye. So you know the conditions in the eye, you know it's clear skies. Why clear skies? Because the air is subsiding. Subsiding air will not condense. That is okay. I've already given the reason why we are going to have clear skies. We're going to have clear skies because the air is subsiding, and because the air is subsiding, the air is going to be heated, and when the air is heated, that air is not going to condense. That is why we don't have clouds in the eye of the tropical cyclone. Now, indicate the relationship between the wind speed and air pressure as indicated by the graph above. This is our graph above, and then this point over here will be at the eye of a tropical cyclone. Now, what are we looking at here? We're looking ahead of the eye, before this eye comes. So ahead of the eye will be at this point. Ahead of the eye will be at this point. So ahead of the eye, wind speed will be high and the air pressure will be low, because you can see the air is rising there. You can see the air is rising there. It shows that there is it shows that the pressure is low here because the air is rising. So ahead of the eye, we are going to have high wind speed and we are going to have low pressure. And then within an eye, what's going to happen within an eye? Because the air is subsiding, it creates high pressure. And within the eye, because of this cumulonimbus clouds that stop the air from blowing in, we are going to have a very low wind speed. There is calm condition in the eye of the tropical cyclone. And now the next question, last question of the tropical cyclone says here, how does the leading or left quadrant dangerous semicircle develop in the tropical cyclone? The tropical cyclone is moving from east to west. Why does it move from east to west? It is driven by the tropical easterlies. Tropical cyclones are not driven by the easterlies. They are driven by the tropical easterlies. You cannot give an answer that says easterlies because, number one, we have two sets of easterlies in our circulation. We have polar easterlies and tropical easterlies. So the answer has to be specific. It must be tropical easterlies. Now, this is the general direction of the storm from east to west because they are driven by tropical easterlies. And now when you're looking at the circulation of air here, it is also from east to west. The air circulation, remember this is a clockwise circulation. The air is circulating in a clockwise direction. So because of this clockwise circulation, at this point, the circulation is to the east. At this point, the circulation is to the east and the general direction is to the east. So that is how the dangerous semicircle develops. How does the leading or left quadrant dangerous semicircle develop? It develops when the general direction and the circulation direction are the same. The general direction from east to west and the circulation direction are also from east to west are the same. General direction are the same as circulation, east to west. So that is when the tropical cyclone is going to have that dangerous semicircle. So these are the answers that we spoke. Now we're looking at other source-based question. This is representation of the summer condition. Now, what is the question? The first question says, identify one factor in sketch A that influences the weather of South Africa. So this is sketch A. So what is influencing the weather of South Africa here? It is South Atlantic, it is Kalahari high pressure, it is South Indian, it is cold Benguela current, it is warm Mozambique. That's not even a question. This was just a teaser. It's so easy. You just look at any of the factors here and you get a free mark here. And now next question, how would the position of the South Atlantic high pressure influence the moisture content of the air reaching the east coast of South Africa in summer? How would the position of the South Indian high pressure influence the moisture content of the air reaching the east? Now, the South, now what has happened now with the high pressure? The high pressures, remember we said they are following this high pressure cells, they are following the migration of the ITCZ. So when it is summer, they move further south, and then when it is winter, they move further north. They move in this direction. They move further south and north according to different seasons. And then Kalahari high pressure does not move south and north, it moves up and down. So it is higher during summer and it is lower during winter. This Kalahari high pressure. It moves up and down. This one move north and south. So the question is, how would the position of the South Indian high pressure influence the moisture content of the air reaching the east coast of South Africa in summer? So what does it mean now? It means during summer, the South Atlantic high pressure is further south, and therefore is going to allow warm moist air to enter the interior, and this warm moist air in the interior will now condense because it's going to rise and cool. After condensing, it's going to result in the cloud, and the clouds will result in precipitation. So how would the position of the South Indian high pressure influence the moisture content of the air reaching the east coast of South Africa? What do you say in summer? Saying that because the South Indian high pressure is further south, it allows the warm moist air to go into the interior, and therefore it allows warm moist air to come into the interior. Why is the Kalahari high pressure weakly developed over the land in summer? This is your Kalahari high pressure. Now you can see the inversion layer is above the escarpment here. Why is this the case? It's because the Kalahari high pressure is higher in the atmosphere. And then why is Kalahari high pressure higher in the atmosphere? Because there is strong convection. There is strong convection. So there is a lot of rising warm air, convection or vertical movement of air. So the question says, why is the Kalahari high pressure weakly developed over the land in summer? It is because, number one, we have strong convection. There is more rising air. And now the question can be opposite. It can say, why is the Kalahari high pressure weaker or stronger during winter? Why is it stronger during winter? It is stronger during winter. So you can just change this and say, okay, here this one is saying weaker. You can change the question and say, put the opposite of that question, say, why is it stronger during winter? Then change summer to winter. Then it is stronger during winter because there is strong subsidence. There is strong subsidence. Remember now we're saying there is strong convection during summer, and during winter there will be strong subsidence. And then this during winter will mean now, because of strong subsidence, the inversion layer, this inversion layer will move below the escarpment, and trap warm moist air. So this one indicates a weaker Kalahari high pressure. This one will indicate a stronger Kalahari high pressure. So this is what will happen for different seasons. And this layer, remember, we call it the inversion layer. This layer is called inversion layer. It's called inversion layer because it is at the plateau. If it was in the valley, we will call it thermal belt, but it indicates temperature inversion, which the increase of temperature with height. The increase of temperature with height. So many times learners confuse the concept inversion layer and thermal belt. You only get the thermal belt. You only get the thermal belt in the valley. You get the thermal belt in the valley, but at the plateau, here you get inversion layer. Though they are same, they cannot be called with the same name. They cannot be called with the same name because even though they are both indicating the increase of temperature with height, which is temperature inversion. Temperature inversion is the increase of temperature with height. You will see here temperature inversion in the plateau here because of the weak and strong Kalahari high pressure. You'll also get that in the valley, but you cannot use the two concepts interchangeably. Inversion layer remains at the plateau and the thermal belt remains in the valley. That's how you should know them. Now, how does the weakly developed Kalahari high pressure cell influence the presence of the inversion layer in sketch B? How does the weakly developed Kalahari high pressure cell influence the presence of the inversion layer in sketch B? This is our sketch B. How does the weak inversion influence the presence? Weak Kalahari high pressure. Now, how does it influence it? The inversion layer is above the escarpment. So you can ask that question in opposite direction and say, how does the strong Kalahari high pressure influence the position of the inversion layer? You can say it goes below the escarpment. But for this question here, it says, how does the weakly developed Kalahari high pressure cell influence the presence of the inversion layer? Now you see the inversion layer is above the escarpment. So if you ask this question in opposite and you say, how does the strong, you see, how does the strong developed Kalahari high pressure cell influence the presence of inversion layer in sketch, whatever sketch, or in winter, you say it goes below the escarpment. Okay, I am not going to just go through the questions that are asked here. I'm going to go through possible ways in which these questions can be asked so that you are better prepared for your paper. Now, the next question says, in a paragraph of approximately 8 lines, explain how the position of the inversion layer will bring overcast and unstable weather conditions over the interior of the country in summer. In a paragraph of approximately 8 lines, now you are stated how long must the paragraph be. But we said the length is not so key to the to this question. What is more key to the question is that you must look at the allocation of marks. The question wants you to give 4 answers. So it says, explain how the position of the inversion layer will bring overcast and unstable weather conditions over the interior of the country in summer. So there is a weak subsidence of air over the plateau. There's going to be weak subsidence over the plateau, number 1, and the land is going to heat up excessively over the central interior. The warm moist air from the warm Mozambique current will reach from the South Indian up the escarpment, and the warm moist air will reach the interior of the country because the inversion layer is above the plateau. There is lots of cloud formation. There's going to be widespread of rainfall during summer. So in a paragraph of approximately 8 lines, how the position of the inversion layer. Okay, now it's very important that you are able to respond. It's very important that you are able to respond to this question for both summer and winter. What will happen during summer? The inversion layer is above the escarpment. Warm moist air goes into the interior. Warm moist air condenses cloud formation. Cloud formation is going to result in precipitation during summer. But during winter, the inversion layer is below the escarpment. And when the inversion layer is below the escarpment, warm moist air cannot go into the interior. If the warm moist air cannot go into the interior, there's no condensation. It's going to result in the stable conditions. But here we're talking about the unstable condition, indicating that the air is rising. But for winter, we're going to have stable conditions, meaning that the air is denser and it's sitting on the ground. It's not going anywhere. Now, let's quickly run to geomorphology. Let's quickly run to geomorphology questions and see what questions we have here. Okay. In introduction to geomorphology here, we simply have what we call water cycle. You can see precipitation is there, and you must know how to define precipitation. And then vegetation, you have transpiration, you have surface runoff, you have infiltration. So infiltration is simply referring to the absorption of water by the surface. And that's your percolation of water there. And through flow is the flow of water beneath the surface. That's what you get there. And groundwater is the water found beneath the earth's surface. River discharge refer to the volume of water as it passes a specific point at a specific time. So this is just an icebreaker to our geomorphology here, this water cycle. Let's look at the questions here. High-lying area that separates two drainage basins is known as the watershed. Point where two or more streams meet is known as the confluence. So easily, if you're looking at two streams, your confluence will be this point here, where this point over here will be your confluence, because you have this stream that is flowing into this stream. So this point over here will be your confluence, because that's where two streams meet. So any point where two streams are meeting, that point is called a confluence. Okay, and then a watershed is high-lying area that separates two drainage basins. Here we have an interfluve. So what does an interfluve do? If you have a drainage basin like this, and a drainage basin with the streams, this is one drainage basin with streams. So between the streams within one drainage basin, this is what you're going to get, an interfluve. But if you have one drainage basin here and another drainage basin next to it there, so the two drainage basins are separated by the watershed. Point when two or streams meet, we already said that it is confluence. Point where the river enters the sea is known as the mouth. But you should not say mouth, just like you could not say elbow when you're talking about river capture. It is not elbow, but it is elbow of capture. And also here you must be very aware, it must be river mouth, because it's not just any mouth, it's a river mouth. And then the elbow of capture, the point where river join or river diverts headwaters of another river, or a stronger, more energetic river diverts headwaters of another less energetic river. That point is not called an elbow. It's called an elbow of capture. Just like here, this is not necessarily a simple mouth, it's a river mouth. The upper limit of groundwater. Now, where do we go here? We go to the upper limit of groundwater. So if you have groundwater here, so this part of groundwater here, this part of groundwater will be the part that is on top here, the top part of groundwater. This is what we now call water table. This top part of the saturated. So this top part over here, this is what you call water table. The top surface of groundwater is called water table. And now the process, okay, base flow. Let me quickly go to base flow. I didn't look at base flow here. So this is what we call base flow, when water is flowing beneath the earth surface. When the water is flowing beneath the earth surface, we call that base flow. And then runoff is when the water is flowing on the surface. Infiltration, the process whereby water seeps under the ground, or the process where water is absorbed by the surface, we call that infiltration. The area drained by a river and its tributary is called the drainage basin. And then what you call the river and its tributary, we call it the area drained by the river system. So you can say it a river and its tributary, or you can say river system. The area that's drained by the river system is called drainage basin. So the river and its tributaries, they are together called a river system. A river that originates in areas of high rainfall but flows through dry area is known as the exotic river. So what is an exotic river? It's a river that has got the source in the highest, in the upper course of that particular river. There's high rainfall. But as that river flows lower, it flows past a dry area or a semi-arid area. So when that river passes through that point, it is known as exotic river. Now let's quickly go through these short questions on drainage patterns. Tributaries join the main river at right angle. Which one has a main river joining at right angle? So both of these A and B. So that question will be for both. So this, when you're naming this will be a trellis pattern, and this one will be rectangular pattern. So the rectangular pattern, tributaries join the main river at right angles. So it's got characteristics of both. So trellis pattern, the tributaries join at right angle, and also with the rectangular pattern, the tributaries join at right angle. So both A and B will be correct here. There are right angle bends along the course of the main river. So this will refer to B. The pattern occurs in folded mountains. So this one will be A, which is trellis pattern, and then developed in areas where faults occur parallel to each other. So it will refer to the rectangular pattern. So when you're looking at the underlying rock for a rectangular pattern, you say it is found in the rocks that have got faults or jointed igneous rocks. This is your this one will be your B, where there are faults or there are joints developed in areas where the faults occur parallel to each other. So this one over here, so there's a fault parallel to each other here. This one over here will be your fault. So long as you see the word faults there, the faults are parallel to each other, that one will be B. Tributaries are short, so your tributaries here are your short tributaries here. So this will be your A, your trellis pattern. Tributaries often flow from gaps or pores. So if the tributaries are joining from gaps or pores, so it will form on this trellis pattern. Now let's go to the next question. Short objective questions. Short objective questions. Now let's look at this river profile. The longitudinal profile in a diagram represents, so this is telling you that this is a longitudinal profile. So now what is a longitudinal profile? It is a view of the river from this point that we call the source of the river, where the river originates, and the point where the river enters the sea, which is called the river mouth. So because you are looking at the river from that point to that point, we call it what? A longitudinal profile. Is the review of the river from the source to the mouth. We call it a longitudinal profile. So they're saying this longitudinal profile of the river represented here is graded or ungraded. Now you're looking at the characteristics of the river here. What is the correct answer there? It is ungraded. So why do we say this river is ungraded? Because it has got nick points. Because there's a nick point, which is a waterfall there, and it is uneven. The river profile there is uneven, so it is ungraded. The river course indicated by X on the longitudinal profile is there. At X, this point X here, what is it called? Is it upper or middle? So it is still upper course there. This will be the upper course of the river. Erosion is dominant erosion at X. So where is our X? This is our X. Because it is in the upper course, what type of erosion is dominant there? It is vertical erosion that is dominant in the upper course. And then why do we have dominant vertical erosion in the upper course? Because in the upper course, the gradient is steep, and therefore there's going to be vertical erosion. And then the sharp drop in gradient indicated at B on the diagram is known as A. So here there's a sharp change here in the gradient. It's called a what? A waterfall. So this is a definition of what we call a nick point. This is a definition of what we call a nick point. What is a nick point? Is when there is a sudden change in the gradient of the river. Where there is a sudden change in the gradient of the river. Now 2.1.5 headward or vertical erosion may result in the removal of the temporary base level of erosion. Which one is that? Is headward erosion. After the removal of the temporary base level at B, the river profile will have what shape? After this temporary is being removed, now the river is going to be flowing here. What will be the shape? What will be the shape here? The shape there will be a convex. Not convex, I'm sorry. Convex will be bending outward. So this one will be a concave. After the removal of the temporary base level. So after all this are removed, now the river will have a concave profile, and now it will change from being ungraded to being graded. It will change from being ungraded because it's going to have a concave profile, and once it is now concave, smooth concave profile, it is now going to change from being ungraded to be graded. So what do we mean when we say it is graded? It will be in a state of equilibrium. There's going to be equilibrium. Let me write it here. Equilibrium. What do you mean when you say it's going to be in a state of equilibrium? It means there's going to be a balance between erosion and deposition. Right now, in this stage, the question said the dominant erosion. So it means there is a dominant erosion in this. So the dominant process in this river is erosion. The dominant process in this river is erosion, especially in this part, because there are still obstacles, there are still weak points there. So the river is trying to remove them. But once this is removed, there is not going to be any dominant process. The river will be in a state of balance between erosion and deposition. And we say that the river is in equilibrium. And now, because it's in equilibrium, it's going to take a concave shape because the river will have been graded. Now, the flow is predominant on the slope of the river profile indicated as S. Now, what is the stage here at S? The stage at S here is called lower course. It's at the lower course because you can see this is where the river is joining the sea, and then you can see already here the river is already winding, and as the river winds, that process is called meandering. The river is meandering there, and then it indicates that there's a lower course. And then what will be the dominant flow is predominant here. So this is what we call a laminar flow. This is what we call a laminar flow. And then that is when a river is flowing in sheets that are separate from each other. There's no mixing of water at this stage. The river is flowing on separate sheets. That's when we call that process a laminar flow. Why is the river flowing in that kind of form? Why do we have laminar flow? Because the gradient is, the riverbed is smooth. So because of the smooth riverbed, there are no turbulences. So the river is flowing very smooth here. But when you look at here, at Z here, this will be the type of flow that is called turbulent flow. And this kind of river flow will take place in the upper course where there are weak points and there are waterfalls, there are rapids. So at this stage, the river will flow in a turbulent flow. But at this stage where it is smooth, it's going to have a laminar flow. And how do you define that laminar flow? Is when the river is flowing in separate sheets. It flows in separate sheets that are not touching each other. So you can see there, you have the flow there, you have the flow. So it goes like that. So it's indicating that there is no disturbances to water. But at this stage, at Z, you can see the water is bouncing up and down. So there's a high chances of this water layers mixing with each other because of the uneven gradient. And then it will happen in the upper course, but the laminar flow, you will get it in the lower course. Now, what we have here, we have drainage basins that have got different densities. The first question is explain the concept drainage density. So when talking of density, we're simply referring total length of streams divided by total length of streams divided by the area drained by those streams. So what evidence indicate that sketch A has higher drainage density? Why do we say A has higher density? There are many tributaries. There are many tributaries here. And then determine the stream order at X in the sketch A. So how do you determine that? You say this is 1 and 1. 1 and 1, they're going to make 2. This is 1 and 2. They're going to remain at 2. This is 1 and 1. They're going to make 2. So you have 1 and 2. It remains at 2. Then you have 2 and 2 is going to result in 3. So determining the stream order at X will be stream order number 3. Stream order number 3. So as we speak of this order, okay, we'll talk about that. Let's finish these questions. Explain the influence of gradient or slope on drainage density. How does the gradient influence density? Now, the gradient and density, they are, if the gradient is steep, there's going to be high surface runoff, and because of high surface runoff, the density is going to be high. But if the gradient is gentle, there's going to be more infiltration and less runoff, and therefore it's going to be low density. Now, if we're looking at sketch A and sketch B, where do we have a steeper gradient? We have steeper gradient at B. Why do we say steeper gradient at B? Because there are more tributaries, which means there is more water flowing than at A. At A, there is more water infiltrating. That is why we have lower drainage density at A, because of the gentle gradient. Remember, now we're looking at the factors that influence drainage density. Factors that influence drainage density. Here we are given one, which is gradient. We also have vegetation. So now, if we're looking at this, looking at vegetation, which area will have more vegetation? A will have more vegetation, because vegetation is going to result in more infiltration. More infiltration is going to result in low drainage density. Then at B, it means now we have low vegetation. At B, we have low vegetation. That is why there is more surface runoff. And another factor that will influence drainage density will be also type of precipitation. So what do we mean here? It means that at X, or here at A, the type of precipitation here is soft rain. So soft rain results in more infiltration and less runoff. But here at B, it is heavy rainfall. Therefore, it's going to result in more runoff, which results in higher density. And you can also look at another factor. It will be soil moisture. Which of the two soils here, soil moisture, which of the two, at A or B, where do we have more soil moisture? At A, there is less soil moisture, which means the surface at A is dry. Because it is dry, more water infiltrates. But at B, it is saturated. Because it is saturated, it allows less water to infiltrate. So most of the water is going to flow on the surface. And another factor that we can look at that will change this density will be porosity and permeability. It will be porosity and permeability. So what's happening here? Porosity. What is porosity? It's pore spaces per unit area. So it means at A, there are more pore spaces. And if you can look at the type of surface at A, you can say at A, we have sand. And now because of sand, there is more infiltration and less runoff, and therefore it resulted in A having a low drainage density. And at B, you can say we have clay soil here. You can say we have clay soil here, and here we have sand soil or sandy soil. So here we have clay soil. Because of clay soil, there's going to be low porosity. Because of low porosity, there's going to be low permeability. So porosity influences permeability. So clay soil is less porous and it is also less permeable. Because it is less permeable, then it's going to result in high infiltration. It's going to result in high runoff and less infiltration, and therefore is going to have higher drainage density. So those are some of the factors that are going to influence. So now, porosity and permeability will also influence drainage density. So at A, the surface is highly porous and highly permeable, resulting in more infiltration and less runoff. But at B, the clay soil is less porous, or it has got less porosity, and therefore it is less permeable. That is why we have what? More runoff. How do you tell there's more runoff? Because the density is high. How do you tell that there's low density? How do you tell this area is high permeable? It's highly permeable because there is more water infiltrating and there's less water flowing. Okay, now let's move. We have looked at the factors that influence the drainage density. Now let's go into drainage pattern in sketch B. Drainage pattern in sketch B and sketch A are the same. The drainage pattern here is the same. It's different in terms of density. So the drainage pattern for A and B will be dendritic. How do you tell it is dendritic? Because it looks like the branches of a tree. It does not look like a tree. It looks like the branches of a tree. And then the tributaries join the mainstream at acute angle. Those are the characteristics of the dendritic pattern. And then those are the reasons. Identify the drainage pattern. We said, what is the pattern? Dendritic for both A and B. For both A and B. Because the difference between A and B is just density. But the shape is the same. Is dendritic pattern. So why do we say? Give a reason. Why do you say it's dendritic? Because it looks like the branches of the tree. And because, again, the tributaries join the mainstream at the acute angle. And then another reason that they can ask you, another question they can ask you is to describe the underlying rock. Then you say the underlying rock here is the rock with similar resistance. The rock with similar resistance to erosion, or the rock with same resistance. But when you quickly go back to this one, you can say this one, the underlying rock is soft and hard rock following each other. Here we said, here what we have for this pattern, we have jointed igneous rock. We have jointed igneous rock or igneous rock with faults or cracks. Here is folded mountains, but here with this one, here this one we say is a surface with a uniform resistance to erosion. Okay, let's move on to the next one. One of the most common examination questions will be river capture or stream piracy together with river rejuvenation. Now let's quickly look at this river capture questions. What evidence in sketch X indicates that the river capture is likely to take place? So what do you do here? You look at sketch X. So you see here is headward erosion. So what is headward erosion? Headward erosion. Remember, this water is flowing and going in this direction. So as this water is going in this direction, now the water erosion is taking place in this direction. backwards. So what is headward erosion? When the river erodes backwards, or when the river erodes towards the source. So it's eroding backwards. So what evidence in sketch X indicates that river capture is likely to take place? So what do? You look at here, you're saying headward erosion is taking place. Tributary of River A is cutting through the watershed. So this place over here is the watershed. So what is happening here? This tributary is cutting through the watershed. It is also important for you to know what do we call the process where the river is cutting through the watershed. That is called what you call abstraction. That process is called abstraction. So we have two processes here. We have one, headward erosion, where the river is eroding towards the source or backward, and abstraction is the lowering and the removal of the watershed, or is the retreat of the watershed. The lowering and the removal of the watershed is called abstraction. What could have caused the Captor stream to erode through the watershed? Why was this river able to cut through the watershed? Now, you need to know what are the factors that contribute to river rejuvenation. It's because what? It was flowing on a steeper gradient. It was flowing on a softer rock. Because of softer rock, it's going to be easily eroded. It is because of increased volume of water, because of increased rainfall. So this could be asked in a simple way, what are the causes of river capture? So one river must be flowing on a steeper gradient. It must also be flowing on a lower gradient. You can also add here, it is flowing on a lower gradient. It's on a lower lying area. It's also flowing on a lower lying area. Now, the next question. Identify features C and B of river capture in sketch 1. So where is river C? This is the point here, river C, and this is this point here. This is river D. So identify feature C. So C is the elbow of capture. This is not an elbow, it's an elbow of capture. And it's D is a misfit stream. It's a misfit stream. And now the question can ask you a question, what will happen to, or we can give characteristics of river D after river capture, or we can give the impacts of river capture on river D. So what will happen at D? River D will have less water. Because it has less water, there's going to be more deposition and less erosion. And then can also be asked a question to give the impacts or the implication it will have. And also when you're looking at river E, look at river E. What has happened to river E? River E has got increased in what you can see that it is thicker in color now compared to this one. So it means it has gained more water. Explain the process that resulted in the formation of feature D. Explain the process that resulted in the formation of feature D. What is feature D? The misfit stream. How did the misfit stream form? How did the misfit stream form? Number one, headwaters of the misfit stream was cut off by the Captor stream. So its headwater has been cut off. It continued to flow after the wind gap with reduced supply of water. So what has happened here is that this is the headwaters. Headwaters is the water that is flowing from the source. Now it has been diverted, it has taken another direction. So now this river has a shortage of water. Now, you can also give what will happen to the people that are living around here in terms of their activities. They're going to have less water for farming, less water for irrigation, for household. So those are type of questions that can be asked. It can be asked to give the impacts of this, the impacts to the people, or the impacts on the river themselves. So when they say what are the impacts, the physical impact on the rivers themselves, this river is going to have shortage of water, but this river is going to have high volume of water. Now let's look at the final question here. It says, in a paragraph of approximately 8 lines, describe how the increased volume of water will positively impact on the farming community at E. So how will the farming community be impacted here? Now there's going to be more water for irrigation, which means now at D there's less water for irrigation. There's going to be more water for livestock, increased yields due to the abundance of water, decrease in cost to obtain sufficient water for irrigation, so they don't have to spend more money because water is readily available. Increased flooding increases natural fertilization of soil. Input cost to farm decreases, so there's going to be less money spent. Farming now is economically viable. More jobs are created as more areas are put under cultivation. Increase in income as farming yields increases. Increase in domestic water. Increase in nutritional activities. Food security is secure since there is more access to food, more water for aquaculture. So this is the impacts to people. The question can also be, what is the physical impact, or what is the impact on the river? So now what's going to happen to the river? The river is going to have increased volume of water. The river is going to flow faster, increased velocity. The river is going to increase its vertical erosion. Then there's going to be less deposition because river has got more energy, and its carrying capacity will also increase. So here this question was looking for the impact to the people around, or the impact to the people living closer to the river. So this impact can also be on the rivers themselves. So you must be careful. That question can be asked in a number of ways. And again, you should be able, so many times you make a mistake because you give the characteristics of river E at river D. You must know which one has gained water and which one has lost water. So it's very important that you are able to look at those. What you have there, you have fluvial landforms. Identify the fluvial landform at A and B respectively. So when you're looking at this one fluvial landform here, this is your braided stream, and when you're looking at this one here, because you can see there's an ocean here, so B will become a delta. Where in the river will one find the fluvial landform at B? This fluvial landform, which is the delta. Where do you find the delta? At the mouth of the river. Where in the river will you find this? You find it at the mouth of the river or in the lower course of the river. Explain how the fluvial landform A is formed. How is landform A formed? How is stream is formed in the lower course of the river? So what is happening there? As the river is flowing, it deposits the material on its own course. It happened that there is deposition of sediments in the course of the river. Because it is in the lower course, the river is unable to cut through the deposit. So what does the river do? The river starts to wind around. The river starts to wind around the deposits. So when the river starts to flow or wind around the deposit, it's going to result in different channels or in number of channels, or the river is going to split in many channels. And as the river splits in many channels, this is going to result in the development of what we call braided streams. And then write a paragraph of not more than 8 lines and discuss the significance or the importance of fluvial landform at B. What is the fluvial landform at B? There's a number of importance of this, and now some of the factors, we can look at them as economic importance, you can look at them as social importance, and can also look at them as environmental importance. Let's look at the importance now of the deltas. They support biodiversity. It means now there's plants and animals that can be found there. It's a habitat for migratory birds that can be migrating from one place to another. They can live in the deltas. They are nursery grounds for marine life. They are natural barriers against storms and erosion. So because there's vegetation around the deltas, this vegetation will also reduce the wind speed. So it stops erosion and reduce the storm. So that's one of the reasons why the tropical cyclones will reduce their speed when they come through the land or over the land, because number one, they start with the friction from the deltas. And now, what will be the economic importance of deltas? Because of the fertile soil, it's good for agriculture. They also support fishing. They are also tourist attraction. The deltas can also be used for human settlements. They can also be used as historical and spiritual sites. People can go there to go and worship and do whatever their interest. And again, deltas are important for education and research. And you can see there, we are also talking about delta in our education system. So it means now it is also important for education and research. Now, let's quickly go through Mapwork activities. What are we going to look at here? So, we're going to look at gradient. So before you can know how to calculate gradient, you must know how height is represented on the map. Number one, height is represented through using of the contour lines. The contour lines there on the map. Number two, height is shown on the map through use of the trig station. What is important is the trig station. You must know trig station has got two numbers to it. It's got this full number or whole number 72. It represents that is trig station number 72. And also at the bottom, it's got a number that has got a decimal comma. It shows the height of that particular trig station. Height on the map can also be represented using spot heights. So this is your spot height. It's a spot plus a number. It's a dot and a number. So we call that a spot height. And then also we can use benchmark to represent height on the map. So this is a benchmark. You will usually find the benchmarks on the sides of the roads. Okay, now let's calculate vertical exaggeration first. The formula for vertical exaggeration is equals to vertical scale over horizontal scale. Vertical scale over horizontal scale. Now, your horizontal scale is always given. Your horizontal scale is always given. So when you calculate vertical exaggeration, you do vertical scale over horizontal scale, and you know your horizontal scale is always given on the map. But your vertical scale, what is your vertical scale? Your vertical scale is not given. You work out your vertical scale. How do you work your vertical scale? You look at your contour interval. And you must remember, your contour interval is always in meters. Your contour interval, height on the map is shown in meters. So your contour interval will also be in meters. Now, let's try to calculate, try to do a general calculation of vertical exaggeration. Now, if you calculate vertical exaggeration, now you have to know now your contour interval. You say now, how it is 20 meters. Your vertical scale is not given to you, but your horizontal scale is given to you. How do you work out your your vertical scale? You're saying now, because my vertical scale is not given, but what I know is that the vertical interval on the map is 20 meters. Then what do you say? You say, how many centimeters are there? How many centimeters are there in a meter? How many centimeters are there in 1 meter? Then you say there are 100 centimeters in a meter. Then you say now, which means now you have to get 100 centimeters in each meter, and you multiply that by 20 meters. Then you're going to get 2,000. Vertical exaggeration. What is the formula for vertical exaggeration? Vertical exaggeration is equals to vertical scale over horizontal scale. I think we get that. Now, how do you calculate vertical exaggeration? You divide your vertical scale by your horizontal scale. What is your given horizontal scale? Your given horizontal scale for your topographical map is 1:50,000. And for your orthophoto is 1:10,000. In this case, we are going to use a vertical scale. Excuse me, we're going to use a horizontal scale of a topographical map, which is 1:50,000. So what do we do now? We say the horizontal scale is given is 1:50,000. Are we given any vertical scale? No, we are not given any vertical scale. But what information do we have? We know that our contour interval on the map is 20 meters. Now, how do we get our vertical scale? How do we get the vertical scale? You say, how many centimeters are there in a meter? There are 100 centimeters in a meter. But now our contour interval is not 1 meter. Our contour interval is 20 meters. Now we're saying 100 centimeters multiplied by 20 meters is equals to 2,000. It's going to be 2,000. Now we have worked out our vertical scale. What is our vertical scale? 1:2,000. Our horizontal scale was always given as 1:50,000. So we have to divide this. We say vertical exaggeration is equals to vertical scale over horizontal scale. So what do we do now? We say vertical scale. We say vertical scale, it is 1/2,000. It is 1/2,000, and our horizontal scale is 1/50,000. 1/50,000. But now you cannot divide a fraction by a fraction. So instead, what do you do? You say 1/2,000 multiplied by 50,000 over 1. So what do you do there? 50,000 times 1 is 50,000. Then 2,000 times 1 is equals to 2,000. So what do you get there? You say 50,000 divided by 2,000. So you do a simple, you simplify. So you cancel this 3 zeros by this 3 zeros. Then you have 50,000 divided by 2. So how many times does 2 goes into 50? It goes 25 times. So it means now on the topographical map, our vertical scale is exaggerated. The features on the topographical map will be exaggerated 25 times for them to be clearer. So our vertical exaggeration on the topographical map is done 25 times. So when you're looking at a feature on the topographical map, you are going to exaggerate it 25 times. Why do we do vertical exaggeration? To make the features to be clearer. So we're going to exaggerate it 25 times to make it clearer. Let's continue with our map work. Here. So now, use the topographical map evidence. What has happened here? Okay. Now, use the topographical map evidence in your answer to the previous question and give 2 reasons why it will be difficult to construct a road. Okay, this one is it's a gradient calculations. This one is a gradient calculation. It's not a vertical exaggeration. So what are we looking at here? Contour lines in the topographical map is very close. So why is it going to be difficult for you to construct a road here? It is because the calculations here is I mean not calculation, sorry. It's because the contour lines will be closer to each other. Okay, let's move on. Let's look into our map interpretation. The dash in block E2 on the topographical map is an indication that seasonal rainfall occurs in the area. Now, you're looking at these things. Is it the row of trees? Is it perennial river? Is it a non-perennial river? Is it cultivated land? Now, what do we have there? You have cultivated lands there. Do you have any perennial river here? You don't have any perennial river. So what is the indication that will show that what will be the sign that indicate that the area receives seasonal rainfall here? It will be the non-perennial river. It is an indication that the area will receive periodic rainfall or seasonal rainfall, the non-perennial river. And then how is the non-perennial river represented? The non-perennial river is represented through the dots. It's represented through the river that is not flowing throughout. The river line is broken. But for the perennial river, the line is solid. Now, let's look at your map interpretation. Here is the question. Refer to the graph below indicating the average temperature of the area from H in block C1 to J in block C4 on the topographical map. Now let's look at the questions here. Identify the man-made feature that was responsible for the higher temperature recorded at X. So here is our point X. And now we have that. Why will the temperatures be higher? So what must you identify? You must identify man-made. Remember, in our previous slide, we're talking about the temperatures in urban areas and rural areas. Where are temperatures higher? Temperatures are higher in urban areas than in rural areas. Now, we must give the reason why are temperatures higher in urban areas. Number one, the tar roads, constructed buildings, these are the features that are going to make the temperatures to be higher in urban areas than in rural areas. And now, when you're looking at this rural area over here, what will make the temperatures to be cooler at this point? Why will temperatures be cooler at this point? Number one, you can see there's vegetation there. You can see there's a river there. So these are the natural features. So the question could be, what is the natural factor that are going to make the temperatures to be lower here? It is the natural vegetation here. It is also the river that are going to make the temperatures higher. Lower. And then what will be the factors that make the temperatures higher in urban area, in the build-up? How do you see urban area on the map? You see the gray area is indicating the built-up area. So also these are the type of roads that are also seen in the urban area. So the factors that are going to make temperatures to be higher here is built-up area or constructed. The gray area is indicating this is a built-up area, and also this is the tar roads that are going to make the urban areas to be warmer. But you're looking at the natural vegetation, and the rivers are going to make the rural areas cooler. And then because of that, this one will be cooler, and then pressure gradient will be created. So this will be high pressure, and this will be low pressure, like in our previous slides. So air will be moving from rural areas to urban areas. So this is a typical example of what we spoke about when we're talking about urban heat island in the earlier slides when we're talking about temperatures. So temperatures will be lower here, then it will be higher here. So you can see here, temperatures are lower, and as you go up, the temperatures are increasing. When you're moving from that point, going there, this is your J, indicating the temperatures are lower. Why are temperatures lower here at J? You can see the graph here showing temperatures lower because you can see there's a river there, there's natural vegetation there. But when you go into H here, H is in urban area, so you can see now the graph is showing temperatures that has gone higher. Because of what? Because it's urban area with artificial surfaces that absorb heat, with roads that absorb heat, with more human activities. So Even heat island, when it comes to Mapwork, that should be the simple thing that you can do for yourself, because it's going to be easy for you to interpret it, because it is showing there on the map. So I expect everybody to get that. Why is temperatures low here and why is temperatures high here? So you have all those factors that makes temperatures to be high and low. And because of that, it's going to result in pressure gradient. Let's continue with our interpretation there. It's the same diagram that we are looking at. Now we're looking at the factors. Explain your answer to the previous question. So we have explained that we're explaining, we're identifying. So what were we doing here? We're simply identifying. So you will identify what are the features. Now, after you have identified the features, you have seen these features that makes temperatures to be low. The feature here is water. The feature here is vegetation. And then the feature here is road, and the feature here is also built up area. Now, we're taking it further. We're saying you're no longer identifying now. You're saying you explain now the answer. Why are these features making temperatures higher in urban areas, and why are these features making temperatures lower in rural areas? Now we're saying the tarred roads and buildings in the city town absorb heat and retain the heat, which will increase the temperature in this area, resulting in urban heat island. And then what will happen now in rural areas? Temperatures, natural surface are going to reflect, or trees are going to absorb. Here we're saying trees here are going to absorb heat, and you can say water masses are also going to moderate the temperatures. Now let's look at this other one. Okay, we have already done that. Now, another way of map interpretation can also be katabatic and anabatic winds. So if they say name the winds that will blow from A to B at night, the weight at night must tell you already that we are talking about valley winds. We know that we are talking about valley winds, and these valley winds must be during winter. So if they say during night or in the valley, you must know those winds. So long as you see the word night, you must know it is katabatic winds. And when they describe the nights these winds will blow, katabatic winds are going to develop during cold winter nights. It is going to be cold, calm winter nights. So there must not be winds. There must not be wind. It must be wind still. Because if the winds are blowing, it will not be clear. So this over here, you are going to have something like this. You're going to have something like this. So this is your katabatic winds. So during which season do they form? They form during cold winter nights. The first process that will take place will be terrestrial radiation, loss of heat by the surface. Then the cold air will go to the bottom of the valley, and it's going to force the warm air that was trapped in the bottom of the valley to move upslope. But the warm air will not move out of the valley. It will be trapped there in the middle of the valley, forming what we call thermal belt. Forming what we call thermal belt. My handwriting is a little bit terrible on a slippery surface. I'm writing on a very slippery. So that is called thermal belt. So what does this thermal belt show you? It shows you temperature inversion. And what's going to happen? More cold air is going to subside to the bottom of the valley. When more cold air subsides to the bottom of the valley, what's going to happen there? There's going to be frost pocket forming there. Frost pocket are going to form there in the middle of and at the bottom of the valley. So it will be during cold winter nights. And I think I came to the end of the revision for paper one, and I would like to thank you for paying attention and for listening. Thank you. We shall see each other again when we do revision for paper two. I thank you. Good day, Lena.
Good day, learners, once again. So today we'll be looking at preparatory examination 2022 Geography Paper 1, which includes climate and weather and geomorphology. Our question today, we are starting with question 1, which is climate and weather, and below are the questions. All right, so question 1.1.1. The slope dash is the angle at which the sun's rays strike a slope. So for this, it's supposed to be option number B, which is the aspect. Because as we know, the side which a slope faces, that side receives direct or receives more heat compared to the other side which doesn't receive the direct heat. So therefore, the slope aspect is the angle at which the sun's rays strike a slope. Right. 1.1.2, in the southern hemisphere, the dash facing slope of a valley receives the most sunlight. We are in the southern hemisphere. If I try to do this one quickly here, this is, sorry, that's a sketch. This is the southern hemisphere here. This is our slope. We have the north, we have the south. And we know this is the sun, which gives direct heat. So they say direct heat. That's why this side is going to be more warmer. The north facing side will be warmer and the south facing will be cooler. So we go back to the question. The southern hemisphere, the facing slope of a valley receives the most sunlight, which will be the north facing side. For this case, our answer will be A. 1.1.3, in the southern hemisphere, the dash in a valley is the south facing slope. In the southern hemisphere, once again, so that will be the shadow zone. The shadow zone in the southern hemisphere, the shadow zone in a valley is the south facing slope. What does that mean? It means that the shadow zone is being obstructed or does not receive direct heat. Therefore, it will have shade, or that side will be a bit much more cooler. That is why we say in the southern hemisphere, the valley will be the shadow zone. 1.1.4, katabatic winds occur at night due to terrestrial dash from the valley slopes. All of us know that during the night, the land loses heat through a process called terrestrial radiation, where the land loses the heat. This is one of the reasons why at night we do cover ourselves with blankets, because the temperatures seems to drop. When they drop, that means the heat, or sorry, the land is losing the heat through a process referred to as terrestrial radiation. Number 5, A temperature inversion occurs when a layer of cold air develops dash dash a layer of warm air. And all of us know whenever we talk about inversion, so that is a point where temperatures increases with height. Now, when they say a temperature inversion occurs when a layer of cold air develops dash dash a layer of warm air. So this is gonna be beneath. So a layer of cold air develops beneath a layer of warm air. Something like this. This is the cold air. Yeah, this is cold air. Then here we have the warm air. The warm air which forms our inversion. So that's why we say cold air develops beneath the layer of warm air. And number 6, dash dash is stroke are most likely to occur on the valley floor during winter. So on the valley floor during winter, they will form frost pockets in a valley. Like this, we know that whenever cold air subsides in the valley bottom, so it's going to collect at the bottom here, forming our frost pockets. All right, let's continue to question 1.1.7. Radiation fog in a valley is formed by the process of condensation of water vapor. Okay, so this occurs, we know condensation is a process whereby vapor changes into liquid again. So as air subsides to the valley bottom, this air is going to change from being vapor to liquid again, resulting into formation of radiation fog. But the process that results into that will be condensation. A process whereby water changes from gas to liquid. Okay, so that is question 1.1. Let us proceed to question 1.2, which says, study the figure below based on a cross-section of a tropical cyclone in the southern hemisphere. All right, this is our tropical cyclone. As you can see, it's being labeled A, there is C there. I can't see other labels, but we shall see what to do. All right. Question 1.2.1, it says, indicate the season in which this tropical cyclone could occur. And we know that tropical cyclones, they usually develop, we could say, late summer. That is when all the temperatures are way very high. We could say late summer or early autumn. Okay, early autumn. Yeah, this is when temperatures are very high to result into the development of a low pressure. So sometimes we avoid just saying summer because it is just summer. When summer is just starting, at times temperatures are very low. So that is why we prefer saying late summer or early autumn. That is when temperatures are way high to support the development of a tropical cyclone. Again, 1.2.2, it says, state the minimum ocean temperature required for the formation of this cyclone. And we know the cyclones, they require 26.5 degrees Celsius or 27 degrees Celsius. So those are the minimum temperatures that are required. When we say minimum, it means we can't go below that one. So it is from 26.5 going upwards. All right. 1.2.3, in which general direction would this tropical cyclone move? We know cyclones, they always move from that's gonna be east to west, or we can as well say westerly direction. And I believe you know the reason for this, because they are driven by easterly winds. That's why they move from east to west, or they move to the west or westerly direction. Okay, 1.2.4, it says, name the cloud type found at A. This is at A here. This is at A, and you can see these clouds are huge and tall. All right. Now, what is the name of those clouds? And we know clouds are categorized into different. We have the cirrus, we have the nimbus, and all that. So, however, the huge and tall clouds are referred to as the cumulonimbus clouds. Cumulonimbus. The cumulonimbus clouds. Okay. Now, question 1.2.5, it says, state the precipitation likely to occur from cloud type A. Now, we know that the cumulonimbus clouds are associated with heavy rainfalls. We could say heavy rainfalls. Heavy rainfalls. We could say torrential rainfalls. Torrential rainfalls. We could say thunderstorm showers. Thunderstorm showers. Not showers, supposed to be showers. Thunderstorm showers, etc. So basically, we say heavy rainfalls, torrential rainfalls, or stroke thunderstorm showers. Okay. Question 1.2.6, is the air surface pressure at area C low or high? The air surface pressure at C, is it low or is it high? Let's go and look at C. So we are here. This is point C here. They're saying, is the air pressure at this point high or low? I think the first concept, we need to know that at this point, at point C, we see air converging, air moves towards the same point. After converging, then it rises. Now, the mere fact that air rises, it means when air moves away from this point, a low pressure is going to develop. So that is why we say the pressure at C will be low pressure due to air rising or ascending at that particular point after converging. 1.2.7, would the airflow at C be described as diverging or converging? And I think I just explained that one in the previous question. So they're saying, would air flow at sea be described as diverging or converging? So remember, to diverge is when air moves away. It is to diverge, and to converge is when air moves towards the same point. So this is to converge. Now, if we check point C, if we check at point C, you can see that this is our air with black arrows indicating air moving towards this same point C, which means for our answer would be converging for question 1.2.7. All right. 1.2.8, at what stage of development will this tropical cyclone be when it moves over land? And all of us know that whenever cyclones move towards land over the land, it means they will lose their energy. There will be less latent heat, times cooler conditions, inflow of dry air, which means the cyclone will be in its dissipating stage. You could say dissipating, or decaying, or degenerating stage, Okay, so this is when they say it moves over the land, it's like the cyclone has reached the land. Whenever it reaches the land, there is friction. That means there will be less light and heat, less evaporation and condensation, which does affect its strength and as well making it to weaken, and eventually it will dissipate. All right, let us proceed to the next question, which says 1.3, for the infographic showing bare wind conditions over South Africa. Okay, so you can see this is our infograph. I see the map of South Africa here. This other written information on this other side. We have a graph here. So remember, whenever we talk about infographics, like it is information in form of graphic, which could be maps, charts, articles, and all that. So that is all about when we say infograph. All right. Let us try to look at the first question. They say, which season is being depicted in the diagram? Let's go back to our diagram. Which season? So this is going to be winter season. It's going to be winter season. We shall see, since they are already asking us to give evidence. So this is winter season. Now they say, provide evidence from the infographic to substantiate your answer to question 1.3.1. So we need to provide the evidence from the infograph. So it means whatever we are going to give, it must be gotten from the infograph. All right, let's go to the infograph to try to see or to show why we are saying this is winter season. Okay. Firstly, you can see that the high pressure cell is dominating the interior. You see the learners. So whenever you see this HH, it represents a high pressure, and that means it is dominating the land in winter. So this is typical of winter conditions. So we could say presence of the high pressure, dominating the interior. That is one evidence. As well, we can look for other evidences. Look at the position of the mid-latitude cyclone. See where it is positioned. It means it has moved all the way from the southern and it moved to the northern area. That's why it was able to influence South Africa. So this usually happens in winter. So we see the cold front. I think let us try to use our blank page here. Check here. Okay. All right, we are there. That was question 1.3.2. Yes, so we said there is a high pressure cell over the land or dominating the land. Second, we said the cold front the cold front or mid-latitude cyclone has moved further northwards over the land. So let's check again for clarity. So you can see, like we mentioned, the cold front has moved further northwards over the land. Another evidence, we could as well look at the position of the high pressure cell. You see, this high pressure cell that we refer to as the Indian high pressure cell, it has well moved northwards. Normally, these high pressure cells in summer, they are situated a bit further away, could be somewhere here. The MLC or the mid-latitude cyclone could be somewhere here in summer. Okay, then in winter they move in that direction. They move northwards, close or towards the land. So that's why we are saying we're now seeing the mid-latitude cyclone over the land here. We see the South Indian high pressure cell, which has well moved northwards over the land. Okay, so that's why we say, we could as well say the South Indian high pressure cell has moved further north. Okay, let's try to check the other evidences. We could as well talk about the big wind conditions. You can see this. This is a coastal low. This is a high pressure cell. So it means there's a pressure gradient here, meaning winds will be moving from the high pressure cell, the low pressure cell, high pressure over the interior to the low pressure cell over the coast, resulting into a development of the big wind condition. So we know that big winds as well develop during winter. So you could say there are big winds or big wind. Just a wind is fine. Big wind conditions which occur in winter. All right, dear learners. So that is for question 1.3. It's true. Okay. Let us proceed. Okay. So question 1.3.3 says, state two atmospheric conditions evident in the infographic that have resulted in the formation of big winds. Like I think we saw this in the previous question. They're asking what conditions does result in the development of formation of the big winds. All right, like we mentioned before, you can see move it. Okay, so you can see the big winds to develop mainly there must be a high pressure cell over the interior and a low pressure cell over the coast. So with this, there is a pressure gradient. That is why we say one of the conditions, there must be a pressure gradient as our factor, the first one. Pressure gradient. What is pressure gradient? It refers to where one area or it refers where the pressure is different between different places. That is, for example, here you see we have a high pressure over the interior and a low pressure over the coast. So this is what we refer to as pressure gradient. So this will hence result in the development of the winds, because we know that always winds, they move from a high pressure going to the low pressure. All right, so that is why we are going to say that there will be formation of big winds as a result of the pressure gradient. Secondly, can as well talk about the high pressure cell, high pressure cell, high pressure cell over interior. Okay, as you can see here, this is our high pressure cell, which is the Kalahari high. So you can as well just say this Kalahari high pressure. Okay, or another factor, another condition, we're going to talk about the coastal law. The coastal law pressure cell, which is situated along the coast. So this is our coastal low pressure cell. This one here would be our coastal low. So because of the presence of the high pressure cell, like we've mentioned, the high pressure cell over the interior, the coastal low over the coast, the pressure gradient. So this does result in the development of the big wind conditions. Okay, 1.3.4, with reference to the temperature graph, explain the process of temperature change from 3 to 2 as big winds blow from the interior to the coast. So we need to look at the graph and try to explain what is happening regarding the temperature. So let's see the question once again. It says, with reference to the temperature graph, explain the process of temperature change from 0315 to 1400 as big winds blow from the interior to the coast. All right, let's check the graph here. They said from 0315, and as you can see, this is our temperature graph here. So this is three this line of, let me say this is the vertical line, which would be the longitude for that case. Then this could be, this is 315 somewhere here. Then they said from 315 all the way to 14. But you can see, imagine that it is you are here. It means I am climbing vertically. I keep on climbing. I climb. At this point, then I go down again. See, I continue to go down. You see this. So if it is with temperature, of course, this shows that at 3, the temperature started to rise. They kept on rising. You see, because you can see here, they were somewhere in 20 degrees C. They went to 25 degrees C. They went to 30 degrees C. They went to 35 degrees C. They went to 38. They reached 40 degrees. You see? Then again, at around 10, then they dropped. There's a sharp drop. Then here there was a gradual drop, you see, to 2 o'clock. So we are going to say, with the reference, let's use our blank page. This question 1.3.4. That T14, 15, the temperatures were rising. and this was due to the incoming hot winds. Okay, let's check again. So like we mentioned, try to remove this. So oh, not 2, I said at the O315, not 2. It's supposed to be O315. Sorry about that. It to be. This is O315, right? O315 temperatures were rising. Well, let's hear the question once again. With reference to temperature graph, explain the process of temperature change. I want us to explain why temperature was able to change from this to this. You see? And that's why here we said temperatures were rising, and this was due to the incoming hot winds, which are the big winds. And that's what we could say. The temperatures kept rising. Temperatures kept rising as a result of a diabetic descending wind. So meaning that as winds were subsiding from the interior to the coast, they were warming up and drying up, therefore resulting into temperatures to keep on rising. Then we say somewhere we see the temperatures dropping. So you can see that again, from this is 10, right? From 10 to 14, there was a sharp decrease in the temperatures. So you could say 10 a.m. to 14 p.m. there was a drop in the temperatures. There's a drop in the temperatures. All right. Okay. Let's go back to our page. So now that was question 1.3.4. 1.3.5, they say a weather station located at A has reported clear skies. Account for this current condition. A weather station at A has reported clear skies. Let's look for point A. Okay, point A. So this is our point A here. That along this area there are clear skies. So when they say clear skies, it means there are less few or there are no clouds that are developed along point A. And this could be as well. Let's go to our blank page for question 1.3.5. 1.3.5 could say clear skies due to dry or hot winds resulting into less condensation. Remember, when air is dry, it means it will have low humidity, making or resulting into less condensation to take place, giving us clear skies. And secondly, could say as well subsiding air, subsiding hot dry air at point A results into clear sky. So we know that whenever air subsides, if I can illustrate it here, whenever air is subsiding, it means there will be no condensation here to happen. That means we're going to end up having clear skies. But whenever air rises, like for this case, if air rises, it means there will be condensation resulting into formation of clouds. So where there are big winds, it means there are clear skies as a result of dry hot air or subsiding hot air. See, that's why at point A it will have clear skies. 1.3.6, it says, explain why city A, which is situated on the east coast, will be affected by the release of fire warning. Explain why city A. Let's go check city A. Okay, so city A here, which could be Durban for our case. Durban. So this is Durban here at A. And they're saying, explain why city A, which is situated on the east coast, will be affected by the release of fire warning. Why are they going to issue fire warnings at city A? That is what the question wants us to talk about. Okay, let's go back to our blank page. Okay. Okay. Why are they going to issue fire warnings at city A? One, we could say to alert people at city A to be aware of the fire outbreak. Two, to ensure that people can evacuate away from that area. Another reason why they issue warnings there, to make sure, to ensure that people are not at risk of fire. So could say save lives. So they're going to issue warning to save lives for both people and animals. So to ensure that people do not do bush burning during big winds. during big winds. It as well say to ensure that people stock enough water in case of dehydration, among other reasons. So that is why they are issuing warnings at city A, is to ensure all those factors and as well to make sure that people are safe. All right. So that was question 1.3.6. Let's proceed to question 1.4. It says, refer to the infographic below on mid-latitude cyclones. Okay. As you can see, that is somewhere here we can see there mid-latitude cyclones here. There's some this other side. You can see the map of Southern Africa here. You can see Madagascar. See, there's the high pressure cell here. There's another on this other side. See, like these are MLC, of course, they are low pressure cells. These are isobars. You can see in steep pressure gradient here. Okay, so there's a station model here. So always try to analyze the infographics and as well you read the information that is indicated. Okay, so let's go straight to the questions. 1.4.1, it says, what climatological evidence indicates that this mid-latitude cyclones is occurring in the southern hemisphere? Okay, what do we look at to ensure that this mid-latitude cyclone is situated or occurring in the southern hemisphere? Right. Firstly, we can look at the date. First, move all this, make it look more clear. Okay, so you can see the date. Our date here is 9 June. And all of us know that 9 June, this usually happens in winter. You see, 9 June in the southern hemisphere, it is winter season. This is when temperatures are very, very low. So one evidence to prove that this mid-latitude cyclone is in the southern hemisphere is by the mere date of winter. So the date showing winter in the southern hemisphere. So that's showing winter in the southern hemisphere because winter in the southern hemisphere that starts somewhere from May towards May, June, July, August. Yeah, that is plus still in winter season. So if we see June and we know that this is winter, you know, and this must be in the southern hemisphere. What other evidence? That was for 1.4.1. 1.4.1 we said that which shows winter in the southern hemisphere. Okay, which other evidence? Let's check. We can as well talk about the position of the mid-latitude cyclone. So you can see that they have moved further northwards. You see, this normally occur in winter. So the position the position of mid-latitude cyclone further north. See, and this occurs in winter. Let's go back to check again. So, like I mentioned, sorry about that. Erase that, remove all this. Like I mentioned, in winter season, the mid-latitude cyclone is always situated further northwards. See, they are moving further northwards, which is typical of winter, but in the southern hemisphere. Okay. Because we know that in the southern hemisphere, mid-latitude cyclones will be situated further northwards. So what other evidence can we give to prove that this is southern hemisphere? Remember, we need to be very careful with this question. It talks about climatological. Okay, wait for my pen to react. Okay. It's technology sometimes. So just to recap, we said 1.4.3, the stage was the mature stage. 1.4.4, the cross section, like we showed it here. This is the cold front, this is the cold sector, this is the warm sector. Then for 1.4.5, a group of tourists want to attempt the hiking trek to the top of the Table Mountain ahead of the cold front, and they're saying in a paragraph, approximately 8 lines, advise the organizers of the hike why the event should be postponed by explaining the expected conditions and possible impacts thereof. Okay, 1.4.5. So we need to look at the possible conditions and the impacts thereof. All right. Let's do like this. Sorry. Okay. So ahead of the cold front, we're going to say, because there will be overcast clouds starting into poor visibility. When it's too dark, it means the tourists might not be able to see properly. As well say the cold front lowers temperatures, making the area too cold and unbearable. Because whenever there is a cold front, temperatures will drop. Need to be very, very cold. And as well say tourists might catch flu or cold due to very low temperatures the area will experience snow, resulting into poor visibility, as well say there will be heavy rainfalls. There will be heavy rainfalls which could trigger landslides or mudslides. As well, heavy rainfalls could result into floods, which might impact on tourists. I can as well say transport and communication. Will be disrupted, which could result into tourists getting lost. So among other factors. So just to recap, we said there will be overcast clouds resulting into poor visibility. The cold front makes temperatures to be very low and unbearable. Tourists might catch flu or cold due to very low temperatures or due to cold snaps. And the area will experience snow resulting into poor visibility as well. There will be heavy rainfalls, which could trigger landslides or mudslides. Heavy rainfalls could result into floods, which might affect on tourists. Transport and communication will be disrupted, which could result into tourists getting lost, among other factors. All right. So that is for that question. Let us proceed to question 1.5. 1.5. Okay. Refer to figure 1.5 below, showing a pollution dome. Excuse me. So they say define the term a pollution dome. So you could say a mass of polluted air, above the city. That's the pollution dome. As you can see here, this is the city. So you can see pollution taking place here. So all this now is a dome which has formed as a result of trapped pollutants in the warm or in the heat island, resulting into a pollution dome. So that is why we define it as a mass or a lot of polluted air above the city. Okay. 1.5.2, they say at night, the pollution dome is lower in elevation than during the day. Explain why this occurs. At night, the pollution dome is lower in elevation than during daytime. So explain why this occur. Okay. So we're going to look at, let us try to use the blank page to illustrate the two. So this is a pollution dome at night. This is our step, for example. It's our city with tall buildings. This could be the CBD in the center. Then during day, so you can see the elevation at this one. During daytime, the pollution dome is way above the city, you see? But at night, it is way close to the city, you see? So what causes this? Why is it that during day, the pollution dome is way far away from the city, then at night is much more closer to the city? What could be the cause of this? Okay, so that's what we need to answer. Okay, let's look at the answers here. We could say that at night, due to terrestrial radiation, this is when the land loses the heat. Due to terrestrial radiation, the dome subsides close to the city. So at night, we know temperatures are low. Therefore, the dome cannot expand upwards. Instead, it will be contracting, moving towards the city or towards the surface as a result of cooler conditions. Secondly, at night, there is less convection currents. Less convection currents resulting into the dome to move close to the city. Okay. At night, we could as well say at night, there is a lot of pollution. Trapped in the air. Okay. So so far, those are some of the reasons. Okay. As well say at night there is a lot of subsiding air, pushing the dome downwards. Okay. Let's go to question 1.5.3. They say, State the environmental problem that results from a pollution dome which develops close to the surface in a city. Environmental problem, as well we know, there might be acid as the rain would form. As the rain could form, and as well we'll talk about the heat island, poor air quality. Okay, so there could be a formation of as the rain, development of heat islands, or poor air quality. Okay. 154. Describe how the environmental problem identified in the above question develops. Let's go to 154. Let's use our blank page. 154. About as the rain could form due to the reaction of water, gases, and pollutants above the city. So when those mix up, the chances of experiencing as the rain will be high. Then poor air quality will be due to pollutants trapped above the city. Then heat islands, their temperatures are rising due to heat being trapped above the city. So all this could result into those factors mentioned. Okay. 1.5.5, air pollution reduces the amount of a city's clean air at night. Explain this statement. 155. I could say that at night, there is less air blowing into the city to clean up pollutants. To clean up the pollutants. So we would as well say that at night there is too much pollution taking place. Also, you could say the pollution dome is situated close to the city. Is situated situated close to the city, among other factors. Okay, 1.5.6 provided two sustainable strategies that can be implemented in cities to minimize the effects of industries on pollution dome. Okay, to minimize, I think we have space here. We could say put fines to industries that do not respect regulations on pollution. So I could say to carry out decentralization or industrial decentralization. Industrial decentralization, so that industries are moved away to other areas. Again, okay, technology. Excuse me. Install filters in chimneys. To reduce on pollutants as well. Would say enforce programs regarding dangers of pollution. As well say advise industries to set up green belts so that they can consume most of the pollution. Also promote greener energy sources. So among others, so this could help in minimizing the effects of industries on pollution down. Let us proceed to question 2, which is geomorphology, by either saying, they refer to read the following statements and choose the appropriate words in the bracket that will make the statement true. Okay. An increase in rainfall in the middle course of the river valley will result in increased, because we know in the middle course of the river valley, usually there is more of lateral erosion. So I could say there will be more lateral erosion. But as well, Even vertical erosion could as well be a correct answer, because we know the more the rainfall, the stronger the river, increasing its vertical and lateral erosion. So both options could be correct. 2.1.2, the amount of load that a river can carry is determined by its gradient. But the gradient refer to the steepness or the gentleness. So the steeper the gradient, for example, like this, so the river will be able to carry lots of sediment from upper course down to the lower course due to the steepness of the gradient. So 2.1.3, the volume stroke velocity of water is higher in the upper course than in the middle course. So I think we are going to say that the volume, that is the amount of water, and we know it is less in the upper course. So this goes with velocity or the speed. So the velocity of water is higher in the upper course than in the middle course. Like, because we know that the upper course, that's why it is very steep. So if water is flowing over a steeper gradient, its velocity is very high, meaning water will be flowing so fast. 2.1.4, the V-shaped valley in the upper course of a river is a result of vertical erosion, because we know when they say the V-shape, they are referring to this. See, and this is caused when the river is eroding, going downwards. When it goes downwards or vertically downwards, so it's going to result into the V shape. So that's why we say that will be due to vertical erosion. 2.1.5, at the mouth of a river, there is more deposition, which results in the formation of a delta. So what is a delta? Delta is a landform which develops due to deposition at the river's mouth. Okay. 2.1.6, lateral stroke vertical erosion in the middle course results in the migration of a meander downstream. We know that meanders cannot form because of vertical erosion. So instead, they'll form as a result of lateral erosion, because it means the river is winding side to side. 2.1.7, rejuvenation closer to the source of the river will result in more erosion stroke deposition in the lower course. So remember, rejuvenation is all about a river gaining energy. Therefore, there'll be more erosion in the lower course. So it means it will start eroding the channel vertically after gaining strength due to more water, or due to gaining more energy. Okay, let's proceed to question 2.2, which says below, and refer to figure below and choose the correct letter that matches the description. Okay, so 2.2.1, it says drainage pattern that formed from rivers flowing into a depression or a lake. Okay, that's going to be F. As you can see, the streams are all flowing to one central point. Okay, we need to be careful between this one and this one here. With this one here, they are showing, as you can see, the streams are flowing out. Look at this tributary joining, then it continues like that. Then here you can see tributaries are joining like this, and the river, they continue. They come, they join, then continue. They come, they join, then it flows. So they are flowing to the one central point. That's why 2.2.1 will be F. A drainage pattern formed from rocks of uniform resistance. We know that's going to be dendritic, which could be typical of A, because it looks like dendritic. Even I think it's not dendritic. Take A, as well take C. So, but the most appropriate one will be A. Okay. Two point 2.3, drainage pattern commonly found in melting ice regions. I think that is typical of G, which is the drenched, because you can see with drenched forms in glacial areas where streams do not have a clear pattern of flow, they are haphazard, you see. Then 2.2.4, a drainage pattern that occurs on common slope down a linear mountain. That would be C. That would be C. That would be C. Okay, 2.2.4, a pattern that occurs on a common slope down a linear pattern. Then actually, if you look at 2.2.4, let's see. So the 2.2.5, a drainage pattern that develops on alternate layers of hard and soft rocks. It has to be trellis, which is B. 2.5, that would be B. Then 2.2.6, a drainage pattern that commonly forms on areas of volcanic mountains. That would be D. Areas of volcanic mountains, that would be D. Then 2.2.7, a drainage pattern formed where prominent ridges like lie parallel to one another. That's to be trellis, which is B, because with trellis it looks like dendritic, though we look at the tributaries that are too short and they join the main, you see, too short. So with trellis, the tributaries are too short, which is going to be B. Oh, 2 point drainage pattern formed where prominent ridges lie parallel to one another. Let's check this question once again. Sorry about that. This technology. Okay. A pattern found where prominent ridges lie parallel to one another. That's gonna be C, which is a parallel pattern, right? Then 2.2.8, a pattern in which the main streams and their tributaries display many right angle bends. That has to be rectangular, which is E. Okay. 2.3, figure below shows a meandering river. You can see this is our meander. This is a feature here, the feature here. Okay. So what is a meander scar? So all of us know meander scar. A featured fluvial landform. Fluvial landform that forms when Oxbow Lake dries up. Okay. 2.3.2, In which stage of the river can a meander loop and a meander scar develop? I think they are more developed in the lower course. But as well, they could also give the middle course. The middle course. 2.3.3, name the slopes that will develop at X and Y of the meander loop. X and Y, so it's a bit dark, but this side is X and this side is Y. So at X, X will be the undercut slope. That's why the water flows so fast. So I could say X, the undercut, sometimes we call it the scarp slope. Then Y, where the river deposits materials, that would be the slip of slope. 2.3.4, at which slope X or Y will there be more deposition than erosion? Because we know the slip off, that's where the river deposits more. Okay, so it means to be it should be slope Y, which is the slip off slope. So that is where there will be more deposition than erosion at slope Y due to slow movement of water. So the river can no longer erode, instead it will be depositing more materials at that point. Oh, this is a given reason for your answer. Would say there is low velocity the slope is shallow. So we talk about gradient. So all this will result into the river to deposit more materials than to erode. 2.3.6, explain how a meander scar is formed. I think here, when I use this space here, I would say, before we look at the meander scar, we need to understand Oxbow Lake. We say a river erodes the outer bank and deposits in the inner bank. Okay, then we say the meander neck is narrowed due to erosion which eventually breaks, is cut off. Forming the Oxbow Lake. The Oxbow Lake eventually dries out, forming a meander scar. All right, let's proceed to question 2.4, which says start the figure 2.4 below on river capture. So they say define the term headward erosion. Headward erosion. So we could define it, and we say depends when I'm gonna write it on top here. A river erodes backwards towards its source, lengthening its channel. That is headward erosion. (2.4.2) name one possible factor from figure 2.4 that could have resulted in river A capturing river B. River A, so that river A, this was our captor river, which was more stronger. So they are asking us to give one factor. So you could say, that river A, I think let me use our blank page so that I have enough space. This is for question 2.4.2. So we could say that river A was flowing on less resistant enabling it to erode easily. I could say river A was flowing on steeper gradient making it more energetic. Or river A had a higher velocity and strength. Or river A had more water to make it more stronger. So these are some of the factors that could have resulted in river A to capture the other river. Okay. Question 2.4.3, explain how the process of headward erosion contributes to river capture. So 2.4.3. So you could say a river erodes backwards towards its source. The river is able to erode through the watershed and will steal the other area. So that's how you can explain how headward erosion could contribute to river capture. Okay. The next question, which is 2.4.4, give the geographical terms of features D and E, which develops from river capture. Features D and E. So you can see this is our feature D here after capturing. That's feature D there, which is curving. And all of us know a feature which curves, that you refer to it as the elbow of capture. Feature D, elbow of capture, where capturing took place. And feature E, you can see this area which has been left dry. You can see the river continues the other side, but then this area has been left dry, and we refer to it as a dry pen or a wind gap. So feature E is going to be our wind gap or a dry pen. 2.4.5, discuss 3 physical changes that will occur in river A as a result of river rejuvenation. So what's going to happen to river A? Would say its erosive power. Will increase. Its energy and velocity will increase. It will erode more vertically. It will have more volume of water. More volume of water. It will develop various landforms. Such as rapids, to see, among others. Right. Question 2.5 below, which is an infographic on just K River catchment area. K River catchment area. Okay. Okay, so 2.5.1, they say define the concept river catchment area. So a catchment area, but as well define it area that supplies apologies. Sorry about that. Okay, so I could say area. I write it here at the bottom. Area that supplies a river with water. So 2.5.2 of which river is the Cascade River a tributary? Let's go check through. So of which river is the Cascade River a tributary? Okay, first. Okay. Of which river is Cascade River a tributary? Okay, let's see. This is the dam on top there. There is a dam here. So this is Cascade here. So this is an area. Chalami. So it comes, it's flowing into which other river? So here they mentioned the Crocodile River. This is Crocodile River. So which means that this tributary, the Cascade River tributary is flowing into the Crocodile River. That's why we say the Crocodile River. Okay. 2.5.3. The water quality of Cascade River is deteriorating. Substantiate the statement by referring to the infographic. Why is it deteriorating? Okay, let's check here. One of Hautenge's largest rivers, the Cascade, flows northwards, meandering through bed flowing into hydrotrophic spot dam. Its roughly 50-kilometer course through the city inexorably marks it as a casualty of Johannesburg massive urbanization. Its ready waterways, a repository for the city's torrent of sewage, stormwater, litter, industrial waste, and building rubble. For water expert Dr. Anthony, not only is the Cascade one of the country's most polluted rivers, it is also one of the saddest. Its demise, he believes, is a metaphor for all what is wrong in our city. All right. So they say the quality of the Cascade River is deteriorating. Substantiate the statement by referring to the infographic. Okay. I think we can focus on this point here, on this statement here. Let's talk about, so all the a lot of points here. Why is water quality deteriorating? 253. Write it here. Three. Okay. Check. Testing one, testing one, two. All right, it's back. It's back. So 2.5.3. The water quality of Jaskai is deteriorating substantially statement by referring to the infographic. Okay, let's go back to 5.3. So remember, we had identified, they said, the torrent of sewage. So talk about sewage from industries and homes that pollute the Jaskai River. Okay, that's one. Also identified also this other part here about urbanization. Check. So, excuse me, urbanization, which has also resulted into high pollution of the Jaskai River, because we know when most people are running away from rural areas to come stay in cities, so at times this also increases pollution, which does affect most of the rivers. So talk about litter, another reason. Let's say the Sky River has been affected due to too much litter affecting its quality, affecting its water quality. Okay, what else could we talk about here? Okay, so among other factors, let's try to check if there's some other points here. Okay, so in a paragraph 2.5.4, in a paragraph of 8 lines, suggest possible strategies that can be implemented to deal with the problems identified in question 2.5.3. What can be done? 2.5.3. It's a buffer around, excuse me, buffer around river to prevent people strict laws and regulations regarding pollution of rivers, as we'll talk about. environmental campaigns, excuse me, environmental campaigns to educate people, get people on importance of rivers. Also, rivers. So talk about cleaning campaigns to ensure that rivers, excuse me, rivers are still safe. Fix sewage pipes to avoid leakage into rivers. Also, okay, that is among others. First, take a glass of water, then I'll shower. Okay. Question 3: geographical skills and techniques. Background, the coordinates. This was Howick is a town located in KwaZulu-Natal. The town is 1,050 meters above sea level, with warm summers and cool dry winters. Snappy descends upon Howick when snow falls on the nearby Drakensberg. The town is located along the N3 freeway, connecting it with the rest of South Africa. The town is the location of Howick Falls, which is the large waterfalls that occurs when the Omgen River falls 95 meters over the right cliffs on its way to the Indian Ocean. All right. Excuse me. So they say the first question, 3.1.1, in the topographical map index 2930SC, the 29 and 30 indicate. Let's check on our Howick map. Let's try to zoom in a little bit. Okay. So this is our 2930. And as you can see, 29 shows, 29 shows a latitude and 30 shows a longitude. I know the latitudes are numbered south, longitudes increases to the east. So which means answer for this case will be 29 latitudes and the 30 longitude, which is B. Howick Waterfalls is located in which province? Remember, as we read, Howick is a town in KwaZulu-Natal, which is supposed to be A. So always for such information, do not forget always to read through those given infos or infographics. Sometimes learners miss out on such easy questions. Okay, 3.1.3. What is the difference in height between spot height 1030 in block 3 and spot height 784? So for this case, the difference, just gonna subtract, and we say 784 subtracted from 1030. Then we get our calculator here, and we sign our calculator. We say 1030 minus 7. Put it here, minus 784. So our answer will be 246 meters. 246 meters. Then 3.1.4, calculate the distance in meters between spot height 1030 and spot height 784 in block D4 on topographic map. So let's go in block E3 and block D4. The block E3, this is E1, E2, E3. So we are here. This is our spot height, which is 1030. And the D4, is it D4 or D5? Let's check. Yes, D4, which is 784 here. So which means we're going to measure from this spot height to this spot height. So what you do, you get your ruler and you measure in centimeters from the given spot to the other spot. But for this case, let us assume that we measured, and let's say we got 6.2 centimeters as our distance. What do? We come here and we say 6.2 centimeters. We need to convert it to because this is the distance in meters to the scale, which will be 500 since we are using a topographic map. So 6.2 times 500. Go back to our scale. 6.2 times 500. We're going to get 3,100 meters. Okay. Then 3.1.5, they say use the answers in equation 3.1.3. So 3.1.3, our answer is 246 meters. And 3.1.4, our answer is 3 meters. To calculate the average gradient in meters between the two spot heights. So what we do there, since we already have the distance, this was the distance here, then this was the difference in height. Okay. Difference in height. So what we do here, as our formula states, vertical interval over horizontal equivalent. So meaning our vertical interval, that is the difference in height, which is 246 meters over the horizontal equivalent, which is the distance in meters. Okay. So when you have everything in meters, then the figure on top divides by itself, divided by 246. And what you do on top, you as well do it at the bottom here, divided by 246. Then you say 246 divided into 246, that will be 1. Don't forget that our answer for gradient must be in a ratio. So it's going to be 1. Then 3,100 divided into 246 divided by 246. So our answer is 12,6. That's our gradient. Okay. Then we proceed to 3.1.6. Choose the correct answer from the option provided below. Write only the letter A to the next to the question number. The cross-section of the slope between spot height 1030 in block E3 and spot height block D4 on topographical map is a cross-section. So let's go again to those blocks. Spot height 1030 in E3 and D4. E3 and D4. So you can see that at E3, between the spot height, this area is gradual, is gentle. That's why there's been farming. But as you go to the other side, look at the contour lines there. The contour lines at this particular point, they are too close to each other, which shows a steeper gradient, right? Which means it could be something like this. Gentle, then becomes steep. Okay, let's check on our options here. So when you look at option B, you can see it is gentle, then it becomes steep. You see? That's why we're going to take number B as our correct answer. Give a reason, then you could say at E3 shows a gentle gradient and steeper at D4. Okay. Then 3.2 refer to the valley at G in block B2 on topographic map. The valley at G in block B2. Let's check. Sorry about that. Block B2. Okay. The valley at G. So this is where we are at G. Block B2. All right. Choose the correct answer from those given below. Write only the letter to the number. The nocturnal or nighttime wind that develops during the night in this area is called, that will be katabatic winds, because we know that katabatic winds develop in the valley at night. Explain how wind promotes the formation of dense fog at G. So let's go back to our blank page. So you could say at night, cold air subsides at the valley bottom, forming frost. The cold air at valley bottom condenses below freezing point, forming the fog. Forming a fog. Okay, so that is how the winds that is katabatic will result in the formation of dense fog at G. Then question C, how development of fog in this area impact early morning traffic on the secondary road? Well, so consider this is our secondary road here, secondary road. And then they're saying that this is developed already. There's a lot of fog in this area. So how will it impact on the early morning traffic? So when there's too much fog, it reduces visibility, causing traffic to move very slow. Okay, let's go to question 3.2.2. Refer to the Umgen River in the south of the topographic map. South of topographic map. Let's go south. With Umgen River. Yeah, this is our Umgen River here. We got it. All right, so it moves all the way. This is Umgen River there. Somehow it falls there. All of this is Umgen River. Even as a tributary joining it there. Right. Okay. So I erase this for more visibility. Okay, so let's go back to the question. It says, in what general direction does the Umgen River flow? Let's check. So you can see that this side it is too steep, right? Too steep. And we know that rivers, they originate in steeper or from steeper areas, and they flow towards gentle places. So it means that this river was flowing, if we put our compass like this, our compass, it was coming from the northeast, going to the southwest. Why do we say southwest for this case? As I mentioned before, so that the river do originate from higher areas. So this is visible by looking at the contour lines. I think you can see our contour lines are too congested here or close to each other, indicating steeper gradient. Again, the other side. But as we pass the Howick waterfalls here, as it continues this other side, you can see that the gradient becomes gentle. And also, you can see that now the meanders are more developed in this other side, which means that the river was flowing from the northeast towards the southwest. Okay. Okay. So that's why we say, that this river is flowing to the southwest direction. Write it down here. Southwest direction. Give evidence from the map to support your answer. Let's say gentle gradient in the southwest. So that is 132B. Gradient southwest. So steeper gradient in the northeast as well. You could see meanders in the southwest, flood plains in the southwest. Let's try to check those ones for clarity. You can see we have flood plains around this other area next to the river. Remember, flood plain is a flat land or a level area across the river, and in most cases that area is used for farming. So there's a flood plain. This other side, there are meanders that are more developed also in the southwest. Then the gradient is gentle again around this other area. That's why you can even see there are a lot of buildings, farming taking place instead of this other side. Then this other side, you can see the gradient is too steep as a result of these contour lines. We still have very steep here. The evidence of waterfalls that are more common in the upper coast. So which means that it can't be flowing to this other side. So it is flowing like this, going to the other direction. Right. So that is for that question. Let's proceed to question 3.2.3. Identify the stream order at H in block F4 on topographic map. Block F4. F4. So this is at H here. Let's try to zoom it. Okay, so you can see at this point, this is H here. If we draw this stream nicely, you can see the other stream, this other stream, right? It means there is 1 and 1, which will give us a 2-order stream at H. Right to back. So meaning the order would be a 2-order stream. 3.2.4, landform 8 on the orthophoto map. Let's go to the orthophoto map. Okay, landform 8 on the orthophoto map. Let's check orthophoto map. Landform 8. Okay, landform 8, you can see contour lines steep on either sides. The second option is here, which could be either a spur, so it could be a spur or it could be a saddle. Identify the Fluvial feature at the base of the Howick waterfalls on the orthophoto map. Orthophoto map is at 9. Yeah, that looks like a pool, because they say under the question talks about the feature at the base of the Howick waterfalls. So we know that would be a plunge pool that develops when the falls erode downwards. 3 to 6. Refer the Fluvial landform, of which the cross section above is illustration. So this would be a meander. Name the Fluvial process taking place at 10 and 11. So at 10, it will be deposition, because that is the slip off. Then at 11, it will be erosion, because that is an undercut. In 331, GIS, refer to block B1. Vector data is data that consists of points, lines, and polygons. Identify the following vector data in block B1 that relates to conservation. A point feature, block B1, that relates to conservation. This is B1 here. So I need to identify a point feature in block B1 that relates to, okay, let's see. Our map, is that clear? Let's try to zoom in and see. In B1, what do we see here? What feature? Yeah, based on our map here, I think because of the resolution, you can't easily see the lookout, identify a point feature there. But let's try a polygon. So polygon, it's a polygon that could be woodland. See, all of woodland that is in block B1, which is woodland. Then refer to the Howick waterfalls in block E2. So they say the location of the Howick falls at F in block E2 on topographic map is an example. The location that's going to be spatial data, because we know spatial data deals with the location of objects. So since they spoke about the location of the Howick falls, that would be spatial data. Then 3.3, refer to Mgen River, which runs through the town of Kwa Mevena in block E1. Define the term buffering. This is drawing rings around a feature, or demarcating a zone around a feature. Demarcating a zone around a feature, that is buffering. So number B, do you think buffering was applied in the development of the town in block E1? Let's go and check block E1. Do you think buffering was applied in development? That's the question. Development of the town in block E1. Do you think buffering was applied here? We could say so, because at least the river is still being preserved. Otherwise, there will be no river there. Okay. but as well, I think let's go with a no, because let's say no, buffering was not applied. Give a reason. The town encroaches on the river. Town encroaches on the river.
In this question here, we have question number 1.1, which talks about the stable weather conditions over the interior of South Africa are due to the well-developed high-pressure cell. Right, for us to realize stable weather conditions over the interior of South Africa, we understand that stable weather conditions are realized when we have the dominance of sinking air. When we have a sinking air, that is where we have fine weather, we have stable weather, which is an anti-cyclonic system. So in this instance here, over the interior, when we are having stable weather conditions, we are having the dominance of the Kalahari high pressure cell. So for that question there, our correct response would be the item number D, which is the Kalahari high pressure cell. It's the one that contributes towards fine weather conditions over the interior. Right, we move on to the second question. Right, the dew point temperature at weather station A, if we check weather station A, you tend to find that weather station A is located here, there over the interior to the extreme west, close to the extreme west coast. So the dew point temperature, we are talking of the presentation of temperature on the synoptic weather map. We have two temperature readings, the one on top and the one at the bottom, meaning to say we have the air temperature, which is the maximum temperature, and the dew point temperature, which is the minimum temperature. So we take the least one, the smaller between the two, which means that is the negative 8 degrees Celsius. That becomes our minimum temperature, or our dew point temperature for that weather station. So our correct response in that question becomes response number item B, which is negative 8. Right, we move on to the next question, which is question number 1.13, which says the atmospheric air pressure at weather station B is dash hectopascals. Right, we try to check again on our synoptic map. We are seeing that station B is located here, and for us to figure out the pressure for this particular weather station here, it's not indicated for us. We need to use map interpretation skills. Right, we check the isobars closer to that station. Right, if we check our isobar here, we have an isobar with a reading of 1016 hectopascals, and we have our station B as we go to the north eastern direction. We also see that we have another isobar which crosses via this path here, which has got a reading of 1020. So if we check here our isobaric interval, it represents that it has a 4 hectopascal interval from 1016 to 1020, 1016 to 1020. That is a difference of 4 hectopascals. So if we can try to estimate before we even check on the responses, our response definitely has to lie within the range of 1016 and 1020. It should be between the values of 1016 and 1020, which will mean that it can only be 1017, 1018, 1019. Those are the possible responses for that particular station. So if we try to check on our responses here, definitely there's no response which coincide, or which is, there are no two responses which definitely fall within the range of our responses expected. So the correct answer for that question comes as response number C, which is 1018 hectopascals for that question. Then we move on to the next question, which is question number 1.14, right, which talks about the low pressure cell at sea is known as a dash low, right. We go to our synoptic map and try to identify C. Our C is here, right. If we see the location of our warm pressure cell there, we can actually see that the pressure cell is located along the coast, is along the coastline. And if you check on this extreme western side, we are over the Atlantic Ocean, and as we get to the eastern side, we are getting inland. So this low pressure cell is along the coast, is along the coastline here. So low pressure cells that we tend to find along the coast, we call them the coastal low pressure cells. So we check on our responses, and on our responses, the correct response there becomes a coastal low for that question, which means our item number D becomes the correct response. Right, we move on to number 115, which says the type of precipitation found at town D is dash. Right, we go back to our map and try to identify where town D is. Right, we check there, our D is there, indicated by this letter, and is pointing to that symbol there. Right, what does that symbol mean? What is the type of precipitation indicated by that symbol? You can see D is pointing at a dot. Right, we have several symbols that are used in synoptic weather maps. We have symbols for different types of precipitation. We have symbols for fog, symbols for mist, symbols for hail, drizzle, rain, whatever form of precipitation, snow. They have different ways of presentation on the synoptic map. So for this one, for this dot here, the correct response is rain. That is the type of precipitation that is represented by that symbol on the synoptic map. So we check the response of rain. Right, we go to the next question. Right, the type of precipitation, to answer question number 1.15, is caused by, right, what causes the rain is, we want to look for the first item of the type of winds which will cause that type of precipitation. Definitely in that instance, when we talk of offshore and onshore winds, we are looking at offshore, we are looking at winds which are coming from land going over the water body or going over the ocean. And onshore, we are looking at winds which come from the ocean over the land. So definitely for us to have rain conditions, we need to have onshore winds. So we pick our item number 2. Then we look at the conditions of the winds which are onshore, conditions which are likely to cause rainfall. For us to have effective condensation taking place, we need to have moist, warm and moist air. Cold and dry air has no capacity here to cause condensation, because if the air is dry, it means it doesn't have moisture. So we cannot have effective cloud formation, and we cannot have rain formation. So in this instance, our item number 116, the correct response you are picking the response for onshore, and you are also picking the response for warm and moist, which gives us a combination at D with item number 2 for onshore and item number 4 for warm and moist, which gives us the response item D for that response for question number 1.16. Then we proceed to question number 1.17, Right, the evidence of backwind conditions at weather station E is dash and dash. We need two conditions that suggest that there was a backwind on that particular weather station at E. Let's try to figure out from the station E. If you try to figure out a station E, you can see that the conditions there is clear skies. If you check there is no shading to indicate cloud cover on that station. And also if you check, the wind direction is a northwesterly wind. And if you also check the temperatures, the maximum temperature is 27, the minimum temperature is -9. So if we try to figure out on these conditions here, we want to figure out conditions that relate to the prevalence of backwind conditions on that weather station. We have noted that there is clear sky, there is no cloud cover here, and we have also noted that the maximum and minimum temperature is 27 and -9, and also the wind direction is a northeasterly or northwesterly wind and at 30 knots. Right, so if we go to our responses, we want to try and figure out the conditions that are most likely to have caused the conditions to be having backwinds. Right. Clear skies, we have noted that the weather station is resembling clear skies. There's no shade which represents any form of cloud cover. It's a valid response. General winds, we cannot talk of general winds. We have seen that the wind speed was at 30 knots. Which is not general in that instance, which means the response item number 2, we are phasing it out. Then we also talk of a large temperature range. If you see the temperature range on that weather station, we had a minimum of -9 and a maximum of +27, which resembles that there was a very big temperature range. There was a very wide temperature range of 36 degrees Celsius. And the implication is such that the conditions before the coming of the backwinds, it was extremely cold with a temperature of a minimum of -9, and then with the coming of the backwinds, the temperatures rose from that minimum until they got to a higher temperature of 27 degrees. So a large temperature range is a possible response. Then southeasterly winds. The wind direction, we've seen that is not even a southeasterly wind, so we are phasing out the last response. So the remaining response is clear skies and a large temperature range, which gives us a combination of item number 1 and item number 3. The combination falls at option number A, which is the correct response for that question number 117. It gives us the response at A. Right, that was question number 1.1. Then we proceed to item number 1.2. Basically, it's a question which is based on urban climates. Right. And before you figure out the questions, we need to familiarize with the concepts of urban climates and how the climate conditions are modified by the urban environment. Because you remember, an urban climate is a micro climate, which means it's a unique climate for a particular geographical region, for a particular smaller geographical space, which is an urban setting. So there are different factors that shape and that determine the climatic conditions that are realized in an urban settlement. Right, now let's look at the questions. We got question number 121. Slopes in a valley facing the equator are warmer because the area covered by insolation is dash, with the responses Y and Z being smaller and greater. Right, here we are looking at, for the perspective of the southern hemisphere, we are saying we are referring to the north-facing slope or the southern slope. The north-facing slope in the southern hemisphere is the one which is facing towards the equator. And if you are looking from the northern hemisphere's perspective, we are saying we are looking at south-facing slopes or the northern slopes in the northern hemisphere. Those are the ones which are facing the equator. So we tend to find that they have warmer temperatures, or they are warmer generally, because the area covered by insolation of that slope by insolation, because they face towards the direction of the sun. North-facing slopes in the southern hemisphere, they face towards the sun, and south-facing slopes in the northern hemisphere, they also face towards the sun. So basically, the area that receives insolation in those slopes, the area is larger. So our correct response qualifies to be Z for that response, for that question, which is Z for number 121. We go to number 122. Anabatic winds are dash winds. Right, you need to distinguish between anabatic and katabatic. Right, we know those are typical valley winds. It's also a microclimatic environment. When we talk of anabatic, we are looking at the day winds, which are upslope winds. Anabatic winds, they happen during the day. They blow from the valley floor going to the valley sides. And the opposite is true with the katabatic winds. They are night winds that flow towards the valley floor from the valley sides at night. So in this instance, we have defined what anabatic winds are, and we can figure out the correct response from the explanation and the definition of the two types of winds. Anabatic winds are upslope winds. That is the correct response for that one. They are upslope, which is Z. Then we move on to number 123. Anabatic winds are dash pollutants found in the valley. Right, when you talk of an upslope winds and you are talking of pollutants being concentrated in a valley, when there is an upslope winds, it means it takes with itself the pollutants within the valley as it goes up the valley sides. So it means it disperses the pollutants from the valley, which implies that the correct response for number 123 is letter Y. Right, we move on to number 124. The type of precipitation found in a valley when dew point temperature is above 0 degrees Celsius. We are saying the minimum temperature is above 0 degrees Celsius. In that instance, what type of precipitation forms in a valley? Right, the correct response there qualifies to be fog. Why we are not saying frost? Because frost only forms when the temperatures fall to freezing point, which is 0 and below 0, which means we can only have the formation of frost in the valley at temperatures maximum 0 to minimum of negative temperatures. So that qualifies fog to be the correct response in that instance. We move on to the next question, number 125. Right, number 125, winds at A will be dash than winds at B in the sketch below. Let's try to analyze the sketch. We are seeing those are winds blowing in an urban environment. And where we see our B is falling on an open space, just by the sides of the taller buildings. And our A is falling in within the taller buildings. So, will the winds at A and B comparably, which ones will be weaker or stronger? If we check on B here, there is open space and there is free flow of air, and wind flows freely across area B, which will imply that the winds will be less stronger compared to the winds which will blow along channels at A. A is more of a channelized winds which are forced to blow in a given direction because of the barricade or the blockade which is caused by the buildings. So the winds will become stronger as they get concentrated and they get to be channelized towards a given direction. So they become stronger. So in that instance, our correct response is item Z for stronger. Right, we move on to the next question, which is question number 1.2.6. The main factor contributing to the heat island effect in the sketch below. Right, if we check the sketch below here, we can see these arrows which are from one building to the other and back, and the other building and back. What might be causing the heat island? And remember, when we're talking of a heat island, we are talking of an urban area with a higher temperature compared to the surrounding rural area. What causes higher temperatures in this urban area here in this given sketch? The correct response there is multiple reflections, which is indicated by those arrows that we can actually see. So the correct response there is Y for multiple reflections. Why Z is not correct is the buildings are not of the same height, and if you check the reflections indicated here, they are even higher than some of the buildings on the extreme side. So we cannot qualify height of buildings to be the correct answer for that one. All right, move on to the next question, which is question number 1.2.7. Right, the sketch below illustrates a pollution dome during the, is it day or night? Right, if we check on the shape of the pollution dome and the concentration of pollutants differs between daytime and night time. Right, during the day, because of the higher temperatures within the city, they tends to develop a low pressure system within the city, which will attract incoming winds from the surrounding farmland or the surrounding countryside. So there tends to be a low pressure and rising air within the city because of the incoming air which is fed towards the low pressure within the city. So the pollution dome is elevated during the day, is raised up during the day because of the convection currents that are realized because of the high temperatures within the city that lead to a low pressure that attracts incoming air from the surrounding countryside. So this shape here is typical of the night situation. You can see that the pollutants are concentrated, and also the dome is having a unique dome shape and is just close to the tallest buildings in the city, which resembles that it's a night situation where we have a sinking air, which will push the pollutants further down and closer to the buildings. And the concentration, you tend to find that it's high at night than during the day. So that one, the correct response is the night pollution dome. It's a night situation. Right, we move on to the last question on that section, which is number 128. The type of pollution dome in question 127 is because of what causes that in relation to convection. Right, convection is low. There are no convections like what has been discussed earlier on. When you have convection, the pollution dome is raised and the pollutants are dispersed up into the upper atmosphere. But when there is low convection, it means the pollutants will become concentrated and the pollution dome will be lowered down. So it means that's low convection for that response. Right, that's the end of question number 1.2. We move on to the next question, which is question number 0.31. That is basically a synoptic, a satellite image on a mid-latitude cyclone, which is likely approaching South Africa. Right. The question is talking about point A here on the synoptic map. Right. You can see if we try to figure out this illustration of this satellite image, you tend to find that we have a cold front on this side here, a cell on that part of the system. Right, you can see also that if we try to use the argument that we were using there of that drawing, you can see that's the point where the cold front has caught up with the warm front, or where there is an occlusion on that part of the weather system. And you can also see based using on the density of the cloud. The cloud there, you can see that there is a dense cloud around that particular area, right, which resembles that warm air has been uplifted from that particular section, causing high condensation level on that particular part. Warm air has been displaced from the ground surface. So basically, that's the evidence that we can use to support that it's a low pressure around point A. Then we move on to question number 3, 1.33. Describe the rainfall usually associated with the cloud type at warm front. At the warm front around here, what kind of clouds do we tend to find? Right, maybe if we can try to illustrate this drawing using a cross-sectional view, we can tend to find that we have something that looks like on this part here, we have the cold front, and maybe on this part, we have the warm front going in that direction. And we are saying our weather system is moving in that direction. So we are looking at the clouds that develop along, we are saying this is our cold front, indicated by this, and this is our warm front, indicated by this. We want the type of clouds that develop around this area here, which is the area along the warm front. We know well that around this area, we have incidences of towering cumulonimbus clouds, but that is not where our question is coming from. Our question is solely based on this part here. We want the type of rainfall that is a resultant effect of the clouds that form along the warm front. Right, in that instance, we have light to moderate rainfall over a wide area. The rainfall there will not be as heavy as the rainfall that we receive here under the cumulonimbus clouds. The rainfall here will be light to moderate rainfall, which will be extensive. It covers a wide area and often lasts for several days. The rainfall here will be prolonged rainfall. It's not very heavy, but it's moderate to average rainfall, but which lasts for quite a number of days. Why does it last? Is because this warm front moves gradually, and this cold front is the one that moves faster. So it means clouds will form gradually and will produce rainfall gradually as they are pushed by the coming cold front. And this area will keep on receiving moderate to light rainfall for prolonged periods until the coming of the cold front, which will completely displace the warm and moist air. So the correct response there, we should highlight that the rainfall is a wide area. And why the interior of South Africa experiences clear conditions. If we check on this map, the interior here is basically clear. Why is it clear in that instance? Right, we can relate to the coming of this weather system here. If we check this weather system, it's just very close to South Africa here, which means it's likely to impact on the western coast of South Africa. When does that happen? This happens during winter. We have the coming of cold fronts or the mid-latitude cyclone affecting South Africa during the winter season. And that is also where we have to find out that we have clear conditions over South Africa. The reason being that during winter, and we have the dominance of the Kalahari high pressure cell over the interior. We have the dominance of sinking air, which creates stable weather and clear skies over the interior during this particular time of the year, which is the winter season. So basically, the clear conditions are attributed to the Kalahari high pressure cell, which causes stable conditions over the interior and giving us a clear skies. Right. We move on to the next question, which is question number 135. Right. In a paragraph of approximately 8 lines, explain how approaching cold front changes cloud cover and winds experienced at area B. We should make sure that for this question, you address the two aspects in the question. Address the aspect of cloud cover and also address the aspect of winds. Right. With cloud cover, when the cold front is approaching, it will ultimately cause increasing cloudiness of the area. Area B is going to experience an increase in clouds. And as time moves on, the clouds will become thicker and more extensive as the cold front approaches. So it's increasing cloudiness at point B because of the cold front will be coming and pushing the warm and moist air to condensation. And as the cold front approaches, the clouds will thicken. They will become more thicker and they will become more extensive. You need to say they will cover a wider area. And we will have instances of towering cumulonimbus clouds developing over that area with the approaching of the cold front. That is basically the cloud changes Then with the wind changes, we are looking at the wind speed is going to increase with the coming of the cold front, and also the winds will become stronger as the cold front approaches. And with the near approaching of the cold front, we will tend to have gust winds when the front is just coming, and that will have a potential of causing harm with the coming of the cold front. That's basically how the wind is also going to change over that particular point B. Right, that is question number 1.3.5. We move on to the next question, which is a question on tropical cyclone Freddy. Right, this information provided here is an extract, and there is also an illustration of the path that was followed by that tropical cyclone. Right, we won't spend much time looking at the extract, assuming that the extract has been well understood. Right, let's go to the questions. Number 1.4.1, it talks about on which date did tropical cyclone Freddy hit Madagascar. I think that is basically extraction. The answer is there in the extract, where it says tropical cyclone Freddy formed on 6 February in the Indian Ocean, northwest Right, tropical cyclone hit Madagascar on 21 February and Mozambique on 24 February. So basically our answer, we were worried about Madagascar. The answer is straight forward from the extract, which implies that the correct response is the 21st of February 2023. That is when it hits Madagascar. Right, number 1.42. Why was the impact of tropical cyclone Freddy more severe or destructive in Mozambique than in Madagascar? Why did it cause more harm in Mozambique than in Madagascar? Right, the reason there is the tropical cyclone, if we check, Madagascar is here and Mozambique is there, which will mean that for this cyclone to come from Madagascar to get to Mozambique, it has to cross through the Mozambique channel here. From the 21st of February, when it hit Madagascar, it crossed the Mozambique channel and reached Mozambique on the 22nd of February. So the reason why we are saying because the impact was more destructive in Mozambique is because the cyclone re-intensified, or it went through cyclogenesis over the Mozambique channel. It strengthened over the Mozambican channel, or it went through a cyclogenesis process, which means it gained more power as it was crossing the Mozambique channel. Right, let's go to the next question. Refer to the path of the tropical cyclone. Give 2 reasons why tropical cyclone Freddy changed from a tropical cyclone to a tropical depression from 21 February to 22 February. Right, you can also relate these 2 questions. They are almost related from the way the question are appearing, because you are looking at 21st February in Madagascar and 22nd February over Mozambique. Right, so the reasons why, because we have said it re-intensified over the Mozambique channel. What reasons can we give here? Because we know that the tropical depression is more destructive than a tropical cyclone, which means the wind speeds are different for a tropical cyclone and for a tropical depression. Why is it that the winds were more destructive? And what happened for it to transform from being a cyclone to become a depression? Right, the reasons that you can give there is because of the warm ocean water over the Mozambican channel. Remember, for tropical cyclones, they need warm oceans. So it went through cyclogenesis because of the warm ocean waters over the Mozambican channel, which provided it with energy to revive its power and to revive its circulation and become more stronger and cause more damage over Mozambique. And also we can talk of high humidity. Humidity fuels the cyclones. They strengthen using the power. When they release latent heat, they gain more power. So also because of the Mozambican channel, being having warm waters, it also meant that it was fed with high humidity, and which also contributed towards the cyclone being more stronger as it went towards Mozambique. Right, we can move on to the next question, which is question number 1.44. Why is the northwesterly path taken by tropical cyclone Fred considered unusual? Right, before I answer this question, I would maybe want to clarify on the normal path that tropical cyclones form. Right, we know that tropical cyclones, in this instance, in our hemisphere, the southern hemisphere, they move in a direction which is from east to west. And that is the ordinary and that is the general movement path of tropical cyclones under normal conditions. They move from east to the west, right? And why do they move in that direction? It's because they are under the influence of the trade winds or the tropical easterlies. That is why they move in that direction. But if we check for this path here, for this tropical cyclone Freddy, we also tend to find that because of the combined effect of this movement of the tropical cyclones being driven by the trade winds also are influenced by a Coriolis effect, which will also cause them to deflect. And if we try to check or to refer back to our trade winds deflection in the southern hemisphere, we tend to find that our deflection is to the left, which will mean that the tropical cyclone, if it's being deflected with the movement of with the effect of Coriolis force and with the movement of the tropical easterlies, which are also under the influence of Coriolis force, we tend to find them twisting towards the south. But in this instance, it defied that. So why was it unusual? Why is it unusual? It is unusual because the northwesterly movement, it defies the typical clockwise rotation of tropical cyclones. We tend to find them having to twist slightly to the left or to the anti-clockwise as they get inland over Africa here because of the influence of Coriolis force. But in this instance, it's unusual because it's going against that circulation, that rotation. It's defying that rotation, which means it's an unusual movement of that tropical cyclone. Right, we move on to the next question. Number 1.4.6. Explain how the damage to infrastructure caused by tropical cyclone Freddy could have a negative impact on people in the affected areas. Right, the question here is specific, is referring to the damage to infrastructure and how does it pose negative impact on people. So we need to be very articulate when answering this question. We need to ensure that we indicate what damage to infrastructure has been realized by the tropical cyclone and how it impacts on people in the area. So I'll highlight just a few examples for this instance. We can talk of damage to roads being a form of infrastructure, the road network being damaged by the tropical cyclone. How does it impact on the people? We can talk of difficulty in transportation of goods or difficulty in access to services. People have difficulties in accessing their services that they want because they need to be transported via the road network, or they have difficulties to access goods that they want because the road system or the road network has been disrupted by the cyclone. Then you can also talk of the damage to houses. Tropical cyclone Freddy caused the damage to houses. How does it impact on the people? It results in homelessness. If people's homes have been destroyed, then it's a problem to the people, them becoming homeless. And damage to buildings, we can talk of damage to buildings like productive buildings like the factories and the industries. That will result in loss of jobs to the people, or that can result to unemployment. That is also a negative implication on infrastructure and resultant effect to people. And also we can talk of damage to communication networks. That can also, a communication infrastructure can be damaged by the cyclone. That will result in disruptions in communication or difficulties in people communicating. So basically we need to be articulate. We need to find the damage that has been done to infrastructure and its subsequent impact to people. Right, then we move on to question number 1.5, which is the last question on climate. All right, the question number 1.5, it says refer to the sketch below which illustrates the development of line thunderstorms and during summer. Right, we should be able to interpret this diagram clearly before we try to answer the question. This is typical of traveling disturbances that happen during the summer season. Right, we understand that this is the interior of South Africa, and over the interior of South Africa, when it is summer, we tend to have the existence of the thermal law over the interior here because of intense heating. The ground is intensively heated, and it results in rising air, creating a low pressure over the interior. So we have the existence of the low pressure cell over the interior. And remember, we have our two high pressure cells over the Atlantic and over the Indian Ocean. And the resultant effect is that there will be pressure gradient between the South Atlantic high pressure cell and the interior, and also there will be a pressure gradient between the South Indian and the interior. So the resultant effect is that the anti-clockwise circulation of air out of the high pressure cell here will feed into the low pressure cell that has developed over the interior. And also the anti-clockwise circulation from the South Indian high pressure cell is also going to feed over the interior of South Africa, which will be having a thermal low. So those two air masses coming from different directions, apparently they will have to meet somewhere over the interior, and they will create this weather system which is indicated over this interior here. Right, let's not waste time by explaining. Let's go to the questions. Right, we have question number 1.51. Identify the front at A. This front here at A. This is a moisture front. It's a moisture front in that instance because of what happens at this front here. We have incidences of cloud formation and heavy rainfall forming along that front. So it's termed a moisture front. Right. Then we move on to the next question. Give the wind direction at B and C. Right, what wind direction is this one and what wind direction is this one? The wind which is fed from the South Indian here, from B, let's start from at B here. The wind which comes from B, which is fed from B in this instance, is a northeasterly wind. This is coming from a slightly northern direction and from the east because it's coming from over the Indian Ocean. So it's a northeast, and this one coming from the Atlantic, this one becomes a southwesterly wind. So it's southwest from this side and northeast from this side here. Then state the moisture content of air masses B and C. Right, the moisture content we figure it out from the nature of the oceans from which these high pressure cells are located. This one is located over the Atlantic Ocean, and this one to the east is over the Indian Ocean. So the implication is over the Indian Ocean, remember it's a warm ocean, we tend to have a warm ocean current here, and the resultant effect is that the winds which come from this will be warm and moist. And here over the Atlantic, it means for the fact that it's a cold ocean, it means we have a cold ocean current, and the winds which blow from this high pressure cell will be cold and dry. So when you are comparing the moisture content here, we are saying the winds which are coming from B here, in this instance, the air mass B will be moist or will be humid, and this one coming from this side will be dry. So it's humid, moist from B, and it's dry from C. Right, explain the formation of line thunderstorms over the interior of South Africa. Right, we'll try just to summarize on that one there, how the moisture front forms. Right, the basic instance is that the high pressure cell over the eastern part, which is the South Indian, it feeds in warm and moist air, and the high pressure cell over the Atlantic Ocean, the South Atlantic, it also feeds in cold and dry air. Because of its anticyclonic circulation, it feeds in cold and dry air. From the South Indian, it feeds warm and moist air. And the existence of a low pressure cell over the interior attracts these two air masses because of pressure gradient. And they meet along the moisture front. As these two air masses meet, we know well that cold air is denser than warm air. So at the front here, the air coming from the Atlantic Ocean, it undercuts the air coming from the Indian Ocean, resulting in an upliftment of the warm and moist air and formation of clouds on the side of the warm and moist air. So the front forms by that fact that there is air which is fed from the South Indian high, which is warm and moist, and air which is fed from the South Atlantic, which is cold and dry. They meet because of the pressure gradient created by the thermal law over the interior, and as they meet, because of the differences in density and the differences in temperature, they cannot mix. This one is cold and dry from the side, and this one is warm and moist. This one, which is cold and dry, it undercuts or it wedges under the warm and moist. That is how the moisture front forms. And the line thunderstorms will develop as a result of the development of the clouds. As this warm and moist air is forced to rise, it's going to create cumulonimbus clouds that will result in thunderstorms happening along the moisture front in a line, which we call the line thunderstorms. Right, let's move on to the next question. What is the positive impact of heavy rainfall associated with line thunderstorms on the physical or natural environment? Right, the responses here are just simple. We are looking at the implication of having moisture being fed to the natural environment. How does it impact? We can talk of replenishing of water sources, which will benefit the aquatic life. We have different aquatic ecosystems and aquatic life. Those creatures and those animals and plants, they will benefit from the replenishment of water sources. And also it can argue that it adds soil moisture that promotes vegetation growth. That is good for the environment, for the natural environment, that we have the growth of vegetation because of the feeding in of moisture to the ground. Or we can argue that it provides water for the wildlife, which is also part of the benefits to the natural environment. So basically those are the expected responses from our first question on climate and weather. Right, we quickly move on to the second question, which is geomorphology. Right, geomorphology, we are doing fluvial geomorphology. In this instance, we are looking at the study of rivers. Right, I will go through the questions in as quick as is possible. Right, we look at question number 2.1.1. This is a column question. Right, dendritic stream pattern, is it Y or Z? Right, in this instance, we know well that the term dendritic is a derived term from the Greek term dendros, which means a tree and its branches. So when we're talking of a dendritic pattern, we are looking at a pattern which resembles a tree and its branches. So if we try to check on those two patterns, the one that reflects a tree and its branches, we tend to find that is Z in this instance. Our Z is the one which resembles a tree with its branches. This one is now a rectangular drainage pattern on Y. Right, we move on to the next part, which is item number 212. Question number 212. The stream pattern develops on a dome. Stream pattern that develops on a dome. When you're talking of a dome here, we're giving an example of an elevated landscape. For example, a volcanic landscape, where we have a lake on top of a volcanic dome, or where we have that we call a caldera lake, which forms on top of a volcanic mountain. We tend to have streams radiating from a focal point. The streams, they will develop from one source and they will radiate into different directions. So the stream pattern that we tend to find on that instance is radial. Radial, the streams will be radiating from one focal point in different directions. The source being an elevated landscape, and they will be flowing towards low-lying areas in different directions in a radial form or radiating from a core focal point. Right, we go on to question number 213. Stream pattern characterized by short tributaries joining the main stream at right angles. Right, you are having a situation whereby the tributaries are shorter but the main stream is longer. It resembles an area which is mainly folded, where we have maybe a folded area or a faulted area where we have a rift valley or a graben and two nearby a host or block mountains, or where we have folding, we have two fold mountains existing side by side and we have a valley in within. The system that we will develop there is that we will have a major river which will run through the valley, and we will have short tributaries emanating from the folds by the sides or emanating from the block mountains by the sides. So that system that we tend to have there is what we call the trellis drainage pattern. Right, we move on to the next question. 214. The underlying rock structure of the stream pattern below has what causes this? This type of pattern is typically a rectangular drainage pattern. What kind of rocks contribute towards the development of rectangular pattern? Right, the correct response for that question there for number 214 is Y, where we have cracked and jointed rocks. This pattern is influenced by the cracks of the underlying rocks. The streams will follow the areas of weakness which have cracked, so they will follow those cracks. So the streams, they will be influenced by the underlying existing cracks along the rocks which are below that area. We move on to question number 215. It talks about drainage density of a river system flowing in areas of high permeability. Where we have high permeability, we are looking at a situation whereby the soil or the underlying rock material allows for infiltration and percolation. Rainwater is allowed to filter into groundwater storage. So it means, remember, for us to have high drainage, we need to have high surface runoff and limited infiltration. And if it is the opposite, we have less runoff and more infiltration, it means we will have less streams developing in that particular area. So in this instance, we are looking at a situation whereby drainage density of the river flowing in areas with high permeability, it means there is more infiltration compared to surface runoff. So we tend to have limited number of streams developing in that particular area. So the correct response for number 215 is low. We'll have a low density in that area. We have limited streams. Right, let's move on to question number 216. Question 216 is on stream ordering. Right, the stream order at X. Right, before we even answer that one, let's try to elaborate and try to simplify how we come out with the stream orders. Right, I will try to illustrate and show how we do the ordering of streams in the basin. Right, number 1 plus number 1 is stream number 2. Get number 2 plus number 1 is maintains number 2. We get number 2 plus number 2, it gives us number 3. Then if we have number 3 plus number 1 is number 3, and number 3 plus number 2 is means number 3, and if we have number 3 plus number 3, we get number 4, and so on, going in that order. That is how we do our stream ordering. So I will try to label those streams. Right, a number 1 stream in a drainage basin is an independent stream without a tributary. So we tend to find that this is number 1, and this is number 1, this is number 1, number 1, number 1, number 1, number 1. Those are number 1 streams in that particular basin. And number 1 plus number 1 here means we have number 2 from this confluence here. And number 1 plus number 1, it means number 1 plus 1 here. From this confluence, it means we now have stream number 2. And number 1 plus number 1 in this instance from this confluence, it means this one is now number 2. And let's go back to this confluence here. This is number 2 plus number 1. The order does not change. It's still number 2. Then we are going on to number 2 plus number 2 in this instance, we are moving on to the next order, which means after this confluence, we have stream order number 3. Stream number 3 plus number 2, the order does not change. It remains 3 here after this confluence. So the correct response here is Z. That is the correct order for that particular point X in that drainage basin. Right, we move on to the next question. Characteristics of first order streams in a drainage basin. Is it straight and short or straight and long? Right, first order streams, they are not long. A high order stream is the one which is longer. Like for example, if we check here, stream order number 3 is starting from here going all this long. But stream order number 1 is just from here to here. Or if we check this one just from here to here, here to there, this becomes a shorter stream. It's straight and short, right? So the response here is Y, number 1, 2, 7, right? We can move on to the next question, which is number 2.2. Quickly is on the concept of stream piracy or river capture. Right, it has river R to the extreme west and river Q to the extreme east. Then there's a watershed in between. Then all those processes happening there. Let's quickly go to the questions. We want to answer the questions as fast. Right, number 2.2.1, it says the sketcher illustrates A or N. Is it a longitudinal, plan, oblique, cross profile? Right, this one here, it qualifies to be a plan view. We cannot say it's a longitudinal because the longitudinal profile shows the gradient of the river from its source to its mouth. And in this instance, it's not one river. We are looking at the river R, river Q here, and river S, which later developed after the process of river capture. So this qualifies to be a plan view in that instance. Right. Then number 2.2.2, a river capture is taken place because tributary P flows on dash rock and over a dash gradient. Right, for river capture to take place, we need conditions where one river is flowing, is more energetic than the other river. And the energetic river advances through headward erosion towards the less energetic river across the watershed. It cuts through the watershed and approaches or intercepts the headward waters of the less energetic river on the other watershed, on the other drainage basin. And remember, the energetic river is usually the one which is on a lower ground, which is less elevated. It cuts through headward erosion until it cuts through the watershed until it intercepts the headward waters of the less energetic river on an elevated platform. So in this instance here, if we check our river tributary number P, if we try to figure out using that argument, we can say the nature of rocks. For this river to effectively erode headwardly, it needs to flow over softer rocks. So item number 1 qualifies, we disqualify harder. And what kind of gradient here? The gradient for this river to be energetic, it needs to flow over a steeper gradient. It approaches a river which is high-lying, so that it erodes headwardly across the watershed and be able to reach the other drainage basin. So item number 2 for harder and item number 4 for steeper gradient they are the responses which are relevant to that question, and the combination comes with letter option B, which is item 1 and item 4. Right, we move on to tributary, question number 2.2.3. Tributary P, as illustrated in the sketch, is a dash stream. Right, the labels for this water, it just label all the aspects here, river R and river Q. Right, this tributary P is the one which intercepted the headward waters of river Q. So it means this one is the captor. Captor is the one that intercepts the water. Then this one is the captured. And where the stream piracy took place, this particular point here, the bend around here, this is what we call the elbow of capture. Then this river here, which continues after river capture, is what we call the beheaded stream. And then this part here, which marks a gap between the old river which was feeding into this one, and the new river starting from here is what we refer to as the wind gap. So basically, those are the concepts related to stream piracy. We have the captor, the captured, we have the able of capture, we have the wind gap, and we have the beheaded stream. Right. So if we are going back to our question, stream P, we have illustrated and we have labeled everything on that particular section of the river capture process. Tributary P qualifies to be the captor. It has captured headward waters of the stream on the other drainage basin. Then number 2.24, the process in which tributary P lengthened its channel by cutting through the watershed is known as, right, the process that aided tributary P to cut through, that what kind of process is that one? That one is headward erosion. Right, remember we have three basic types of erosion that takes place within the river channel. Right, we have headward erosion. Headward erosion is responsible for lengthening the river channel, is the one that is responsible for making the river longer, which means it happens at the source of the river. The river source keeps on migrating towards the watershed. It migrates, meaning to say the length of the river will keep on increasing. That is headward erosion. Then we have vertical erosion. Vertical erosion is responsible for deepening the river channel. The channel becomes deeper through vertical erosion. Then lastly, we have what we call lateral erosion, which is sideway erosion. Sideway erosion is responsible for widening the river channel. So basically, those are the three types of erosion. So relevant to this question here, our type of process which is responsible for making river tributary P be able to cut through the watershed, it was aided by headward erosion. Right, we move on to the next question. Feature T is known as A or N. That is question number 2.25. We have already discussed that. That bend is called the able of capture. Right. We move on to question 2.26. River R will have a dash drainage basin and A or N velocity after river capture. Right. If we check on river R here in terms of its basin, river R used to have a basin which was this side of the watershed before the process of piracy. But now its basin is now extending going towards there, because this part of river Q is now part of its basin because it's now being drained by this same river here. This is now a tributary of river R. So its drainage basin has been increased by the process of capture. So if we check on the responses here, it becomes larger. And the velocity, how does the velocity of the river, how is it influenced by the process of capture? If there's more water in the river channel, it means the river has more energy. It flows much faster when it has more water. So it's larger and an increase of velocity in that river. So it's the correct combination is item number 2 and item number 3. Item number 2 and item number 3, they come on number 2.26, item option number 6. That is the correct response. We move on to the next question. Refer to area U on the sketch where the river rejuvenation occurred. To answer question 227, 228. River rejuvenation occurred due to A or N and dash erosion that took place. Right, river rejuvenation. Some of the causes of river rejuvenation is isostatic uplift, which is indicated. Increase in volume of water, yes, is also a cause. We can also talk of other causes, like an increase in the rainfall received in the area is also a cause or a contributing factor of rejuvenation. But in this instance, our cause is direct. The rejuvenation or the revival of the river's erosive power is being contributed to by the increase in the volume of water. There has been stream piracy, and this stream piracy is contributing towards the increase in the discharge of that particular river, which will also imply that its erosive power is going to be revived. So it's increasing the volume of water, item A. We are cancelling item number 2. Then what kind of erosion happens if a river is rejuvenated? When a river revives its erosive power, it regains energy to cause vertical erosion. It regains power to erode vertically and deepen its channel. That is why we tend to find that we have the development of landforms like valley in valleys after rejuvenation. The meanders, the entrenched meanders rather. The entrenched meanders, they are a result of incision by the river, which will mean that the river will be deepening its channel through vertical erosion. Or where we have the paired terraces, those terraces are realized because of the development of a channel in the old channel. So it will mean that the river will be regaining its capacity to cause vertical erosion. So the correct response is item number 1 and item number 4. Those two responses, they correlate at item increased volume of water and vertical erosion. Increased volume of water is item number 1 and vertical erosion is item number 3. 1 and 3, which means the correct response there should be item number A, response A. Right, we move on to the next question. The resultant landform most likely to form after rejuvenation in area U is A or N. Right, let's go to area U and try to analyze what landform is likely to form. This area marked U here, you can see this river. If you can check, the river is winding, is meandering around this area. So when there is rejuvenation, the river rejuvenates and already the channel was meandering. What is the likely landform that is going to form in that particular part of the river? Definitely the correct response here, we are going to have the incised meanders are forming over that area. Right, that is question number 2.2. Let's quickly move on to the next question, which is question number 2.3. Question number 2.3 is based on the longitudinal profile of two rivers, river X and profile X and profile Y. Right. The first question is talking about what is longitudinal profile. Longitudinal profile, we can simply define it, though it can be defined differently according to your way of understanding, but we should address the basics. I can define a longitudinal profile of a river as the gradient of a river from its source to its mouth. How the river looks like along its course from where it starts until where it ends. That is the longitudinal profile. Right. Then we move on to the next question, number 2.3.2. A is known as this A here. What is it known as? That is a permanent base level. If you can see here, it's starting from the sea level, so that becomes a permanent. That river cannot erode below that point. If it gets that point, it attains a grade. It can never go below the level of the sea where it is feeding into. Right. And give an example of a natural temporal base level of erosion that could develop at the neck point. At the neck point, we can have a lake developing here. It can be a feature of a temporary base level. Right, we move on to the next question, number 2.3.4. Which profile X or Y is graded? When we talk of a graded profile, we are looking at a profile which resembles a smooth concave shape of the river's longitudinal profile from its source to its mouth. So if we try to check between these two, the one which is smooth concave is profile Y. Then we move on to the next question. Give a reason for your answer. I think I've already explained the answer. Why am I saying Y is a graded profile? Y resembles a smooth concave shape from the source of the river to its mouth. And then explain how the profile above the graded profile developed. Right. It is attained because of an equilibrium or a state of balance. For us to attain a grade, it is attained after the river attains an equilibrium. The rate of deposition, the rate of erosion is equated to the rate of deposition, which means whatever is eroded and whatever is deposited is the same, which means the river will maintain a smooth shape throughout its course from its source to its mouth. So basically, when I'm explaining the formation of a graded profile, it is a result of the balance between the rate of erosion and the rate of deposition. The material that is being eroded is equal to the material that is being deposited along the river channel, which will mean that the river will maintain a smooth concave throughout its profile. Then number 237, draw a rough cross profile of the river valley at B. Right, if you check point B here, we are very close to the source. We are still in the youthful stage of the river. If you are drawing the cross profile, you should ensure that your drawing should resemble, let me just simplify, a simple drawing which might be relevant. Right, we are saying the river will be having something like a profile, like something like this. Right. What happens with this profile is the profile should have a narrow valley, and the valley should be deep. Those are the basics that should be addressed by that part, because the river is still in its youthful stage. It's still in the youthful stage where it is eroding vertically. It will mean that the river will have a deep valley. The valley will be deep and will be narrow. The river will still be in the young stage or in the youthful stage. So basically, you can draw a profile which resembles something like that. A river which has got a narrow valley and which is deep. That is typical of a river. And also the discharge of the river will be very minimal. It will be having limited discharge because it's just in its youthful stage. Then give reason for the shape of the cross profile. I think I've explained before I answered before getting to the question. The reason why we have a narrow and a deeper valley is because the river is predominantly eroding vertically, and also the river is still in its youthful stage. That is why the river valley is still narrow. There is less discharge in that particular, and the type of erosion does not allow for the widening of the river channel, but rather it concentrates on the deepening of the channel. Right, we move on to the next question, which is question 2.4. Right. Number 2.4 is based on a sketch of a fluvial feature along the river channel. Right, before we look at this, let me try to explain the aspects of this diagram here, so that when we are answering the question, it becomes clear. This part of the river here, this fluvial landform, is what we call a meander. It's a bend along the river channel, which is in the river's lower course. I think you can see that the sea is illustrated here. The river is getting into the sea and it's winding its channel. The channel is winding. In that instance, it's bending. And along these bends, we have what we call the outer bend of the meander and the inner bend of the meander. Right, what we call the inner bend of the meander, for example, is this part here. This part A is what we refer to as the inner bend. And also this part here is the inner bend. And this part here, we labeled B, is the outer, and this is also the outer bend of the meander. So what happens is, as water is flowing past the bend, we tend to have that flow velocity of water here is much faster. The water flows faster. The water which goes via this outer bend will be much faster than the water which goes via this inner bend. The water here will be slower, will be having slower velocity, and the water here will be having a higher velocity. The same happens as the water is going again via past this bend here. There is fast velocity on this part. The water flows faster, and the water which comes via this side will be flowing gradually. That is what happens along the bend there. So this is what we call the outer bend, and which we call, this is the outer part of the bend, and which we call geographically the undercut. It's called the undercut of the meander, and this is called the slip off. It's called the slip off slope of the bend here. Right. These are the two parts of the meander that we are going to look at. And because of the limited velocity here, we tend to find that there is deposition taking place. Remember, whenever the energy to transport a load, the force below the minimum required to transport that load, the river will deposit the load. If the energy required to transport, the minimum required to transport a load is not reached, the river starts to deposit material. So it means there is deposition which takes place here because of the limited velocity of the water. And here, because the water flows fast, it tends to erode this outer bank here. This bank is eroded and is undercut. That is why we are calling it undercut. It means it's being cut by erosional processes happening. And the material being taken here will be deposited on the inner bend where there is limited velocity. That is what happens along the river channel and along a bend in a river channel. So from that discussion, I think we are able to figure out the responses to the questions which will follow. Right, we'll quickly go through the questions and figure out the most probable responses. Right, number 2.4.1. The fluvial landform or feature illustrated in the sketch above. In the sketch is, we have already highlighted the correct response. That one is a meander. It's a bend along the river channel. Then we go to question number 2.4.2. Give a characteristic of a river in the lower course in which this fluvial feature named above develop. We are looking at features in the lower course. What are the features of a river which is now in its old age? Right. The river there will be having a wide channel in the lower course. It's one of the features. It has a wide channel. And also the discharge volume is high or is large. The river has got very large volume of discharge. And also there is slow velocity. The water is generally slow in terms of its velocity. And also if you can check, the river is shallow. The river becomes shallower because of increased deposition. So basically those are some of the features that you can figure out. The river is shallow and there is slow velocity, and also the channel is wide, and there is a larger volume of discharge. Right, that is what happens in the lower course of the river. Then we can figure out question number 4.243. Explain how gradient influenced the development of the fluvial landform in the sketch. How do meanders form in relation to the gradient? Right, what you should know that is the gradient of the landscape where the river is going towards its mouth in the lower course. The gradient is almost gentle. It's gentle to almost flat. The river will be flowing over a gently sloping landscape. What is the implication of a gently sloping landscape towards the formation of the meander? What will happen is the river will be flowing over a gently sloping landscape, which will also imply that the velocity will be lower in that particular landscape. As the velocity is lower, the river will start to deposit load. We will start to deposit sediments along its channel. And at the end, as the river deposits some material or some silt material and sediments, it starts to wind. It means the river will be blocking its own channel. And as it blocks its own channel, it has to wind to find its way, avoiding the deposits that it has made in its own channel. And as it winds, remember we are talking of what happens on a bend. Whenever the river creates its own bend, it will mean that water which goes to the outer part of the bend will be much faster than water which goes towards the inner part of the bend. And at the end, those processes are going to further and further, and the meander will migrate. The outer part of the meander will migrate, creating a pronounced meander or creating a pronounced bend. Cycles of erosion on the outer bend will continue, and the material that is eroded there will be deposited on the other side. And at the end, you tend to find that the river will create a pronounced bend because of that process. So it starts from the gradient of the landscape. It's gently sloping, leading to low velocity of the river. Because of low velocity, the river deposits material and deposits sediment. As it deposits sediment, it starts to wind, avoiding such sediments. And as it winds, remember there is undercutting that is going to take place. as it tries to avoid the load which it has deposited in its own channel. So it means the outer part where it is trying to avoid the load is going to be undercut by erosional processes, and the material is going to be deposited on the inner side where it is avoiding, and that process repeats itself until the river has a winded channel or has a meandering channel which is bended. That is basically how we can figure out how the meanders develop from the gradient of the landscape in the lower course. Right, refer to cross-section X and Y and the fluvial landform features above. Identify slopes A and B. We have already mentioned that. Slope A in that instance, that is a slip-off slope on the inner bend of the river where there is deposition. It's called a slip-off, and slope B is the undercut, which is a slope dominated by erosion on the outer bank of the river. Right. We move on to which cross-section X or Y represents the line between A and B. From A here, we tend to find that this is a gently sloping landscape. It's more of a convex slope from A going to the river channel, and here it's more of a concave which bends inwards. It's an undercut slope. So if you try to figure out from those two, you tend to find that the slope is gentle from beginning at A, it gets into the channel, then it becomes steep as we go towards B. So the reflected cross-section of the channel is the one illustrated by Y. In that instance, is Y from A to B. Right. Which cross-section we've done that one? Explain the process involved in the formation of slopes A and B. I think we've explained that. We just have to clarify. Slope A, which is a depositional slope, which is the slip of water flows gradually on the inner bend, and sediments are deposited on that river spot because of slow velocity. This is the side here. On A here, the water flows at a less velocity and sediments are deposited, meaning to say the slope will be having a gently sloping landscape going towards the stream, the river channel because of deposition. Then slope B. B here, water flows faster on the outer bend, and it causes erosion of the outer bank here. This bank is eroded because of velocity of the water, and it becomes an undercut. Material which is being taken here is deposited here. That is basically how those two slopes form. So we are looking at the process involved in the formation of A. There is erosion and deposition on one side and the other side, and deposition causes that slip off, and erosion causes the undercut on the other side. Right, let's look at the last question on river management, river and catchment management. There's an extract there. The extract, I think, is clear and has been gone through. Right, in which province is Hammanskraal located? Right, this is NEPO interpretation. You can see where Hammanskraal is and the province indicated here, and whatever you can use this infographic to figure out. Right, Hammanskraal is located in Gauteng. It's in Gauteng province. Right, we go to question 2.5.2. What is meant by unplanned development as mentioned in the extract? The extract is talking of unplanned development. Right. We can safely relate this to a settlement. When we talk of unplanned development in settlement studies, what will we be referring to? Right. Let me try to figure out where the unplanned development part is falling under. Right. It says people have had a decade-long struggle with water and sanitation issues, serving as a clear example of what happens when unplanned development occurs. Right, basically when we're talking of unplanned development, we are looking at urban sprawl, the problem of urban sprawl, uncontrolled growth or formless growth of cities and towns. That is basically unplanned development. Or we are looking at the growth of informal settlements. Or we are looking at illegal invasions of land. That is unplanned development. So basically it has something to do with illegal settling of people, or the sprawling of the urban settlement, the formless growth of urban areas and cities, or basically the growth of informal settlements. That is unplanned development. Then give two consequences of unplanned development according to the extract. Right, the extract talks about there are frequent leaks. There are frequent leaks in the water supply or in the sewerage systems. That is one consequence. Then the other consequence is disruption in water supply. Those ones are listed in the extract. It's just extraction. So it's frequent leaks and disruptions in water supply. Then we move on to the next one. How did Apis River become polluted? How did it get polluted? Right, it's also an extract question, which is from the extract given there. The number one cause of pollution is the dumping of raw wastewater into the river. There is the dumping of raw wastewater and also dumping of semi-treated wastewater into the river. Those are the two forms of pollution which are contributed to the Apis River. Then the last question, in a paragraph of approximately 8 lines, suggest strategies the local municipality can implement or put in place to reduce pollution of Apis River. What can the municipality do to avoid the instances of pollution of that particular river? We are looking at a legislative perspective. We are looking at the local government. What can they do to try and curb the pollution of the Apis River? Right, we can talk of wastewater treatment improvement. Since we have noted that there is wastewater which is being dumped into the river, what can be done with the wastewater? How can we improve the wastewater treatment system? So we can upgrade existing systems, upgrade the existing water treatment system, or we can do regular maintenance of the water treatment system so that we do not have disposal of untreated wastewater into the river or semi-treated wastewater into the river. That is number one. Then we can also enforce legislation. We use the ruthless hand of the law to curb the problem. Enforcement of legislation by imposing penalties for violators. We can impose hefty penalties for those who cause pollution of the river. It's also an act which can be implemented. Or we can talk of intermunicipal cooperation. Municipalities can work together with other municipalities in the surrounding so that we manage the very same river which flows through the jurisdiction of the different municipalities, what we call the intermunicipal cooperation. Coordinated efforts of municipalities to try and curb the problem of pollution of rivers. Then we can also talk of private-public partnership. The municipality can partner with private businesses to find solutions to the problem of water pollution, of river pollution. Engaging with private entities, it can also help enhance resources in case the municipality or the local government is crippled in terms of its financial capacity to deal with the problem. It will imply that if they engage private partners, they might also chip in with financial assistance that will help us solve the problem of the pollution of the water sources. And also with knowledge, we might also tend to find that there might be private entities that will cooperate expertise towards the solving the problem of the pollution. And also we can promote public awareness. One of the major reasons why people pollute rivers is because of lack of knowledge on the implications of polluting rivers and the resultant effects of thereof when they pollute the rivers. So people need to be educated on the importance of river conservation and impacts of pollution. It's also a way that can be implemented to curb the problem. Then we can also talk of the protection of riparian zones. We can implement buffer zones around the rivers to limit development close to the rivers. We can fence the rivers so that we limit development close to the rivers, and also we limit unwanted activities happening close to the river. It's also an act that we can put in place along the rivers or along the wetlands. We can buffer.
Mixed bag, climatology and geomorphology. Once more, because this is where we find most challenges. All right. They say refer to figure 2.1 showing a high pressure and a low pressure cell in the southern hemisphere. Match the statements below with the high pressure cell or the low pressure cell. Write down your answer next to the question numbers 2.11 to 2.1.8 in the answer book. All right. 2.1.1 says, sorry, let us first look at the figure. Sorry about that. Let's look at the figure. So this is, let's call, let us refer to this one. Go to figure A, which is a high pressure cell. Figure B, a low pressure cell. All right. So they say associated with rising A. Is it going to be a high pressure cell or a low pressure cell? And for this case, that would be a low pressure cell. It is the one that is associated with rising A. That's why to illustrate it here on our blank page. Okay. Because we know that in low pressure cells, air converges, then it's going to rise. This is in low pressure cells. All right. So which makes our option for 2.1.1 to be a low pressure cell. 2.1.2 says air diverges on the surface from this pressure cell. Air diverges. So we go back and we show air diverges on the surface. Okay. Now let us try to demonstrate here a high pressure cell first. In high pressure cell, air subsides or descends. After descending, then it's going to diverge. Because to diverge when air moves away. Okay. So air subsides, then diverges. This is the surface. Because in high pressure cells in the upper atmosphere, air converges. You see, it is converging here, and after converging, it is able to subside, or it is able to descend, forming a high pressure cell. Then eventually it diverges out on the surface. So which means if we go back to our options, 2.1.2, it will be a high pressure. 2.1.3, associated with clockwise movement of A. Don't forget they said these pressure cells are situated in the southern hemisphere. All right. So which one between the low pressure cell and the high pressure cells move in a clockwise direction? Go back to our blank page to try to illustrate. If we have this globe here, which shows northern hemisphere and the southern hemisphere. So we know that in the northern hemisphere, low pressure cells, so in the southern hemisphere, low pressure cells rotates in a clockwise direction, and they rotate anti-clockwise in the northern hemisphere. This is typical of low pressure cells. And then high pressure cells, they rotate clockwise. These are high pressure cells. They rotate clockwise in the southern hemisphere and anti-clockwise in the southern hemisphere. So these are high pressure cells. But our question is saying associated with clockwise movement of air in the southern hemisphere. Clockwise movement in the southern hemisphere, which is this one here, is clockwise movement in the southern hemisphere, which is typical of a low pressure cell. 2.1.4 unstable weather conditions over the interior. So remember, when they say unstable weather conditions, so they are referring to things, for example, rainfall, winds, overcast condition, etc. Right. We can as well talk about, let's say, thunderstorms. So all these are examples of unstable conditions. Now, how do these develop? We try to illustrate on our blank page. We know that rainfall develops as a result of air ascending. When air ascends, it condenses, forming clouds and as well rainfall, accompanied by thunderstorms. Right? So, does air rise in low pressure cells or in high pressure cells? And we did indicate up here that in low pressure cells, air rises. See, when it rises, there will be formation of overcast clouds and there will be rainfall. So, which means that unstable conditions are associated in low pressure cells. In low pressure cells. 2.15 associated with ridging. What is ridging? This refers to the elongation or extension of isobars. Isobars away from a high pressure. So the moment I say high pressure, definitely you know what our answer is, right? Because it says associated with ridging. So ridging is common in high pressure. So what they mean? Something like this is happening. You see isobars extending away. You see, so it means this is elongation. So this part here, you can see what refer to as ridging. Isobars are extending, you see, towards that other point. So that is ridging, which is common of high pressure cells. So we say high pressure. Okay. Associated with heavy rainfall and hail, this will of course be a low pressure, because we say that in low pressure cells, we say that air rises. When it rises, it condenses, forming cloud that is accompanied by heavy rainfalls. That's why we say that to be a low pressure. 2.1.7 dominates the land in winter. That will be a high pressure cell. In winter, the high pressure cell dominates the land. How do we show that? If we illustrate it down here, regarding a high pressure cell, this could be the map of South Africa, and normally they're going to show something of that sort or that nature, indicating a high pressure. When this happens, now this shows a high pressure cell dominating the land or the interior in winter. If it was summer, it was going to be like this, because in summer, a low pressure cell dominates the land. So this is winter and this is summer. Okay. So big wind conditions develop when it interacts with a coastal low. That will be a high pressure. A high pressure cell. So if I can as well illustrate that on a diagram, it's going to be, could they say, big wind conditions develop when it interacts with a coastal low. Okay. So it means if this is our high pressure cell, for example, it means we're going to have our coastal, here we see CL, meaning a coastal low here. So if we have a high pressure cell, now there will be a pressure gradient indicating now winds are moving from a high pressure to the low pressure, and these winds are referred to as the big winds. Right. So they develop between the interaction of a high pressure cell over the land and a coastal over the coast. All right. So that is for question 2.1. 2.1. Okay, question 2.2. They say choose a concept from column B that matches this description in column A. Area drained by a river and its tributaries. That will be a drainage basin. So number D, number 2.2.2. A high-lying area that separates two different drainage basins. That will be a watershed, which is F. 2.2.3, starting point of a river. That will be the source, which is G. 2.2.4, term that describes the main river and its tributaries. That will be E, which is the river system. Point where the river enters the sea, that will be the river mouth, which is H. Elevated land that separates streams in the same drainage basin, that will be an interflow, which is B. Point along the river where two or more streams meet, that will be C, which is the confluence. Okay. 2.3 figure shows the path of a tropical cyclone. So give a path of a tropical cyclone. So they're saying give evidence that this tropical cyclone is in the southern hemisphere. How do we tell it is in the southern hemisphere? Firstly, can we indicate the clockwise rotation, clockwise symbol, clockwise symbol. Clockwise symbol, and as well countries found in the southern hemisphere. Countries found in the southern hemisphere. In the southern hemisphere. What else can we look at? The date, which is April. So I think it is still summer. April. Yeah, I think that date. About the date. Which shows summer. Which shows summer in southern hemisphere, because April is still not yet winter. We're still experiencing high temperatures. What else can we look at? The Mozambique Channel, which is in the southern hemisphere, as well mentioned. The Mozambique Channel found in the southern hemisphere. All right. Now they say 2.3.2. Why is the Mozambique Channel usually ideal for the increase in temperature within the tropical cyclone? So consider Mozambique Channel experiences warm ocean currents which rises the ocean temperatures. Experiences warm ocean currents which rises ocean temperatures. 2.3.3, explain how the intensity of the tropical cyclone increased as it moved from area A to area B. Area A, area. So explain how the intensity of the tropical cyclone increased as it moved from area A to area B. So you can see area A to area B. This is the Mozambique channel. So don't have to explain how the intensity of the cyclone increased. Okay. So that is what, which question is that? That is question 2.3.3. Question 2.3.3. So the intensity increased massively the warm temperatures resulted into high rate of evaporation there was high rate of condensation which resulted into high latent heat supply. As well say there was less friction with the land to slow down the winds and intensity of the cyclone. As well say this area due to high temperatures it resulted in further development of a low pressure. So that's how the intensity, of the cyclone increased as it moved from area A to area B. All right. 2.3.4 discuss the conditions that could have caused the cyclone to weaken as it reached area C. So let's remove this one so that you can see clearly. So they say discuss the conditions that could have caused the cyclone to weaken as it reached area. So this is area C here. That's area C is almost close to the land. All right. Let's go back, discuss the conditions that could have caused the cyclone to weaken as it moved to area C. That is question 2.4. 2.3.4. This is 2.3.4. 2.3. So I could say friction with the land weakened cyclone, as well say cyclone moved into cooler areas, because we know that cyclones, they love warm conditions. So if they move towards cooler areas, this as well weakens them. Okay, as well say less supply, less evaporation, and condensation. Meaning less supply of latent heat. So let's check again. At point C would have been the reason which caused the cyclone to weaken. Spoke about friction with the land, the supply of latent heat, moving into cooler areas, among others. So for now, I think shall go with those factors. Let's proceed to question 2.3.5, which says evaluate the physical negative impact of the coast cyclones along the coast of Mozambique. The physical negative impact of the cyclone along the coast of Mozambique. It is 2.3.5. The negative, so cause coastal flooding, destroying the coastal areas, results into flooding of farms, causing soil erosion, infrastructures, such as roads, buildings. Destroys the natural habitats. Disrupts the ecosystems. So also due to heavy rains, it could cause landslides and landslides. So, among other physical impacts. All right, so that is for question 2.3. So we're going to go to 2.5, which says, refer to figure 2.5, which shows a river capture or stream piracy. Define the concept river capture as shown in sketch B. So this is sketch B here. So before, you can see we have a watershed. There's this other stream flowing the other side, the other one flowing this other side. So there's a watershed in between them. So this is after capture. You can see this one was able now to store the other river, and this one was left without the source. Okay, so define the concept river capture, so this is what I say: energetic river steals headwaters of a weak river steals, or can as well say robs. Okay, steals or robs. Identify features 1 and 2 of river capture in sketch B. Features 1 and 2 of river capture. So feature 1, the elbow of capture. Feature 1, that's going to be the elbow of capture. What do you call the elbow of capture? As you can see, it forms an elbow. So this is an elbow, so like there is a curving here. So notice the elbow of capture, it is the point where capturing took place. And feature 2, that will be the wind gap. The wind gap or a dry pen. So that is an area. Feature 2, this point here, that area which is now dry. There's no more water at that particular point. Okay. Then we look at question 2.5.3. What could have caused the capture stream to erode through the watershed? Remember, when they say capture stream, this is the same as the energetic stream, or the pirate, or the one which store water. Right. So they say, what could have caused the capture stream to be able to erode through the watershed? We'll say the watershed, like you can see here, this is our watershed. Figure A high-lying area which separates two different rivers or different basins. So you can see that this river was able now to erode backward through this watershed and was able now to intercept the other river. That's why when you look at the figure B, you can see nicely that the other river, it has been robbed of its source. Okay. Then the question is asking what could have caused the capital stream or the energetic stream or the pirate or the one which stole water to erode through the watershed. 253. So you could say it was flowing over steeper gradient. That's why it was able to erode faster. Steeper gradient able to erode watershed faster. Or as well as say it was flowing over a less resistant rock. To erode faster. Check the question again. What could have made it to cap the catastrophe to erode through? As well as say it was more energetic. Making it able to erode through. Okay. 2.5.4 explain the process that resulted in the formation of the misfit stream. Which one is a misfit stream? You can see this is our misfit stream. This is our misfit stream here. Misfit stream. Now a misfit stream, that is for question. Misfit stream would say a stream that lost its source. That is a misfit stream. So we need to explain the process that resulted in the formation of a misfit stream. That is question 2.54. 2.54. So we could say energetic river erode through the watershed. Energetic river intercept and stills the headwaters of a weak stream. The lower part of the weak stream is left without a source. Forming a misfit. All right. That is for question 2.5.4. So we say an energetic river erode through the watershed, as you can see here. So this is our energetic river. She was able to do edward erosion through the watershed. Was able now to intercept this stream and eventually stealing its source. That's why here, after capturing, you can see that now this stream no longer has its source. It has been now diverted, or it has been stolen, which means the misfit no longer has any water supply. That is how we could explain the formation of a misfit stream. All right. 2.5.5 says, describe the change in the flow characteristics of the capta stream. What will happen to the capta stream? Would say its erosive power will increase, its velocity will increase as well. We're flowing so fast. It will erode vertically. To be rejuvenated, to gain more water, to gain more volume of water. etc. All right. So question 2.6 says, figure 2.6 shows a river profile. All right. So 2.6.1 is the river profile in figure 2.6 graded or ungraded. So our answer for this case is going to be ungraded. Give evidence, because we could say the profile is not rough or not smooth. Rough or not smooth. As well say it has temporary base levels of erosion, temporary base levels of erosion. It is the waterfalls and rapids. So you can see this profile is not smooth, because you can see here there are waterfalls around this other point, you see. So the profile is not smooth throughout. That's why we say it is typical of ungraded profile. So 2.6.3, why would there be more erosion than deposition at A? Then we could say because the river velocity is high, gradient is steep. Let's go, I think we'll see this on our blank page 263. We said river velocity is high The gradient is steep. Gradient is steep. Allowing no erosion. Okay, so that's why we say that at A there will be more erosion than deposition. Look at the gradient. It is too steep. That's why there's a waterfall. Too steep. So where it is too steep, we don't expect materials to be deposited. Instead, the river will be eroding vertically, and as well, due to steep gradient, the velocity or the speed of the river is going to be high. Therefore, it will be eroding instead of depositing materials. 2.64, it says in a paragraph of 8 lines, explain the fluvial processes that a river undergoes to reach a graded profile. As we know, we say that this profile is ungraded as a result of temporary base levels of erosion like waterfalls, the rough surface, etc. So let's see, explain the fluvial processes that the river undergoes to reach a graded profile. So you could say the river erodes away the temporary base levels including rocks, rapids, waterfalls. The eroded materials, are transported downstream. The profile which was rough, now it is smooth. This smooth. Therefore, we shall have a new graded profile. Okay. So question 1.3 are based on climatology. The figure 1.3 shows a mid-latitude cyclone on a synoptic weather map of southern Africa. Let's check figure 1.3. Figure 1.3 there. You can see we have, there is the symbol of a cold front and home front. There is a symbol for high pressure cells. You can as well look at the isobars and sketch map of southern Africa. All right. So they say, give evidence from the diagram that suggests that the weather system A is a mid-latitude cyclone. So what evidence, yes, can we give to suggest that the weather system at A is a mid-latitude cyclone? For this question, we can see it has a cold front and a warm front. You can say because of the cold front, the symbol for the cold front, the symbol for the warm front as well. So for the warm front as well set. A bit. Talking about its location, located in the western side. Located the western side. Located in the west. That's where the MLOC or the mid latitude cyclones do originate, among other factors. Why does this weather system originate at the polar front? Then we know at the polar front, that's where we have warm winds, mid, cold winds. Okay. Because the polar front is a region where different air masses meet. That includes warm winds and the cold winds. So the mid latitude cyclones do develop at the polar front. That is where the cold easterly winds meet with the warm westerly winds. Now give a reason for the direction of movement of this weather system. Now its direction of movement, we know they move from west to east. But the question is asking that why do they move from west to east? Then we say they are driven by the westerly winds. So if you look at the diagram, usually mid latitude cyclones, they move from the west going to the east. Reason? Because of the easterly winds. Okay. Then 1.3.4, why is the cold front associated with severe weather conditions? Then we say because it lowers down temperatures. It lowers down temperatures, and as well results into overcast conditions and heavy rains. Okay. 135. Explain the formation of the stage of development shown in figure 1.3 of the mid-latitude cyclone. Explain the formation of stage of development in figure 1.3. Let's see the stage of development. I think this is going to be the occlusion stage, because you can see the cold front and warm front are mixing up, which is the occlusion stage. Okay, so I'm going to explain 1.3.5 down here. But we said it is an occlusion stage. We say it forms. I said the cold front travels faster than the warm front. Okay. Cold front narrows the warm sector. Eventually, cold front front eventually, which is the warm front. So what does that mean? If you look in the mature stage, for example, this could be our cold front. This is the warm front. But you know that the cold front is more dense, so it travels faster, so it keeps on narrowing the gap. Eventually, it will intercept the warm front, creating an occlusion. Right. For question 1.3.6, why does the cold front of the mid-latitude cyclone have a positive impact on agricultural activities in the Western Cape? Then we could say it causes winter rainfall, which favors farming. It allows growth of grapes, which are suitable for cold conditions. Okay.
September, you'll be writing paper 1, which is called Physical Geography, where we're doing climate and weather. And we also do geomorphology with 30 marks of Mapwork. Now let's look at the content that we can expect to get from the examination. There are subtopics for question 1, which is climate and weather, is subtopics, mid-latitude cyclones, tropical cyclones, subtropical anticyclones, traveling disturbances, where you are looking at the moisture front and line thunderstorm, and you're also looking at bear winds and coastal lows. Then you look at the microclimate, which is the climate that affects smaller areas, where you'll be looking at the climate in the valley and the climate that affects urban areas and rural areas, which is urban climates. Then let's start with the first topic that you started with at the beginning of the year, which is a mid-latitude cyclone. So mid-latitude cyclone, what you can expect there, you can expect the questions that want you to give or to identify stages of development and look at the features of a mid-latitude cyclone. So in the diagram that we're looking at here, we're looking at the mid-latitude cyclone, which is in the mature stage. What are we looking at? This is this diagram over here. This diagram over here. Okay, the diagram over here is showing you two fronts. This is the cold front. It's important to note that when you're looking at the gradient of the mid-lat of a cold front, of a warm front, sorry, it looks gentle and this one looks steep because of the difference in terms of gradient. The warm front will move slower than cold front, and it eventually catch up with that. And then we are going to be looking at a different stage of development. Now, let's look at the simple characteristics between cold front and warm front. The air behind the cold front, the air behind the cold front is cooler than the air behind the warm front. And then the air ahead of the warm front is also cooler because that will be the cold sector. And then you can also look at the clouds that are associated with cold front. These are the cumulonimbus clouds. That is a common question for you to be able to identify the clouds of associated with the cold front, and you must also be able to explain the formation of those clouds. Now, let's look at the cyclone in its mature stage. Now, if you get the diagram and you are asked what stage of development is this, number one, you know the stage of development here is a mature stage. The stage of development here is mature stage. And then why do you say it's a mature stage? Because we can see we have a well-developed cold front and a well-developed warm front. And then the air circulation with this cold front is clockwise. And then why is it clockwise? Because now it's telling you that this is in the southern hemisphere. And then what you need to know also is you need to be able to identify these lines that join places with the same atmospheric pressure. We call this isobars. These are the isobars, and you can see clockwise circulation. And this diagram is a map view of a mid-latitude cyclone. We can look at the diagrams before that. We can look at the diagram before that. This diagram over here is indicating the cross-section. So many times learners are requested to draw a cross-section, and they indicate this diagram. You can see the difference between this is the cross-section. With the cross-section, if the examination or the examiner want you to show the cross-section, you must not show the symbols. The symbols here, you can see here we have the symbols that indicate cold front. We have the symbols that indicate warm front. And then remember, the front symbols must always be drawn in front of a line, not behind the line, in front of the line, east of the line, always. Whether it is in the southern hemisphere, it must always be on the east of the line. It's not always it cannot be on the west. I saw people drawing mid-latitude cyclone and putting the symbols behind the front. They must always be on the east of the line if you are drawing a mid-latitude cyclone. Okay, the mid-latitude cyclone here is in a mature stage. Why do you say it's a mature stage? We're looking at the evidence here. Number one, you can see the pressure here is below 1,000. And you can also see here we have a fully developed cold front and fully developed warm front. And then you must also be able to identify this line. This is your isobar, and then a definition for isobar: line joining places with the same atmospheric pressure. And the circulation is showing clockwise circulation. It's very key for you to be able to state that the air circulation or the movement of air around the system. So we have two movements here. We have number one, movement of air around the system, and we have the movement of the general movement of the system. The mid-latitude cyclone move from west to east, or it move eastwards. Why does it move eastwards? Because it's driven by the westerlies. And then mid-latitude cyclone is a low pressure center, or a low pressure cell rather. So why is it a low pressure cell? Because the pressure in the center is at its lowest. Then we looked at the cold front and the warm front and the clockwise circulation of air. And then we have this as a warm sector. We have this place over here as the warm sector. And then this large area here is called the cold sector. And then these are the stages of development of a mid-latitude cyclone. You must be able to state or to identify the stages of development. There you have your initial stage, your development stage, and you have your mature stage. It's the same stage that we've been looking at in the previous diagram or previous slide. And then we have this stage. Also, you must be able to explain what happens in this stage. This stage is called occlusion stage. How does occlusion stage occur? or why does occlusion stage occur? The occlusion stage occur when the cold front catches up with warm front. And then the question is, why does the cold front catch up with warm front? Is because cold front travels faster. And why does cold front travel faster than warm front? Is because cold front has got a steeper gradient than a warm front. And as you can see now, when cold front catches up with warm front, you are going to have cold air, which is the cold sector. Then you're going to have warm air ahead of the cold front, but which is behind the warm front, which is the warm sector. But the air here should not be cold. You must change this. This air cannot be cold. This air cannot be cold. This air should be cooler, because now the cold front caught up with the warm front. The cold front caught up with the warm front. So if you have warm air and then you have cold air, when they mix, they cannot remain cold, because it's warm and cold. So it's going to become cool. The temperature will change. In the occlusion stage, the air ahead of the warm front will not be cold. It cannot be cold. It's going to be cool, even though the entire sector here, it is the cold sector, but the air ahead of the warm front will be cooler than the air which is found behind the cold front. And then what is important again, you could get the question, what identify or what do we call the linked mid-latitude cyclones, or the mid-latitude cyclones that are following each other? It is called a family of depression. This is, we have cyclone 1, cyclone 2, cyclone 3, there you have them like that. And now an examiner can ask you, or in examination you can be asked to identify between these three mid-latitude cyclone, which one is older or which one is younger. So the one which is further to the west will be the youngest one, and the one that is further to the east will be the oldest one. Now, how would we identify with evidence which one would be older? You can look at this one here, looking at the pressure here, and you can look at this one here, looking at the pressure again here. And you can also see this one which is further east, it has already reached occlusion stage, but this one, it's still in the mature stage. But now you must also be able to describe the characteristics of a mid-cyclone in the occlusion stage, that the sector, the warm sector, is narrower. What makes the warm sector too narrow? It is the cold front that is catching up with the warm front, making this sector a little bit smaller. But you can see here during the mature stage, the sector is very wide, or the warm sector is very large, because the cold front is still far away from the warm front. But when you look here, you can see they are very close to each other. So the warm sector narrows. Even when you are requested to draw the occlusion stage, or the occlusion stage, you must also indicate, you must show that the warm sector is narrower. So that's your family of depression. Now, this is a typical examination question that you can expect. Write a paragraph in which you explain the development of a cold front occlusion. Cold front occlusion, not cold front occlusion. Sorry, that's a misspelling. So when you explain the development of cold front occlusion, now you need to explain that air behind cold front is cold, and then cold air move faster than warm air. Why does cold front move faster than warm air? Because the gradient is steeper, and then it catches up with warm front. And then what will it do when it catches up with warm front? Then it's going to undercut cold front will undercut the warm front, and as cold front undercut the warm front, what will then happen? Cold front will undercut the warm front, and then the warm sector will be lifted off the surface. As you can see here, as you can see in this diagram here, we have only cool air here, and the cold front is touching the surface, and you can see now all the warm air has been lifted from the ground. That is why now because of the cumulonimbus clouds here, we're going to have a heavy rain that's going to be experienced, and then we have your nimbostratus cloud and altostratus clouds, and now we will then experience torrential rain. We'll have rain that takes place over a long period of time because of these clouds. Now, describe weather changes associated with the passing of a warm and cold front. What will happen when warm front or cold front passes? Now, let's look at the three weather stations here. Let's look at this weather station. Let's look at this weather station and this weather station. So this will indicate to us what happens when the cold front passes. Number one, this is your cold front, this is your cold sector, and this is your warm sector. So what happens when the cold front passes? Number one, temperatures will drop and air pressure will increase. Remember, temperature and pressure, they are inversely proportional. So when temperature drops, the air becomes heavier, and when the air becomes heavier, it subsides, and subsiding air creates high pressure. And then wind will change direction because of the clockwise circulation of air. The air will be coming from this point here, and then because of circulation, the air changes direction like that. So this process will be called baking in the southern hemisphere, because the air will be changing, or the wind will be changing direction from because of this circulation, or because of this clockwise circulation. And then the cloud cover will increase. We are more likely to have overcast condition, and then we will have heavy rainfall, and then this will have also impact in the environment. So many times you have a question in examination that asks you to describe the impact or discuss the impact of mid-latitude cyclone on the impact that the cold front of a mid-latitude cyclone will have on the environment or physical environment. Now, when speaking of physical environment, remember, we're only referring to natural features. We're not referring to livestock. We're not referring to infrastructure. We're not referring to anything that was planted or that was built by human beings. We refer to only natural features. Like we can say the impacts of cold front or the impacts of mid-latitude cyclone will be soil erosion. And you can say it also destroy natural habitats. You cannot say it destroy crops, because crops are grown by people, so they are not natural. You cannot say it's going to destroy roads, telephone lines, electric poles, electric connectivity. You cannot say anything that is relating to what people have made. You can only restrict it to natural environment. You can talk about destruction of habitats. You can talk about disruption of ecosystems. You can talk about soil losing its fertility, but nothing that is not natural. Only talk about natural features. You can have, number one, I said, soil erosion is one fact. And then after soil erosion, you can also add another fact on soil losing fertility. Even if you're talking about soil, but you are referring to different facts about the soil, then you can say it's going to destroy, or it's going to result in the destruction of natural habitats. Then you can also say it will result in, you can say it results in destruction of ecosystems. So natural habitats, ecosystem, you only refer to natural impacts. You don't refer to anything. Now, let's look at the warm front. This is the front that you get an examination question that they ask you which front hardly ever affect the weather of South Africa. This is the warm front. The warm front doesn't have more impact in the weather of South Africa. But when the warm front passes, what will be the impact? It will result in, or what will be the weather conditions associated with the passing of warm front? The temperature will rise because the name says warm front. It means warm front is leading warm air. So once it passes, temperature will rise to maximum, air pressure will drop because now the air is warm, it is lighter, and therefore it's going to rise. And therefore that is why we're going to have air pressure being lower or dropping to minimum. And then wind will change from northeast to northwest. That is all again because of clockwise circulation of air. And cloud cover will decrease because now a lot of there's not going to be undercutting of that warm air by cold air. So the cloud cover will decrease and rainfall will stop. Now, let's look at the typical examination question. This was the question that came from the last year's December question paper. It said, in which general direction do mid-latitude cyclones move? You must be able to state that. And then sometimes the examiner will ask you to draw and label. Every time when you are requested to draw and label, make sure that your diagram has a heading. So you see this question, the diagram that we have here, it has got a label. The diagram here has a label, and the label says cross-section of a mid-latitude cyclone. This is a cross-section of a mid-latitude cyclone. Now, what you should know is that if you are requested to draw, you must make sure that your drawing has labels. And then again, when you're drawing a cross-section of a mid-latitude cyclone, you must also show the direction. Show the direction of the movement of air. And then give a reason for your answer. Why do mid-latitude cyclones move from west to east? Your answer here is west to east is because they are driven by the westerlies, or they are steered by the westerlies, or occurs in the westerly wind belt. How does a front A give rise to the formation of cumulonimbus clouds? Now, cumulonimbus clouds is common clouds that you're going to be talking about when you're talking about number of natural phenomenon or weather phenomenon. Tropical cyclone is associated with cumulonimbus clouds. Moisture, a line thunderstorm is also associated with cumulonimbus clouds. So it makes it very important for you now to be able, or it makes it important for you to be able to give the characteristics. It makes it important for you to be able to give the weather associated with cumulonimbus clouds. Now, the first weather condition that you must know associated with cumulonimbus cloud is that cumulonimbus clouds result in overcast condition. Because they are thick clouds, there's going to be overcast condition. Number two, because of cumulonimbus clouds have got high volume of evaporation, they are associated with heavy rainfall. They are associated with lightning and thunderstorms. They are associated with strong winds. So these weather conditions are the weather conditions that you can relate. These are the weather conditions that you can relate to three weather systems. You can relate that to three weather systems. You can relate them to three weather systems. Okay, all right, thank you. Now we were looking at these clouds, cumulonimbus clouds. Cumulonimbus clouds are very important kind of clouds because in geography we have three phenomena, with the three weather phenomenon that are associated with cumulonimbus clouds. Number one is the mid-latitude cyclone that we are looking at here. then it is the tropical cyclone, and it is the line thunderstorm. Line thunderstorm. So these three weather phenomena, have got something in common, which is cumulonimbus clouds. Here we said, how does front A give rise to the formation of cumulonimbus clouds? Now, this question is now referring to mid-latitude cyclone. But now, what you should do, you should now link the development of cumulonimbus clouds to all the systems that have cumulonimbus clouds. Here, in the mid-latitude cyclone, cold front will undercut the warm air ahead of it. But now, when you're talking about other systems like your tropical cyclone and your line thunderstorm, there is no undercutting. The warm air is going to rise rapidly. It rises on its own. So the formation of cumulonimbus clouds, the air is going to be undercut when it comes to mid-latitude cyclone. But when it comes to line thunderstorm, the air is rising. When it comes to tropical cyclone, the air is rising. Why am I bringing these topics together? Is because they have common type of clouds, which means because they have common type of clouds, which means now when you're looking at the weather associated with these three systems, the weather is the same. Let's look at this. We're looking at the weather associated with cumulonimbus clouds. Number one, it is overcast conditions. That's the first condition. Number two is heavy rain or heavy rainfall, lightning, and thunder. Now, if you write an examination and you are requested to give the weather conditions that we would expect, if the question is on tropical cyclone, mid-latitude cyclone, or line thunderstorm, because they have or they are associated with similar kind of clouds, the common answers will be overcast condition, heavy rainfall, lightning, and thunderstorm. It doesn't matter. It's tropical cyclone, mid-latitude cyclone, or line thunderstorm. So you don't have to go and study the weather conditions associated with tropical cyclone, mid-latitude cyclone, and line thunderstorm. So long as you have studied the weather associated with cumulonimbus clouds, then you can look at the weather associated with mid-latitude cyclone. In particular, the cold front of the mid-latitude cyclone, because when it comes to the warm front, it will be different type of clouds. But the cumulonimbus clouds are the weather conditions associated with the cold front of the mid-latitude cyclone, plus tropical cyclone and the line thunderstorm. So if you know what is the weather conditions, you must also know, because of these weather conditions, what would you expect? How would this affect, or how will this have impact? And now, let's look at the impact that it would have. And then the impact that we should look at now is the environmental impact. How will these clouds impact on the environment? Now, number one, it will have soil erosion. So if a question comes in your examination, you have to give the impacts of tropical cyclone. Tropical cyclone, the impact, the environmental impact, it will be soil erosion. It will be the impacts for mid-latitude cyclone, it will be soil erosion. Impacts for line thunderstorm, it will be soil erosion. So that is the impact on the natural environment. It is soil erosion for all three of them, for all three of systems. So now, let's say another impact, it will destroy ecosystems. So perhaps you did not look into line thunderstorm and you see line thunderstorm in the examination, but you studied the impacts of tropical cyclone. They will have the same impacts. They will have the same impact. So they will destroy ecosystem. Why destroy ecosystem? Because they have the same type of clouds, and the same type of clouds will have the same type of weather conditions, and the same type of weather conditions will have the same environmental impact. And now we can talk about habitats. We can talk about it destroying habitats. Habitats destroyed. And then if you look at these things, if you look at these answers here, these answers are so related to each other. Because number one, you said it destroy habitats. Habitats, we're referring to where animals live. And then when you're looking at the interaction of animals and plants and the natural environment, it is called ecosystem. So this is, we're just looking at the same answers. You can also add another factor here, soil fertility lost. Soil fertility lost. So if the soil is eroded, the topsoil contains minerals or nutrients, so the nutrients will be washed away. So these are the fact, or these are the impacts. These are the impacts that mid-latitude cyclone, tropical cyclone, or line thunderstorms will have on the natural environment. And then why will they have it? Is because of the weather conditions. It is because of the weather conditions that will be experienced. And these weather conditions will be experienced because these weather systems have got the same type of clouds. So I was just trying to link all three weather systems that we have studied with the development of cumulonimbus clouds. So the cumulonimbus clouds, the development of cumulonimbus clouds is that they form in the same way, except that with the mid-latitude cyclone, there is undercutting. There is the undercutting of cold, of warm air by the cold front. So here there is undercutting, but with tropical cyclone, mid-cyclone, the development of cumulonimbus cloud is that there is going to be a rapid rising air and air rising higher, and then there's going to be condensation. So the subsequent processes are all the same. The only difference here is that there is no undercutting with the with the tropical cyclone and the line thunderstorm, but the formation is the same. The impacts are the same because the weather conditions are the same. So you studied the impact of the tropical cyclone, you know you have studied for mid-latitude cyclone, and you have studied for line thunderstorms. Now let's move on to the next question. It says, in a paragraph of approximately 8 lines, explain strategies that can be put in place to manage the negative environmental impact of the heavy rainfall associated with mid-latitude cyclone. Now, what can we do there? We can maintain this. It was taken from the last year's question paper in December. We can maintain natural vegetation. We can encourage afforestation. We can buffer areas, create effective drainage system, use of sandbags, building of retaining walls, use of catch nets in places that are prone to rockfalls, use of canopies, areas which are prone to rockfalls as well, construction of gabions, construction of dams, constructing artificial levees or barriers to reduce those flooding, conserve wetlands so that they can reduce the volume of water that is flowing, and then implement contour plowing that's going to reduce water speed, terracing of slopes. So terraces will, contour plowing will also result in terraces, widening river channels in order for water not to overflow, canalizing rivers, making canals in rivers to defect water from one place, because if water is going to be full in a stream, now the stream can overflow. Educate people about environmental conservation, awareness, or early warning systems. So awareness and early warning systems and educating people, this is one of the strategies that you can apply for any question that says suggest strategies to reduce a certain problem. Any problem that you get from the examination question, you can educate people about about whatever feature that it is. It doesn't matter what it is, so long as we can talk about educating people and then making awareness or warning to people. So this is a common answer to most of the strategies that you can think of. And then let's go to next question. Actually, the questions are done now. Let's look at the tropical cyclones. We need to look at the conditions that favor the development of tropical cyclone, characteristics, location, weather patterns, development stages, and how they can be managed. Number one, what you should know is that tropical cyclone move from east to west, and the reason why they move from east to west is not because they are driven by the easterlies, it's because they are driven by tropical easterlies. You cannot say easterlies because we have two sets of easterlies in the circulation, so you must be specific. It is tropical easterlies, not just easterlies. Unlike with the westerlies, we only have one set of westerlies in the circulation in the atmosphere. So if you say mid-large cyclones are driven by the westerlies, that answer is correct. But if it's saying tropical cyclones are driven by the easterlies, that answer is correct but incomplete. You must state which easterlies. So for it to get full marks, it must be tropical easterlies. If you say just easterlies, that answer is incorrect. It's not incorrect, but it's incomplete, so we don't give marks for incomplete answers. You must also be able to give the characteristics of the eye, and you must also be able to draw the eye of a tropical cyclone. So when you draw an eye of a tropical cyclone, you must do just a reverse of a letter S. You draw a reverse of the letter S, and you just shade the middle there. So this will be the eye of a tropical cyclone. And now, what are the characteristics of the eye of a tropical cyclone? There is no wind. Why is there no wind? It's because of the cumulonimbus clouds that forms the eye wall that stops air from blowing there. And we have no rain. Why there is no rain? Because there is no condensation. Why is there no rain? Again, is because there are no clouds that are going to condense to form rainfall, because the air there is subsiding, and subsiding air hits adiabatically, and therefore it's not going to condense. So this is your tropical cyclone, typical of tropical cyclone that was called Freddy. You remember tropical cyclone Freddy was behaving like this, moving in this direction, and after moving westward, it also moved eastwards back into the Mozambique channel. So this is common characteristics of a tropical cyclone, moving from east to west because they are driven by the easterlies. Actually not easterlies, but tropical easterlies. And now this is what we have already discussed, the impacts of tropical cyclones. So it is the same impacts that you are going to give when you're talking about the mid-latitude cyclones, because they both are associated with cumulonimbus clouds, and therefore they are going to have the same clouds. Now, here is tropical cyclone moving over the land, is going to dissipate. The Common examination question is why or what stage is that when the tropical cyclone? Sometimes you get a question that says tropical cyclone made a landfall. Tropical cyclone made a landfall. So when a tropical cyclone makes a landfall is when the tropical cyclone reaches the land. Now the question could be why. What happened to the tropical cyclone, or why did the tropical cyclone dissipate when it made landfall? Or landfall. It is because over the land there is no moisture, there is no warm air, and there is high level of friction over the land because of vegetation, because of hard surfaces, because of buildings, because of number of things that going to increase the friction on the on land compared to over the ocean. So one way of one way of monitoring the cyclones is through satellite tracking. Is through using the satellite to track it, and this process is what we call a remote sensing. When you use what's this? When you observe the world from space without touching it is called remote sensing. So this is the satellite that could be used to monitor the progress or the movement of a mid-latitude side of a tropical cyclone rather. Okay, now why is it important? Why is it important and why is it effective to use a satellite when you track tropical cyclones? Is because data is received in real time. So the data or the information that you get from the satellite, it is going to tell you what is happening at that particular time. And then data can be monitored every hour, every minute. So it is also real-time monitoring of data. It can determine intensity. So you can use a satellite to check the intensity. That is it category 5 tropical cyclone, is it category 4, or is it still in a storm? It's still a storm, not a tropical cyclone. So it is very important. And then after knowing the intensity of the storm, it will then alert or the authorities will know what to do, because they would have to prepare adequately for whatever strength of cyclone it is. And then it is also important because the satellite can be used to predict the path, even though the path of a tropical cyclone is very erratic. Tropical cyclone's path is erratic. It's not easy to predict, but we can use the satellite to just try to catch up with the occurrence and the movement and the speed at which it is going. And then satellite image also cover a large area, so it helps to tell and warn people that could be in danger, and it also warn the authorities what steps to take next. Now let's look at subtropical anticyclones and associated weather. So here what are we going to look at? We're going to look at factors that influence climate of South Africa, the land thunderstorm and South African birth winds. This we call traveling disturbances. Now, so what we have there? We have high pressure systems. It's very important that you are able to identify them. So the question could say, identify the high pressure A, B, C. You must know their names. This is South Atlantic, this is South Indian, and this is Kalahari. And then what you should know again is their movement in the atmosphere. The South Atlantic and South Indian, they both move northwards, north and southwards. They move northwards and they also move southwards. But with Kalahari high pressure, it moves up and down in the atmosphere. It moves up and down in the atmosphere. We'll look at the next diagram that shows that. So on the east, we have South Indian, and then South Indian is associated with warm Mozambique current, and therefore the air on the east will be warm and moist, and the air on the west, because it is influenced by Benguela current, it will be cold and dry. Now, let's look at the cross section. So what we're looking at here, we're looking at this is the map view and this is a cross section. So these two diagrams are indicating winter season. So here, this diagram is showing us the cross section of the interior during winter. So during winter, what is happening? The inversion layer is below the escarpment, and therefore warm moist air cannot reach the interior, and therefore it results in dry conditions. Now, because of this condition, it is winter, which means now, as you can see, it means now the temperatures in the interior are low. Because of low temperatures, now the air is heavy and it is subsiding. Now, the air will be blowing from the interior. The air will be blowing towards the coast. Now, the question will be, what do we call the air that blows from the interior to the coast? Is it offshore or is it onshore? So this will be offshore winds. So during winter, we experience offshore winds because the pressure is higher in the interior and it is lower at the coast. So the air blows from the interior to the coast, and then what do you call that air? We call it offshore wind. And then these offshore winds that occur in South Africa, they have the name that we call berg winds. We call them berg winds. These are the hot, dry winds that blow from the interior to the coast during winter. They are hot, dry winds. Now, an important question that to be asked is, we said during winter the temperatures are low, but now why are berg winds hot? Because it's a known fact that during winter the temperatures are lower in the interior, but we said berg winds blow from the interior to the coast, and berg winds are hot and dry winds. Why are they hot? Is because of adiabatic heating of air. Berg winds are hot because of adiabatic heating. And then why are they dry? Because they blow from the dry land. The winds blow from the dry land. They are offshore winds. So they are dry because they're coming from the dry land. Remember, the air assumes the characteristics of the surface that it is blowing on. So that's why berg winds are hot and dry. And now, let's look at these two diagrams now. What is the season here? We said the season here is winter. Why do we say it is winter? Because number one, we can see the high pressure cells are closer or have moved northwards, or they are closer to the land. They have moved northwards. And the interior is dominated by Kalahari high pressure, or Kalahari high pressure is dominating the interior. And now when you're looking at the cross section, is the same diagram. When looking at the cross section there, we say now the inversion layer is below the escarpment. And now we also have the coastal low. Coastal low is further east. Remember, coastal low, they develop on the west side. They develop on the west side during summer, and they travel along the coast. They travel along the coast to the east during winter. So when you see coastal low here, westwards, you must know that the season there is summer, because they develop in summer on the west side, and they move towards the east during winter. And then sometimes you'll also get what you call a cold front here. You'll get a cold front here. Now, if you see a cold front here, you have a coastal low here, and you have Kalahari high pressure here, then you can see in a synoptic weather map, and they ask you what conditions are favorable for the development of berg winds. What conditions are favorable for the development of berg winds? What you should know is that, number one, air, according to pressure gradient, air is going to blow from high pressure to low pressure. So metallurgy cyclone is a low pressure system. So even in the absence of a coastal low, the air will still move from the interior to the coast because you see the presence of mid-latitude cyclone. So mid-latitude cyclone is also a factor that favors the development of berg winds, because a mid-latitude cyclone is a low pressure cell. And then another factor that will favor the development of berg winds is H in the interior, which is Kalahari high pressure, and the L at the coast, which is a coastal low. So there are two factors here, or two weather phenomena here that are also creating low pressure along the coast. So when the examiner says what factors favor the development of this berg winds here that will be developing here, you must know if you have a mid-latitude cyclone, it will be the high pressure and the mid-latitude cyclone, or it will be the high pressure and the coastal low. And then what you should know again about the coastal low is that the coastal low of all the low pressure cells, coastal low pressure cells are not associated with heavy rainfall. They are not associated with heavy rainfall. They are associated with light rainfall and drizzle. They are associated with light rainfall and drizzle, mainly because of the influence of this cold, dry air that will be blowing from the interior, and then the warm, moist air that comes from the coast. So if you're looking at the coastal low here, the coastal low will be influenced by two air masses. The coastal low will be influenced by the two air masses, or by two air masses. The air circulation around the coastal low, because it's a low pressure cell and it is in the southern hemisphere, it's going to circulate clockwise. And now, because of clockwise circulation, some of the air mass will be coming from the land. And the air mass that comes from the land going into the ocean or to the coast, it will be dry. And the air that comes from the ocean going into the land will contain moisture. So that is why the coastal low are not associated with heavy rain. The coastal low are not associated with heavy rain. They are associated with light rain to no rain. In particular, where we have our offshore winds and we have our onshore winds. So the coastal low is associated with two air masses, the offshore and the onshore. And the onshore side can bring clouds and can bring light rain, but the offshore winds are blowing from the interior, and therefore they bring dry conditions. Okay, now let's move to the conditions that we experience now during summer. What happens during summer? During summer, we have L on the interior. So this L on the interior indicates low pressure, and it's important that you are able to name it or to identify it. This is called thermal low pressure cell. It is called thermal low pressure cell. So it's because the temperatures are higher in the interior during summer. So the pressure is low because the air is rising. The air is not subsiding during winter. And then what do we have again? This will be a diagram showing that showing summer conditions on the map. If you are to draw the cross section, there, you will now have your inversion layer being above the escarpment. The inversion layer will be above the escarpment. Remember, we're saying here in winter, what is more likely to happen when we have inversion layer below the escarpment? We said the likely weather conditions will be the bergwinds, which are hot and dry. Bergwinds, which are hot and dry. But now, when we're looking at what will happen in summer, the high pressure cells, the South Atlantic and the South Indian, are further away from the land. So it means they are not blocking the warm, moist air from entering the interior, or what do you call it? We call it maritime air masses. It's maritime. Why do you call it maritime air masses? Because it's influenced by the rain, not by the rain, man, by the ocean, sir. So I'm ahead of myself when I'm saying it's influenced by the rain, because I want to talk about rain in the next 2 minutes. So now, when the high pressure cells moved further away from the land, because when they were here during winter, they were blocking the maritime air mass from entering the interior. Now, when they get here, what is happening? The warm air, not necessarily the warm, but the maritime air masses, which means the air from the ocean. It can be the cold ocean or the warm ocean. It is still maritime because it's air that comes from the ocean. So what will happen here now? The warm, moist air, this air here is warm and moist. This air here is cold and dry. They will move towards the interior. So when the two air masses move towards the interior, because the high pressure cells have moved further south, allowing these two air masses, the two air masses are going to move further into the land. And when the two air masses move into the land, the cold and dry air will do the same. It's going to undercut the warm, moist air and force the warm, moist air to rise higher in the atmosphere. And this air is going to rise rapidly. And what is going to happen? Condensation will take place. And after condensation, we will have precipitation, which is heavy rain, line thunderstorm. We're going to have line thunderstorm. And you must know that the line thunderstorm have got more impact because they are blowing over a larger area, and they are also taking place over a longer period of time. So that is the why the line thunderstorm will develop. So during winter, there are high chances of bergwinds because the inversion layer is below the escarpment and the pressure is higher in the interior, and therefore air blows from the interior to the coast. But during summer, what happens? The South Atlantic and the South Indian high pressure cells are lower, that allow maritime air masses go into the interior, and then cold dry air is going to go beneath, or it's going to wedge or undercut the warm air, forcing the warm air to rise rapidly, condense. After condensing, we're going to have line thunderstorm. And line thunderstorm, the impacts are going to be the same impacts as we discussed earlier, because the line thunderstorm, they are associated with cumulonimbus clouds. So you can also be looking at what will be the impacts of line thunderstorm. So the environmental impact will be the same. It will have soil erosion. It will destroy natural habitats. It will make the soil to lose fertility. But you must be careful, because the examiner could be looking for something different. The examiner could be saying, what will be the impact of a line thunderstorm for the farming communities? Now, if they say the impacts on the farming communities, then you can bring all the impacts, both natural impacts and or the impacts on the natural environment and the impacts on the man-made, because the question says the impacts on the farming communities. So you must be careful. Read the question thoroughly. Read your question once. Read it for a second time, and you read it for a third time, then you can start answering the question, being very sure. There's nothing that's going to disadvantage you more than you not reading the question. You must make sure that you understood the question before you can start answering the question. Like in tropical cyclone, the examiner could ask you the impact of tropical cyclone for the coastal environment. So when they say the coastal environment, you must know you can also add man-made environment like the harbor, the infrastructure. So you can add all those things. It depends on the question. So please make sure that you understood what you are supposed and underline the key words of the question, underline the instruction. Does it say explain? Does it say state? Does it say list? So you must make sure that you understood what the question said. And then on what? Is it on economy? Is it environmental? Is it physical environment? Is it coastal environment? Is it on farmers? Is it on communities? So be careful. Make sure that you don't answer a question according to a previous question. You answer your current question. Don't look at this question was asked previously and then you think the question was asked previously. Yes, it could have been asked previously, but it was specific to something. Make sure that you read that question and you understand the question. Now, let's look at the animated development of land thunderstorm. So the examiner, you could be asked to give the characteristics of this air mass. These two air masses, you must know this air mass is warm and moist. This one is cold and dry. They blow towards each other. They cannot mix. Because they cannot mix, what's going to form between them? It's a front. What is a front? A front is a boundary between two different air masses. And now, how do we differentiate between these two air masses? We differentiate them according to moisture content. We differentiate them according to their moisture content. So we're saying this air mass is cold and dry. This one is warm and moist. Sometimes an examiner can just ask you a question, give characteristics of the air mass here, air mass A and air mass B. You can just say this is warm and moist, this is cold and dry. So this is now on which side of the line thunderstorm, not line thunderstorm, on which side of the moisture front will the line thunderstorm develop? You must know it is on the east. Why on the east? Because on the east, that is where the air is warmer, and that is where the air is rising higher, and that is where condensation is going to take place. Now, let's quickly look at this question. Sketch A shows typical conditions. Here is your A, is this winter or summer? Summer, spring, winter. The correct answer there is it is winter condition. Why do you say it's winter? Because of H there, number one. Number two, we can see the coastal low is further to the east. It's not on west as it develops there during summer. And then you can see the high pressure cell, South Atlantic and South Indian are closer to the land. And then the low pressure system in sketch B forms due to over the land. The low pressure system here, is it forming because of low evaporation, intense heating, cold, dense air, or heavy rainfall? It forms merely because of intense heating. It is low pressure cell, indicating that the air temperatures are higher, and therefore the air is not sitting on the ground to create any pressure. So the air is rising. That is why we have low pressure cell there. So the correct answer there will be B. Now, baking or divergence, ridging will take place here. The correct answer there is that there's going to be ridging. When this high pressure cells increases or elongates, it's going to be ridging. When this high pressure cells elongates, the ridging is going to take place. The anticyclone in sketch A and B change their position seasonally because of the number the correct answer there is because of the shifting of the ITCZ. So when it is winter in the southern hemisphere, it means it is summer in the northern hemisphere. So it means now the ITCZ is going to move further north. So the high pressure cells are going to follow. The high pressure cells are going to follow the ITCZ, and therefore they are going to move northwards. Now, when it is winter in the northern hemisphere, it means it is summer in the southern hemisphere. Now, the ITCZ is going to move lower or southwards, and now the high pressure cells are also going to move. So we can see that the position of the ITCZ, but remember, ITCZ is not found in South Africa or Southern Africa. It is found at the equator. So along the equator. So I am just trying to emphasize the fact that the ITCZ is going to move further south during summer. It will not be at the Tropic of Capricorn here. It will not be at the Tropic of Capricorn. It is Tropic of Capricorn down here. So I am simply showing you in terms of the movement. I'm just doing exaggeration in terms of the position of the ITCZ, but it will not be close as this. So I'm just simply showing you why did this high pressure cells move southward. It's because they were influenced by the ITCZ that was going southwards. But remember, it will be closer to the equator, further high there. It's not even here. It's going to be closer to the equator, further north here. I was just simply showing that. So this is not to any scale. Okay, let's continue with our questions. The South Indian anticyclone in sketch B is likely to feed more moisture over the east coast in comparison with sketch A because number one, because of the fetch, because it has a large fetch or large distance. It's because of the large distance. Okay. This answer is correct, but it is not answering the question. So this high pressure cell, it is also called a blocking high pressure. This high pressure cell is also called a blocking high pressure cell. So I'm looking at this option here. It is also called a blocking high pressure cell. Why do we call it a blocking high pressure cell? Because it can reach and stop the metal cyclone from going into the land. It's all from moving further into the land. So it can reach there and stop metal from moving, or cold front from moving further into the land. So that is why it is also called blocking high pressure cell. But the correct answer here, because the question says the South Indian anticyclone in sketch B is likely to feed more moisture, is because of the larger fetch. So it fetches water from further place, and therefore because of longer distance that it travels, it means it's going to bring more water into the interior. Now the next question is the low pressure system in sketch A will move in a what direction? The low pressure system in sketch A. So what is the low pressure system in sketch A? The low pressure system in sketch A is called thermal low. You must be careful. These are two different low pressure systems. In sketch A is coastal low. It moves along the coast. But in sketch A, the low pressure cell there is a thermal low. It's thermal low. This one is coastal low. Is coastal low. So these are two different low pressure systems. Please don't confuse them. And then the question here, the low pressure system in sketch A will move in a what direction? In a what direction? So it's going to move in a easterly direction. Easterly direction. So it's going to move eastwards, in an easterly direction, but it does not move straight eastwards. It moves along the coast. It moves along the coast, but in the easterly direction. Okay, now let's move on. Berg winds are most likely to develop in the presence of the and the. Now, Berg winds in which sketch will Berg winds form? Berg winds are more likely to form in sketch A. And then they are going to form mainly because of the Kalahari high pressure and the coastal low, which is 1 and 2. Which is Kalahari high pressure and coastal low. The inversion layer that forms over the escarpment in sketch B will favor the formation of the inversion layer that forms in sketch B, because here in sketch B, when we have the inversion layer, where will the inversion layer form? The inversion layer is going to form above the escarpment. The inversion layer here is going to form here. The inversion layer in B, here it is going to form above the escarpment. It's going to form above the escarpment. And this is where we're going to experience line thunderstorm. Now, the question is, the inversion layer that forms over the escarpment in sketch B will favor the formation of and what? Of the rainfall and hail, because it is going to result in what we call line thunderstorm. It's going to result in line thunderstorm. Now, let's look here at the questions that were based on line thunderstorm. According to the extract, in which season do line thunderstorm commonly form? It should be during summer. Describe the temperature and moisture content of wind A and wind B. This is wind A this side, and this is wind B this side. We have already given the characteristics. We say this one is cold and dry, this one is warm and moist. And then explain why the heaviest rainfall occurred closest to the moisture front, as evident in the... Now, this is where there is a lot of moisture. Then the moisture is going to decrease when you move further away from the cumulonimbus clouds. Explain the negative or physical impact of line thunderstorm. We have already spoken about the impact of line thunderstorm. What are the impact of line thunderstorm? The impact of line thunderstorm, because line thunderstorm is associated with cumulonimbus clouds. So all you need to know is you need to look at the impacts of cumulonimbus clouds. Remember, we spoke about heavy rainfall that's going to result in flooding, that is going to destroy natural habitats. It's going to cause soil erosion. It's going to destroy habitat. So it's the same impacts. The impacts are not going to change. It's going to remain the same. Now, this is South African Berg winds that we are talking about, that develop in the interior. This is just an animation of the diagram that we have already spoken about. Now we can look at what we call valley climates as microclimates. So what do we have there? We have the development of... Now, this diagram, which time is represented there, is showing night time. So what happens during night time? During the day and during the night, we have two processes taking place during the day and during the night. During the day, we have insolation and we have terrestrial radiation. For day and night, we have terrestrial radiation, and for day, we have insolation and terrestrial radiation. But during the night, insolation stops because there is no sun. So we are only left with terrestrial radiation, which is the radiation by the Earth's surface. Now, because of that, now the surface is going to lose its heat. The surface loses the heat because of terrestrial radiation. This is your terrestrial radiation. Now, when it loses the heat, the top of the mountains become colder, and the cold air now starts to subside towards the valley floor. When the cold air gets to the valley floor, what does it find? It finds warm air. It forces the warm air to rise, but the warm air can't rise out of the valley. It cannot rise out of the valley. Now it is trapped somewhere in the middle, forming inversion there. And that inversion, we call it thermal belt. Because now, what do we have here? We have cold temperatures here. Then we have warmer temperatures here. What has happened here? This process, we call it temperature inversion. You see, temperatures are lower here, but temperatures are higher here. So we call this process temperature inversion. So it means now the temperatures are increasing with an increasing in altitude. So we call it temperature inversion. Why? Because we do not have insolation. We have only terrestrial radiation. So the top of the surface is getting colder, and colder air becomes heavy. It subsides to the bottom of the valley. And then what does it do? It accumulates. As it accumulates, the temperatures drop below freezing point. It's very important that when you explain the development of frost pocket, is that the frost pocket will develop when the cold air subsides and cold air accumulates and the temperatures drop below freezing point. And then when temperatures drop below freezing point, then we're going to get frost pocket. So now this is going to affect how you use the slopes. You cannot grow crops that can be killed by frost. This frost sensitive crops. I'm saying insolation and terrestrial radiation, those processes take place during the day. Both processes take place during the day, but during the night, one process stops, which is insolation, and we continue with one process, terrestrial radiation. And therefore, the surface loses heat, because terrestrial radiation is the radiation by the Earth's surface, or is the loss of heat by the Earth's surface. So, as that happens, cold air subsides to the bottom of the valley. It accumulates, temperatures drop below freezing point, and as temperatures drop below freezing point, frost pocket will develop. Now, the development of frost pocket is going to influence the utilization of the valley. We cannot grow frost that are sensitive to frost at the bottom of the valley because they will be destroyed. So only frost that are resistant, only crops that are resistant to frost can be grown there at the bottom of the valley. So that is the impact of katabatic winds. During which season do katabatic winds form? Katabatic winds are clearly defined during cold winter nights. Cold, calm winter nights. So the night must be cold, the night must be calm, and it must be winter night for it to be very clear. And now, again, another feature that will develop here in the valley is that here we have cold surface, we have warm air above it. So when this warm air touches the surface that is cold, condensation will take place. Condensation, just like a cloud formation, For clouds to form, the air rises. The higher you go, the colder it becomes. Once the clouds once warm air reaches cooler altitude, is going to condense, and then after condensing, what's going to happen then? Clouds are going to form. The same process is going to take place in the valley. The warm air is there. The surface is cooler. When this warm air is in contact with the cold surface, condensation takes place. But what is going to happen in the valley is not clouds now. This is what we call radiation fog. What we call radiation fog. And now this radiation fog is also important for you to note the impacts of radiation fog. Radiation fog is going to reduce visibility. If it reduces visibility, it means people that are driving are going to drive slow. If they drive slow, then there could be traffic congestion. And if they drive faster and the visibility is not clear, then there are high chances of accidents taking place. So those will be the impacts of this natural phenomenon like radiation for. So you can see there we have high pressure there, we have low pressure there, and then we this whole process here is called temperature inversion, because the temperature increases as you move up with altitude. Now let's look at this diagram. Name wind 1 in sketch A. Wind 1 is anabatic winds. Wind B is katabatic winds. Name one difference between wind 1 and wind 2. Wind 1, you can see, is the air is blowing up slope, and here is blowing to the valley. And this one takes place during the night. This one takes during the day. Would wind 1 or 2 originate if a higher pressure occurred at the top of the valley? So it is clear that air is going to follow pressure gradient. So which one is going to form when pressure gradient is higher at the valley? So because air follows pressure gradient, it means the pressure is higher here. It means pressure is higher, so it is clearly going to be wind 2 that's going to form there. Now, next topic, we're looking at urban heat island. So it's very important for you to be able to define what urban heat island is. Urban heat island refers to the warm urban area surrounded by the cooler rural areas. So you must be able to define it, and you must also be able to state why are temperatures higher in the cities than in rural areas. Now, number one, artificial surfaces that absorb heat, high buildings that are resulting in multiple deflection of heat from one building to another, industrial activities, many cars that produces pollution that absorb heat. So those are the factors why cities are warmer. And then it's important, we were looking at the isobar, and here this is not isobar, it joins places with the same temperature. This now becomes an isotherm. This will become now your isotherms. These are the lines that joins places with the same temperature. So as you can see, this temperature is higher in the city center and temperatures decreases. So you could be asked by the examiner, what is the temperatures in the city center? You have to be able to read this and take, and then what is the temperature in the rural area or in the suburbs? You can read that. And then what is the difference, or what is the range in terms of temperatures between the 2 points? And then you must also be able to explain why is that variation between temperatures of the urban area and temperatures of the rural area. So you must be able to give reasons for that variation. Why, as it is now, relative to urban heat island, we also have what we call pollution dome. So pollution dome and urban heat island, many people can confuse the two. They are related concepts, but they are not the same concepts. So pollution dome, like the name says, it is a polluted air in or around the city. Pollution dome is polluted in and around the city, and it is higher during the day. Why is it higher during the day? Because during the day there is more human activities. There is more heat generating activities that make it to be more. So the temperatures go higher. But during the night, pollution dome is more, is denser. Is denser because during the night, what's going to happen? We're going to have subsiding air, and the subsiding air is going to push the pollution dome lower to the surface. And you must also think of the impacts that the pollution dome can have. Pollution dome can result in the breathing problems, just like urban heat island. Because of high temperatures, people might struggle in breathing. The same thing with pollution dome. And then you must also be prepared to answer application questions, because application questions could be, how will pollution dome impact the city dwellers? How can pollution dome impact the city dwellers? Or you can state now that people less production because people have fatigue, and then the buildings, there's going to be corrosion of buildings. There's going to be more cleaning that is required because of the dry deposit of acid rain. Remember, your acid rain can be dry and wet deposit. So when you see the dust particles, that will be part of the dry deposit of acid rain. Now, here are some of the questions that could be looking at the pollution dome. Now we're looking at the diagram. Let's try to answer these questions. Where's my first question here? You can see my first question. Okay. Okay. Sorry. Now, 1.2.5, there's my first question there about pollution dome. Refer to sketch A, B on pollution dome below to answer this 1.25 to 1.2.7. Represent a pollution dome at night. So at night, the pollution dome will be more flatter than that. And it's also lower. It's flatter and lower. So B is the one that represents that. Pollutants are dispersed. You can see at A, there's arrows there going there. So it means the pollutants will be dispersed at A. Denser concentration of pollution dome, because now the dome has come down. It means now all the pollution is trapped, is going to be denser at B than at A. Now I want us to quickly look at the strategies to reduce a pollution dome. Number one, we can plant trees, we can do roof gardens, we can do commercial decentralization, meaning that we don't keep a lot of businesses in the city center, because businesses attract a lot of people, and people travel with cars, cause pollution. Industrial decentralization also, industries in one place pollute a lot. We can have tall chimneys so that the pollution is escaping into the higher atmosphere, not being trapped. And then we can use public transport to reduce pollution by vehicles. Then we can also use eco-friendly buildings that are not going to absorb or create a lot of pollution. And this is an open-ended question. Most of the questions, most of the answers that you can think of will be correct. Now we have station models here. We can look at synoptic weather map. What is the season represented here? You must be able to identify that. This season will be summer, mainly because of you looking at the tropical cyclone there. So this is a synoptic weather map. You must be able to look at the features there. We spoke about this line many times. It's isobar, and then you can see there's coastal low. You can see coastal low is still on the west side because the season here is summer. And then how do you tell it's summer? Again, you can see there's a lot of clouds in the station models. And then the South Atlantic high pressure cell further south, the cold front further south, and then you can also see South Indian high pressure cells. You can see tropical cyclone.
Good day, learners. Godfrey here. I'm here to take you through the National Senior Certificate Examination for 2023, Paper 1. As I finish Paper 1, we shall be starting Paper 2 very soon. You'll be waiting, you will get Paper 2 very soon. You can see 150 marks, 3 hours. We'll start from there. And here we come. I'm not going to take you through the instructions, but I will just take you through directly to the questions. Question 1 is climatology. Various options are provided as possible answers to the following questions. Choose the answer and write only letters under that. So what do? We are given a map here. We need to start by interpreting that map. The map you have here, we have got high pressure cell here, we have got which is in the center, which we know that if we have high pressure cell in the interior, which season is depicted? It's a winter season. Okay, let's quickly go to the questions. 1.1.1. The season represented in the synoptic weather map is obviously, like I said, it's winter. So there we quickly go, and the answer is D. Okay, so we go down 1.2. The isobaric interval of the isobars on the synoptic weather map is dash in hectopascal. We come here, we're looking at these isobars. These are the isobars. So when you look at this one, this is a high pressure, and this is 1024. Okay, so this is 1020. That means as you are getting away from the high pressure, it's decreasing. But it's decreasing with what? 4. So that means A is going to be 1020 minus 4, which becomes 16. So 1016. So 1016, when you look at the various options that are here, but they say the isobaric interval. So the interval, that is the difference between the different isobars, is 4. So the answer becomes B. Okay. We go down. The air pressure reading at A, the air pressure reading at A, the air pressure reading at A, the air pressure reading at A is that hectopascal. Obviously, I've just told you that A is what? Minus 4, because this is 1024, 1024, 1020, so that minus 4, it becomes 1016. So 1016 is that option there. It's there, and therefore it is A. Okay. We go forward. Point 4. The dew point temperature indicated at the weather station B is dash degrees centigrade. We go to weather station B. Weather station B. The dew point. Of course, this one on top is the air temperature. The one down is the dew point temperature, which is 1. So the answer is 1. And when you check the options that are given there, 1 is there, and which is C. So here is C. The weather station around the interior high pressure cell show clear skies due to dash A, and the anti-clockwise rotation around results into this kind of winds. So here we're looking at 1.5. And then let us look at the various options. 1 is saying subsidizing. Obviously, it's a high pressure. A is subsidizing. That option must be there. That option is there. Also, we have rising. Of course, it can't be subsidizing and rising. That one is out. So when we look at our options, wherever there is 2 is wrong. So that means this one is obviously wrong. Okay. So C is obviously wrong. We go to another one. Southwesterly direction. Or southeasterly direction. So there is Roman number 3 there. And when you look at Roman number 3, it can't be southeasterly when you look at this weather station. You go back here, and you check. If you like it, is it southeasterly? No, it is not easterly. We go back down there. Then we say, oh, that, of course, wherever there is 3, is also wrong. So this one is wrong. Okay. This one is also wrong because there is 3. This one is also wrong. Which option do we have? We only have option B, whereby northwesterly and subsidizing. And therefore, the answer here is B. Okay. We go. We have a diagram here that shows. So we are going to use this diagram to answer 1.16 and 1.18. So when we go down here, we're looking at the map of South Africa. We have the low pressure system here, which is the negative cyclone, and the anticyclone here on this other side. The first question is CC. So this and this is what? But you can see it's a high pressure. So because this is a high pressure, this becomes what? Raging. So an elongated high pressure is raging. So the answer is A. Okay. 1.1.7, the high pressure cell D will cause weather system E to move in that direction. Which direction is that? So that 1.7, obviously the answer is B. Okay. So here we say B. So the weather condition at this station F is here. What is the weather condition? So the weather condition here is which one? Go down and we say air temperature is 8. Let's look at that air station. Air temperature is the atmosphere temperature at that station. Is it 8? No. The atmosphere temperature is 14. So meaning that 8 is where we have 8 is number 1. So in these options, wherever there is 1 is wrong. So this one is wrong and this one is wrong. Okay. So we are remaining with those 2. Cloud cover is 4/8, which is a half. And therefore, when you look at the station model, It is a half. Therefore, do we have that 2 somewhere? So it is on this and on this. So we are looking for the other option that makes it very right. Southwesterly winds. Southwesterly winds. Obviously, these winds are southwesterly. When you look at it, you come here, it's southwestern direction. This is southwestern direction. So that obviously makes it wind speed not is 5. This one is not 5, it's 10. So that means wherever there is 5 is wrong. So where is 5? 5 is here. So the only option is B. So right there, B. Okay, we'll go forward. Refer to this valley climate. We have the valley climate here. What we need to do, this is a cold plateau. Here we have the shadow zone. We have trees here. You can see cold air of the drainage. You can see crop farming here. And this is south and this is north. That means this slope here is north facing. This slope here is south facing. Okay, and they show us temperatures. Minus. So here, actually here B is higher than up and low, meaning that cold, cool, hotter, or warmer. Okay, so we go down there. See the questions. So we are using this to answer this question. So 1.2.1, the direction in which the slope faces in relation to the insolation. Yes, that is Z, which is Z here. The sketch represents the valley, which hemisphere? The hemisphere obviously is southern hemisphere. Why? Because the slope here is warmer than the slope. So the south-facing slope is warmer than, the north-facing slope is warmer than the south-facing slope, which makes it the southern hemisphere. So here is why. The next question is, dash wind occurs due to terrestrial radiation. Which one? It can't be anabatic because terrestrial radiation mainly happens late in the night. So why answers there? So 1.24, a temperature inversion occurs between A and B due to dash and or temperature and height. Obviously, the answer here is Z, which increases. Okay, temperature increases. So 1.24 is Z. 1.25, the form of precipitation that could occur at X. Here, it's very cold here, so you don't expect dew. It was only going to be frost. So Z is there also 1.25. 1.26, fog, dash fog may form in the valley in the clear and calm nights. Obviously, that is a radiation fog. Okay. 1.27, the northern side of the valley is covered with trees because the answer is Z, because of low evaporation. Remember, trees have cool environment, or they bring cool conditions. And there's less sun on that side. We go to the next question. The next question is a text. The text given here is the 2 cold fronts to hit Western Cape this weekend. So we have the date here, the 10th of June, 2022. And then they show us that according to South African weather, 2 cold fronts are expected to bring rain, strong winds, high waves, and significant drop in temperatures in South Africa. So the first cold front is expected to hit the Western Cape on Sunday evening, 12 June, ahead of the first cold front. Okay. So they say strong northwesterly to westerly winds between 10 to 60 kilometers per hour, gusting up to 80 to 70 kilometers per hour. So are expected over the southern part of the Northern Cape and the interior of Western Eastern Cape from Sunday. So the second cold front is expected to reach Western Cape by Monday evening, which is the 13th. You can see from 10th to the 13th. So bringing that contain the high amount of rainfall. Okay, etc. when you continue reading. So the first question is, which season do the cold front mentioned above influence Western Cape? When you look at the text, there are months that are given there, which indicates June. June is which month in Southern Africa? It's winter. Therefore, the season here is winter. Give evidence. The evidence is that the month given the text is winter. The June month. The June month. Okay. Then why do the cold fronts have a greater impact on the Western Cape during this season? Why on Western Cape during this season of winter? We must understand that this system moves with the movement of the ITCZ. So when the ITCZ is above the tropical or overhead the tropical Cancer, which is the northern hemisphere, it is winter in the southern hemisphere. So here we are going to say that because the ITCZ shifts, northwards, hence the system, hence the cold front as well, okay, following. Okay, so when the system moves northwards, the cold front also falls northwards and reaching Western Cape, which is the southern hemisphere. Okay, the change in the wind direction mentioned in the extract is what? Since this is southern hemisphere, we take backing. Okay, so the answer here is backing. Give a reason for your answer. Give a reason from the extract for your answer. It is given the extract somewhere. When you go back to the extract, they say the wind direction is associated with the cold front in the southern. No, it's not that one. And say somewhere they say that wind direction associated with the cold front will change from northwest to southwest. Okay, the wind direction associated with the cold front will change. That means the extract is here. Change from southwest to northwest, meaning that there is change in direction. So that answers this question. Okay, and that is the last paragraph. So this last paragraph here answers this question. So in the paragraph of 8 lines, suggests the positive and negative. We are talking about the positive and negative impact of heavy rains associated with the cold front on physical environment. They need the physical environment. So the positive one, I will start with positive. Under positive, we shall say it clears or cleans the atmosphere. Remember, when it rains, if the environment has been dirty, having toxic or those gases that are not right, when it rains, they will be brought down from the atmosphere, in that the air that is in the atmosphere is going to be clean. That is number one. Number two, another positive impact, that because it rains, this rain is going to be very important for the growth of vegetation. Okay? Rain favors the growth of vegetation. Favors the growth of vegetation. Those are all positive. So under the negative one, let's say the negative, we shall have soil erosion. So, okay, let me say heavy rains, I would say that heavy rains contribute to soil erosion, which is a negative effect. Okay, then we can have another point here, and we say it also causes flooding. Then you can also look at soil erosion coming because of heavy rainfall, which means it makes soils infertile because it will wash away the topsoil, which is infertile. But remember, I want you to let learners that all these ones are positive and negative. Therefore, I would like you to write them in the paragraph format. So you write them in the paragraph format. Remember, when you're writing a paragraph, it must be a statement that is making sense. So you make sure that it's a statement. You don't bullet. Please don't bullet. You write it in a paragraph format. Okay. We go to 1.4. 1.4 is an infograph which is showing the tropical cyclone. Okay. And then when you look at the diagram here, it clearly indicates that this is the center, which is the eye. Here are the eye walls, and you can see the cumulonimbus clouds here on the sides. Here air is rising, here air is descending. You can see the kilometers away from the center. So we have the graph associated with the tropical cyclone here. They are showing the air temperature and the wind speed. This is ahead of the eye. This is in the eye. So we also have the isobaric representation of the tropical cyclone, and we have a dangerous quadrant on this side. We have the symbol of a tropical cyclone there that can also tell us the hemisphere. You know very well, if this one is here, it tells us a lot about the hemisphere. If the symbol is like that, it also tells us about the hemisphere. If even the diagram, the arrows are like that, it also tells us about the hemisphere, which is the southern hemisphere. But we shall see as we proceed with the questions. Question 1 says, what evidence indicates that the tropical cyclone developed is in the southern hemisphere? You see, learners, if you first interpret the diagrams, it becomes easier for you to get the answers. See, by just interpreting the diagram, I would answer all the questions before even I look at the questions. However, let's say the first evidence that is in southern hemisphere is that air rotates clockwise. Okay, clockwise rotation of air, okay, into the low pressure system. Number 2, we can also look at the location of the dangerous quadrant. The dangerous quadrant is located in the southwest direction. So the dangerous quadrant is in the southwest. Okay, in the southwest. All right. We can proceed. Give 2 reasons. Give 2 reasons. But here is 1 mark. So don't mind, you can write 1 and get all your marks. Give your mark, get a full mark. Okay. Give 2 reasons from the infograph that indicate that the tropical cyclone is in a mature stage. What reason do we have to say that this tropical cyclone that we have here is in a mature stage? The first reason that we are going to give there that is in a mature stage is that the eye is visible. So we say well-developed eye. Okay? Remember, mind the mark calculation is 2 times 1. So there should be 2 points. Okay? Then we can also look at the pressure, the air pressure. Air pressure is below 1,000 MBs. Okay, the air pressure is below 1,000 MBs. Okay, so all those ones are evidence. You can give other evidence. The eye is well developed. Then you can also look at from the very infograph the speed. But because here it is indicated, actually, you look at the area covered by look at this one. It covers between 500 kilometers and 450 kilometers. So it has covered a wider area, which means it is in its mature stage where it is running at a rapid speed. So you can also give another evidence. The system covers a wider area. Covers a wider area. From 450 to 500 kilometers. That is a bigger area. Okay. Give a reason for your answer. But before we reach the reason for your answer, they said, how did the descending air at A influence the cloud cover in the eye? First of all, how means a way, a method. How is it influencing the cloud cover? Here we are going to say that the descending air, that means if air descends, what happens? If air descends, it simply means no condensation taking place. No condensation. As air descends, there will be no condensation taking place. And therefore, if there is no condensation, it simply means there will be no dew point reached. That means there is no dew point reached. No dew point reached. And that influences what we call the clear skies that exist in the center of the eye. Okay. Then give a reason for your answer. Give a reason for your answer. We are looking at 1.4.4. Give a reason for your answer. Okay? The reason is that Okay, this one influences the clear skies. Give a reason for your answer. We shall say no dew point reached. Dew point reached. Hence, clear. No dew point reached. That's why we can have clear skies. All right. Then proceed 1.45. 1.45, they say, what is the relationship between the wind speed and the air temperature as indicated in the graph? We go to the graph. Here we can see the increase in what? Here it shows what happens here. That is, as the height changes, look at where the air temperature is, the air pressure. The pressure is high, away from what? From the eye, but the wind speed is low. That means when you reach here, the wind speed has been high, okay, but it starts decreasing, okay, in the eye. And then also the pressure starts to do what? To drop. So here we shall say that here at the ahead of the eye, okay, ahead of the eye, what shall we have? The wind speed is low. Wind speed is low, while the air pressure is high. Wind speed is low, while air pressure is high. That is the first relationship between, remember we're mentioning wind speed and air pressure. So what about within the eye? What do you see here? Okay, then the wind speed declines. In the eye, the wind speed is low, but also the air pressure is also low. So low wind speed, or wind speed is dropping as the air pressure is dropping. So wind speed dropping as the air pressure. Okay, so they basically, I've answered that question. So 1.46, why is B on the sketch or as represented to be the dangerous quadrant, the left dangerous quadrant? We go back to B. Why is this one indicated to be the dangerous quadrant? Okay, it's indicated to be the dangerous quadrant because hold on. Why is it referred to as the leading left quadrant or the dangerous quadrant? Because the rotating A and the direction of the system, the direction act respectively, the rotating A and the direction of the system, all act in the same direction within the dangerous quadrant. All act in the same direction within the quadrant B. Okay, then how does this leading quadrant semicircle develop? So we shall say that as A or wind, as A spins around the low system, the low pressure system, they coincide or they act in the spiral to each other. They act spiral to each other in the southwest direction. That's how it develops. That's how it becomes. So the speed at which it spins and the direction at which it is going, they are all acting in the same direction. And that results into them acting strongly, resulting it to be known as a dangerous quadrant. Okay. Then we look at the next diagram. The next diagram here. So remember I told you, learners, we interpret the diagram first. You refer to the sketch below. When you look at the sketch, it shows the cross-section of the South African relief. It shows here, on this other side, we have the Atlantic Ocean. Here we have the mountain. We have the Central Plateau here. Then we have another mountain on the other side. Here we have the Indian. So if you to name this mountain here, this is going to be the Drakensberg, and this will be the Table Mountain. So this is the interior, and there is a moisture front there. There is anticyclone here and anticyclone here. So there is air that is leaving this side coming the interior, and there is air that is leaving this side coming the interior. So if you're to name this anticyclone, since this is Atlantic Ocean, this is going to be the SAHP, South Atlantic High Pressure. It's going to be the South Indian High Pressure. So remember, learners, I said you don't look at the questions immediately. You first interpret the diagram. And when you interpret the diagram, eventually you will be answering all the questions nicely. So the first question is identify the high pressure A and B. And I think I've identified them. So A is SAHP, which is the South Atlantic High Pressure, and B is SIHP, which is the South Indian High Pressure. We proceed. Which season is represented in the diagram? Obviously, the season that is represented in the diagram is summer. Why summer? I would say summer because I think it's not as, but it's summer because in the interior you can see there is rainfall. Remember, the interior experiences this kind of rainfall during summer. Somewhere here we have the cumulonimbus clouds that are responsible for this kind of rainfall. Another thing, we have the moisture front. Then you also have the converging air. Remember, air converges if it's a low pressure. So a low pressure in the interior develops only during summer. Okay. So those are reasons that can be given. However, it's not asked, but we're trying to find a way of answering the question. Okay. The next question says, define a moisture front. A moisture front, now in this case, will be defined as, sorry, it says which season. The season is here, sorry, summer. So after summer, they said give one reason. So the first reason is converging cold air and warm air in the interior. Okay, then we can give another reason here is that the CB clouds, the CB, which is the cumulonimbus clouds, you can see it here, the CB of the cumulonimbus clouds that are evident in the interior, and that is responsible for heavy rainfall. And that heavy rainfall occurs only in the interior during summer. So the CB clouds and the heavy rainfall in the interior also explains that kind of what? Of season. Okay, so the fact that warm air and cold air can intersect in the interior, it tells us that. All right. Sorry for that. The moisture front. What is a moisture front? A moisture front is a moisture boundary, or the boundary that separates the boundary that separates the cold dry air from the Atlantic Ocean, cold dry air from the Atlantic Ocean, and the warm moist air from the Indian Ocean. So that boundary separates the two air masses of different characteristics in the interior is known as a moisture front. Remember, these two air masses are formed of different moisture content. That's why we call it a moisture front. All right. Give two forms of precipitation that is associated with this line thunderstorm. First of all, you can see that there is heavy rainfall. Remember, precipitation is any form of water in the atmosphere. So we have heavy rains, and if you expect heavy rain, you can see some kind of hail within this kind of rain. So that means another form is hail. Okay, another form of precipitation is hail. The answer, the mark allocation says 2 times 1, so we have to give 2 answers. Describe the process involved in the formation of the line thunderstorm. What is the process involved in the formation of a line thunderstorm? So the moisture front already has developed. Okay, so if the moisture front has developed, what happens? So cold dry air, okay, proceeds to the interior, meeting with moist warm air. Okay, so when it meets with the moist warm air, what happens? The cold air wedges underneath, and the warm air rises along the moisture front, forming a line thunderstorm. Forming a line thunderstorm, which comes with lightning and all that, with a line of clouds that forms on the eastern side of the thunderstorm. Okay, we go to question 2. Question 2, the first question says 2.1.1. A river and its tributaries is known as what? A river and its tributaries is known as what? We're looking at the river and its tributaries, so it means it's a system. Okay, a river and its tributaries is a system. Okay, if it had the word area or a zone, it would be a drainage basin. But since it's a river and its tributary, it becomes a system. So 2.1.2, the high-lying area that separates 2 drainage basins, it becomes a watershed, which is A now. Okay, the 2 or more rivers join. Which one is that? They join where we have a confluence. So the answer becomes what? D. Next question. Refer to the sketch below and answer the questions. First question is, which kind of drainage pattern is represented here? You can see that it looks like a branch of a tree, which forms a dendritic. So that becomes B. Okay, 2.5.5, the stream order at X. We go to X. Where is X? X is here. So which stream order? So we say 1 and 1 is 2. So 1 and 1 is 2. That means 2 mixed with 2, it forms what? 3. So 1 and 1 is 2, so we keep 3. 1 and 1 is 2, so we keep 3. 1 and 1 is 2, so we keep, this is 1, so we keep 2. 1 and 1 is 2, so we keep 2 here. 1 and 1 is 2. So 1 and 1 is 2. This is 1. This is 1. Therefore, obviously, this is 3. So X is 3. And we have the third stream order there. Yes. So the answer is C. The drainage density of a drainage basin is high because it is influenced by the river flowing in the area and. So we come here. Obviously, we're looking at drainage density, amount of rivers that are existing on the surface of the earth. So, first of all, if it's less vegetation, that means there is more surface runoff than infiltration. So this option must be there. So wherever there is 1 might be right. So we are going to first see. So do we have 1 here? Yes. We don't have 1 here. That is wrong. We don't have 1 here. It's wrong. So we are remaining with C and B. Okay. So we are remaining with C and B. So when you look at C and B, the next one is high porosity. High porosity means there is more allowing water to go through. So that means if water easily goes through, it can't allow the what? The formation of high drainage density. So that one is right. So wherever you have 1 and 2 is wrong. 1 and 2. So 2 is here and 2 is here. That is wrong. But there is also another 2 here. Obviously, the answer remains high rainfall. And when you look at 5 talks about high permeability, allowing easily water to go through it. So the answer is B. So the answer here becomes B, which is 1.1, 2.1.6. Okay, so 2.1.6 is answered there. Okay, then we go to this figure. We are going to use this figure to answer question 2.1.7 and 2.1.8. So here we have this figure that you can see that they are short tributaries in this kind of folded mountain. You can see this kind of folds. So that means this kind of tributaries, and we have the folded mountain, obviously tells us that it is trellis. Okay? It tells us that it is what? Trellis. Let's look at this. Tributaries of a trellis drainage pattern. You see learners, what I'm telling you. Try to interpret the diagram before you answer the question. So it is trellis there. What is the first question? Tributaries of trellis drainage pattern. Okay, so they join the main river at acute angle. That is wrong. It cannot be acute angle. Acute angle is less than 90 degrees. So wherever there is A is wrong. Okay, so acute angle is wrong. So 2.1.7. So they say join at 90 degrees, mainstream at right angles, which is 90 degrees, bend 90 degrees along the course. That one we might not accept it. Then it flows away from the central place. That is wrong. So the answer is B. You can see it joins the mainstream. This is 90 degrees. You can see that. So the answer is B there. So the drainage pattern is found in this region. Which region? Inclined, jointed, uniform, folded. So folded is okay. Okay. So that means wherever you have 5 is okay. I mean 4. So there is 4, there is 4, there is 4. So this one is wrong. Okay. They say jointed igneous rocks. Okay, jointed igneous rocks. Then uniform resistant rocks. They say uniform resistant rocks. This is the dendritic. So this one is right. Is wrong. Okay. And then talk about inclined. We say it's wrong. So the answer is 2 and what? And 5. 2 and 5 and 4. Sorry, 2 and 4. It makes it D. All right. Makes it D. Let's proceed. The next question says, we are referring to these 2 here, and we'll answer the questions that are there. So when you look at these 2, remember you said learners will interpret first before we look at the questions. Look at this. This drainage pattern is not uniform. This one is uniform. So when you look at this one is disrupted by a dam and by this hard rock. So there can be a waterfall here. So that means this is temporally base level and this is concave, which can revert or which can come to a permanent base level. So if it looks like this, that means there's a balance between erosion and deposition. So there is a C here, there is permanent base level of erosion. First sketch illustrates which profile? A and B. A and B illustrates that profile of the river. So the cross is wrong. So this is longitudinal. Longitudinal means you see a river from the source to the mouth. The source is there, the mouth is here. The source is there, the mouth is here. So these 2 are longitudinal. Z answers that. So the temporary base levels of erosion is evident in which sketch? This is A. So A is Y. So Y is there. The profile of sketch B is which one? Graded or undergraded? Obviously it's graded. There is a balance here between erosion and deposition. Y is answering that. Okay. Then we say the dominant process at X. We look at X here. X is here. The dominant process at X in sketch A is dash erosion. Can't be lateral. Lateral means the sides, the river widens, becomes bigger. Edward means erodes going back to the source or upstream. So that means the answer is Y. Because going to erodes here, going back to the source or upstream. Okay. We continue, and then when we continue, we are looking at 2.2.5. The permanent base level of erosion is in which one? A dam or a sea? A dam is in a course. So this is temporary, this is permanent. So the sea becomes Z. So in the profile, there is an equilibrium between erosion and deposition, equilibrium between erosion and deposition, which is graded. And this is the cell. So it is B, which is Z now. Okay. Then we go river profile B. This B here developed due to erosion of the temporary base level or the lowering of the watershed. The answer becomes Y. So it's erosion of the temporary. So when these ones are eroded, it becomes concave. We proceed. 2.3. Refer to the photograph. The photograph there that is indicated is a valley below. So you look at this photograph. When you see this photograph, you will find out that at least it is a very sharp valley. Now, here is a narrow valley. Here, it's a V, and so on and so forth. The interlocking, the spars are there. The first question is, the valley in the photo is generally found in which state? Obviously, it's the upper course. Can't be middle because this is a narrow valley, okay, or a V-shaped. You can see a V formed there. Identify two characteristics visible in the photo to support your answer. Which characteristic? Number one is the narrow valley, okay, very narrow valleys. Here, narrow valley. So besides the narrow valley, you can see the V-shaped valley is evident. V-shaped valley is also evident. Also, we can look at the interlocking spars. Interlocking spars. These interlocking spars that you can see there. All right. And also, we can also look at the color here of what could be the water. It is white. So that white color simply means it is in the upper course. Okay, so we can talk about the white color of the water. Okay, refer to sketches B and A, which is indicating the waterfall. So here is a waterfall there. So when you look at this, it shows how erosion will take place. But when you see there, it cannot take place at the same pace. This one, it was at the same level here. But when you check here, this one is further eaten compared to what is here, which simply means here, softer rocks, hard rocks. So if this one is soft and this one is hard, let's answer the question. What is a waterfall? A waterfall is the change in a gradient. Change in gradient, or when a river flows over hard rock down the stream. Okay, hard rock down the stream. So match Y, Z with the figure, and then in the sketch A with the concepts related to a hard rock and less resistant rock. So we said Y is a hard rock because you can see the rate at the speed at which it is declining is not the same speed. This one is declining. So because this one is declining faster, it is softer. This one is declining at less speed, it is hard. Therefore, here we shall say Y is a hard rock. So we say Y is hard rock and less resistant, hard rock, okay? And Z is a soft rock, which is less resistant, soft rock. So Y is a hard rock, which is resistant. Z is a soft rock, which is less resistant, okay? We continue. How does erosion in B, this B here, how does erosion in B cause the waterfall to retreat or move upstream? So we find out that at B, what happens? How does erosion in B cause the waterfall to retreat? Cause the waterfall to retreat, erosion at B. So we come here, retreat or move upstream. So don't forget that as this water flows over this hard rock, okay, as water flows over the hard rock, okay, We say as it flows over the hard rock, headward erosion takes place, eroding softer rocks, leaving behind, eroding softer rocks faster than the hard rocks, at Y, leading to retreat upstream, Okay. Refer to the sketch below on this river rejuvenation. So we have this sketch below regarding river rejuvenation. Okay, we can have the terraces. You can see the terraces here. You can see the new valley, meaning that this is the old valley. This is the new valley that is formed in the old valley. It is this river that is meandering, flowing in that direction. So there is A, there is B there. So here it is indicated that these rocks that are here are a bit softer. What is river rejuvenation? Here we say when a river gains its erosive power, or I say when the river develops the characteristics of the upper stream while it is in the lower course. State two possible causes of rejuvenation. What could cause rejuvenation? Number one is heavy rains that increases the amount of water in the river, okay, that allows it to flow faster. Then we can also say change in the gradient. So when the gradient becomes steeper, the river will erode more. Okay, we can also talk about drop in the sea level, Okay, all that assists rejuvenation to take place. Okay, the next question says that draw a freehand cross-section of from A to B of illustrated rejuvenation. So here we look at it freehand from A to B. What do you see? You draw what you see. Here it comes down, here it comes down, you drop, it comes down, step-like feature. So what we are going to do, we draw this one. Okay, so let's see. Let's see here, it's going to be freehand cross-section. He said freehand. That means they want us to indicate the shape of the rejuvenation, the shape of the rejuvenated valley. So this is the rejuvenated valley, which is the new. So we say rejuvenated valley. And then they say indicate the new valley. This is the rejuvenated valley. So the new valley is this one. New valley. When you look at the shape here, you clearly see, check here, you clearly see that here and here. So this is the new valley. So it's no longer wider, it becomes a bit narrower compared to what it was before. Then it say indicate the terraces. The terraces, the river terraces, those are the steep-like features that are left out. So these ones are the terraces. Those are the terraces. Okay. How did the river terraces illustrated above form? They form due to, so we shall say, when the river gains more energy, okay, what happens? It erodes the valley in the new valley. It erodes the old valley, forming a new valley, leaving the terraces behind, leaving the river terraces, leaving river terraces. Okay, let's go. Now, 2.45. Explain how the illustrated landform will negatively impact on infrastructure development. Infrastructure development. That means if a valley is formed in another valley, it becomes very difficult for infrastructure to develop. So we'll find out that flooding, when now it's the landscape becomes steeper. Landscape becomes steeper. Therefore, when it becomes steeper, what happens? It becomes difficult for infrastructure to develop. The valley becomes steeper because now a new valley is loaded in the old valley. So the landscape becomes steeper. Number two, also we can say that when it becomes steeper, it simply means that also the water flow increases, the speed increases, and when the speed increases, erosion takes place. Erosion also increases, and this increased erosion means it results into, or it makes it difficult to construct for infrastructure development. Okay? For infrastructure development. So that is 2.4.5. We're looking at 2.5. 2.5 is an extract. It's an extract that is given about the river catchment area and river management. So you read it, talks about the river turns black after coal mine dam collapses next to the rural community in Fluvial, Mufolo's game reserve. So what happens here? Large volumes are potentially toxic coal mine waste have been spilled into the rivers flowing through communities, and Fluvial follows the game reserve. Okay, according to the US-based Union Concerned Scientists, mining and coal washing operations produce high water pollution, which can also contain toxic heavy metals such as arsenic, copper, lead, and manganese. Okay, when the Silari Dam wall collapsed on the 24th December, the residents of the affected communities were not warned about the potential hazards until 2 weeks later. Conservation managers in the neighboring Uthuluwe Buffalo's game reserve were also led to believe that the spill was under control, only to discover pitch black water flowing through the reserve several days later. By this stage, the black water had reached the confluence of black and white Umuforo's rivers. Okay, so that is the extract. Let's see the questions. First question here for 2.5.1. What caused the river to change its color to black? Number one, it's a 1-mark question. Therefore, it is because of the toxic coal mine waste that spilled into the river. Okay? Toxic coal mine waste that spilled into the river, making the color black. So I think the answer is somewhere here in the first paragraph. So state 2 toxic heavy metals. So there is lead, there is coal, okay? It's copper. Is it coal? Is coal there? Oh, sorry. I think I haven't seen coal. Oh, coal is there. It's copper, there's coal, there's lead. So all those minerals are here. Copper, there's coal, there's lead, okay? Manganese, all those ones. The answer is just 2 marks. So I'll just take 2. Okay. Quote the phase from the X-ray that indicates that the mining company did not disclose or make known the pollution of the river. So we find out that somewhere here they say the residents, okay, but residents somewhere here they say when the dams collapse, when the Slurry Dam wall collapsed on 24th December, the residents of the affected community were not warned. That means they were not informed. So this one up to here about the potential hazard until 2 weeks, it answers this question 2.45. 2.45. So what could have been the negative economic impact of the non-disclosure on the community? That means if you did not disclose it to the community, and this water spilled, this toxic gas is spilled in the water, that means there would be lack of drinkable water, so the water was polluted, so the residents were affected when they are unaware, because the water was now, the water that is there was now, the water that was available was now toxic. So here we are going to say lack of drinkable water. Okay. Next one, that is in the paragraph of approximately 8 lines, describe the environmental, it's basically saying describe environmental importance of managing inflow drainage. And that means the question is 2 parts. It has got measures. We need to suggest the measures that the local community or municipality could implement to maintain the future quality of water. So we need to first of all know the negative importance. Describe the environmental importance of managing forest drainage. So if you manage the drainage system like forest, how important is it? It's going to be important environmentally because it will help to preserve or to conserve. It helps to conserve the aquatic life. So if it is well managed, it will help to conserve the aquatic life that will be found there. Okay. Number 2, also those are the habitats now that are there. Okay. It also helps to keep the water clean. If it's well managed, it helps to keep the water clean. Okay, so we said the first one, conserving the aquatic life. Number 2, it helps to keep water clean. And it also helps, I'm still looking at the positive, it also helps to conserve the vegetation. The vegetation that grows next the river. Remember, the question says paragraph, so it should be written in the paragraph format, despite the fact that I'm outlining it. So those are the importance of managing. If you manage it, it's okay. All this will happen. The next one is measures for the local community to implement so that in the future they can have better quality water. The first one, under the suggestions, is going to be buffering of the river. So when you buffer the river, you're protecting the river. Okay, we can also The measure that can be put in place is educating the masses about the importance of maintaining the river. The importance of maintaining the river. After educating them, you can also set measures that can put in place that punish the polluters. Punish the polluters. All those ones that are polluting the environment, punish them. You can also reward those ones who try to maintain the water sources, but you write it in the paragraph formatting. Okay. We got the last question, that is question 3. Question 3, it talks about map skills and techniques. So here it's coming from Zerast, which is northwest. Okay. The province is northwest. You read this information, is very relevant. So don't just jump it. Zerast is a commercial town situated in the northwest, which is the northwest province. Okay. It is situated in the Marico Valley, approximately 1,294 meters above the sea level. The town is 240 kilometers northwest of Johannesburg. It lies along the N4, the main road link between South Africa and Botswana. The climate in this area is characterized by short, cold, and dry winters and long, warm to hot summers. Rain is frequent during the summer months. 2 rivers flow through Zerast, that is the Klein Miliko and the Kari Strip in Zerast. There is a natural spring at the Miliko Orb. So that information is very relevant, so please don't jump it, you read it. First question that comes here is map scale that the grid reference of a spot height 13, 15 in block B4. So here I have the map. They said B4, the spot height is here. They want the grid reference. Remember, we start with the latitude. Latitude is 25, but the first line is 30. That means the second line is 31. So it should be 25, 31. Because it is here, it's more or less halfway. Okay. So we come here, let's see the options. So that means this one, the longitude should be 26. If this is 4, this is 5 here, this is 6 here, and this is 7. So it should be 2607. It should be 2531. Let's go and look at those options. 25, 31. So the ones that are starting with 26 are wrong. So there is no way the 26 can be the latitude. Remember, we start with the latitude. Check here. The latitude is 25. So since it's 25, whatever has 26 as the first line, on the first line, is wrong. So these 2 are wrong. So let's come to this one. When you check this one, it says 25, 31, 26. It cannot be 25, 7. So if you come and check here, it's 25, 30, 31. So the one that starts with 31 and it starts with S and the rest is fine. So the answer is B. Okay, we go forward. They say the straight line distance from 1 in block A1 to Klipfontein on the orthophoto map is dash in kilometers. Okay, let's check on the map. Sorry for that. Let's check on the map. Question says, in block A1, on which map? Orthophoto. We come here, the orthophoto is here. Klipfontein is here. Okay, so from 1 to Klipfontein is here, but Klipfontein is not exactly located here. Klipfontein is 100 kilometers to reach it. So that means we need to measure from here to here. The answer we get, we convert it to kilometers so that we can add onto this one. So it's going to be the distance you measure from 1 to this place here, Klipfontein. Don't forget, from 1 to Climatology is if you measure it with centimeters, it's if you measure it with centimeters, it gives you somewhere around 4 centimeters. So 4 centimeters times 0.1, when you multiply it, 4 centimeters times 0.1, it gives you 0.4. Okay, that is the distance from here, 1, to the end of the map. But from the map to reach Clifffontaine is 100 kilometers. That means plus 100 kilometers. So you get 100 kilometers, 4 kilometers. And that answer is D. So this one is D. Okay. Remember, we multiply by 0.1 because the map that is given to us is orthophoto map. Okay, refer to the orthophoto map. Coming to the topographic map. The first question says, calculate the average gradient from the spot height 1463 at F to the block in block A2 to the benchmark at G in block C2. So we come here, use the relevant information. The horizontal equivalent is 300. So the horizontal equivalent is 3000 meters, which is given. So we just need to find the vertical interval. We come here, he said spot at F, you come here, where is F? F is here, and the height at F is indicated there, which is 1463 meters, and to the spot height, is it no, to the benchmark? The question says to the benchmark, and where is the benchmark? What is the height of the benchmark? We go to that block, want to see the block. They say the block is C2 at G. When you check G here is C2, so the area is here. Okay. Sorry, it's not clear, but I'll try to zoom it out and see. Then when you zoom it out, you'll find out that the benchmark is here. Therefore, the height for that benchmark is here, which is 1183.3 meters. So what do? Come here, we say VI is equal to, so we have 1463, which is the biggest, 1463 meters, minus the lowest of the benchmark, which is 1183.3 meters. The answer you get here is 279.7 meters. That is the VI. But remember, the HE is given. We apply it in the formula. So it's going to be 279.7 meters over 3,000 meters. So divide by 279.7, also divide by 279.7. This goes into this once, over this goes into this how many times? When you put on your calculator, it will go in 10.7 and others. So the average gradient is going to be, therefore it is 1 to 10.7. Okay, 1 to 10.7. So go ahead, use the topographic map evidence and your answer. That means we need to use the map and the answer so that we can give the reason why it will be difficult to construct a road between F and G. We come here. When you look at F, G is here, okay? And when you look at F, F is here. What do you see? We see contour lines close to each other, which means it's mountainous. So the first evidence from the map is that it will be difficult because the area is mountainous. The area is mountainous, evidenced by the contour lines close to each other. Okay, so that is evidence from the topographic map. What about the answer? The answer given is 1 unit moved vertically, 1 unit vertically represents 10 meters horizontally, which means it is steep. So it becomes difficult for you to construct a road where it is steep based on the answer given. Okay. Wow, sharp. Let's proceed now. Refer to the rough cross-section that is between 2 in block A2 and 3 in block on the orthophoto map. We come here. Let's look at our orthophoto map. They say it is between 2 and 3. 2 and 3. But try to zoom it out such that I can be in position to see my features. 2. So 2 is here and 3 is here. So you can see this nature, this nature, this nature. And when you look at it roughly, this is the cross section, right? So the first one is convert the vertical scale on the cross section to the ratio scale. What is the vertical scale? It's a representative scale that is given here. So 1 centimeter represents 20 meters. So how do we change this one? This is the same as 1 over 20. And when you change this in the ratio form, it is 1 to 20. So that is the ratio form of the scale. 1 to 20. Okay. Then what does the vertical exaggeration of 5 times mean? It means geographical features are 5 times larger or exaggerated, making it visible. So it is 5 times bigger. 5 times larger or bigger or exaggerated. Okay. We go to 3.2. 3.2, it's interpretation now. 3.2. So 3.2, we're referring to the block, refer to the block dash in E2, and that indicates the season of the rainfall. Dash is in this block E2 on the topographic map, is indicating which season of rainfall. We got the topographic map. Okay. Topographic map is here. Therefore, when you look at this topographic map, we go to E2. E2 is here. And when you check it here, what is the question? Which rivers do you see? You can see that these rivers are real broken. And they gave us a guide to say it indicates seasonal rainfall. So which rivers indicate seasonal rainfall? Of course, it can't be rough trees. Okay. I mean, which indicator here is for seasonal rainfall? Rough trees is rough. When your river is not seasonal, is rainfall throughout the year. Cultivated land is not answering that. The answer becomes C. Okay. So here they say refer to the graph. Here is the graph below that is indicating the average temperatures from H to what? To J. H to J. So H is here and J is here. And here they're showing the temperatures here are higher, temperatures here at J are lower. Let's see on the map. What do they say so? So H is here, which is an urban area, and J is here, which is basically having rivers and so on. Okay, so let's see the question. What do they say? Identify the human activity or the human feature that was responsible for the higher temperatures recorded at X. Okay, we go to X. And according to X here, X is H. So H is here. Why do we have higher temperatures here? So we have higher temperatures because that area is a built-up area. Built-up area. Or we can say urban area. Okay. Explain your answer. Explain your answer. So we say let's find the human-made picture, built up or a city, built up area. Yes. Explain your answer in 3.2. So 3.2, the urban infrastructure or the built up area. Okay. Buildings, here we say buildings, built up, the human feature is a built up area. The human feature here, buildings. So human feature here, buildings that are responsible for the higher temperature. So the high buildings. Would be high buildings, which is the built up. So we say buildings absorb heat, making the city hotter. Buildings absorb heat, making the city to have higher temperatures. Okay, identify the natural feature that resulted into lower temperatures at Y. Let's go to Y here. Let's go to Y. Come on, Y. Y. Which natural feature? So identify the natural feature. Identify the natural feature. Identify the natural feature. Identify, the question says, identify a natural feature that resulted in lower temperatures at Y. When you come here at J is where Y is. Which natural feature is there? You can see when you see this, there's a river there, isn't it? River, it helps to cool the environment. It's also that green vegetation, this protected area, which makes it the green vegetation. Okay, so here, the natural feature here is the perennial river. The perennial river. Okay. Next thing is, which sketch below represents the slope from 4 in block C1 to 5 in block B1 on the orthophoto map? So we come to the orthophoto map here. Come to the orthophoto map here. The orthophoto map here, we are looking at 4 and 5. 4 from 4 to 5. This is a higher area, it's a lower area. So the contour lines increasing going upwards. When the contour lines are increasing going upwards, it tells us A. Okay. Refer to the orthophoto map. How did the topography or relief of the area favor the location of the rifle range? Let's go to the rifle range. The rifle range is here. It's mountainous, it's mountainous, it's mountainous, it's mountainous. What does the rifle range, what is it used for? This is used for people who learn or train how to shoot. So if you're shooting, learning how to shoot, it's the mountain is favoring. Okay, the relief in the area favors because the bullets end in the mountains, or the mountains, and say the mountain shields the areas around. The mountain shields the areas around. The mountains shield the areas around. Okay. The mountain shields the area around. That is 2.6. I mean 3.26. 3.27. Describe two factors on the topographic map that limited the pollution of the Climatology dam. You come here. Where is the dam? The dam is here. Which two? But the question says two factors on the topographic that limited pollution. What limited pollution there? First of all, the first factor that limits pollution is that the dam is located in between mountains. Okay? It's in between mountains, number one. Number two, it's close or it's located next to the protected area. So here you can see this is a protected area, and when you look at the nature of the relief around, it's mountainous. It's mountainous. So here we shall say the two factors is located in the protected area. So no just accessibility at any time, protected area. Number two, the mountainous nature around. Around the dam. Around the dam. That means it limits people's settlement. Therefore, there will be less pollution in the area or on the dam. Look at the last section. The last section says, which one of the following is a standardized point symbol? Point symbol. Obviously, that is found on the topographic map. This is not a point. That is a polygon. C is a line feature. And this road is a line feature. The only point feature is B. Therefore, the answer here is B. That is the only point feature. Okay? And when you check here, let's go to the topographic map and look for it. When you go to the topographic map and look for it, it is somewhere here. Okay? That is where we have our point feature, which is a monument. A monument is a point feature. Okay? Give one attribute and identify the alpha numeric block on the topographic map on which the point symbol is located. We go back to the map. Alphanumeric. What is the alphabet? It's located at alphabet C. And then what is the numeric? The numeric is 3. So it is C3. So here is C3. Okay? Then the last question, it says, give one attribute data of the point symbol on that answer, evident on the topographic map. You come here, this point symbol has got a name. What is the name? The name here is graph is Graphendiferkos. Okay, so you write it here, Graphendiferkos. So 1820 to 1891. Okay, the last section of the paper says, identify the GIS component A. GIS component A. Where is A? A is here, and therefore, that is, we call it people. Okay, the component is people. It's an individual, GIS specialist. People, person, or GIS specialist, whatever. Give one reason why GIS component, answer the question, is important. Why the GIS component in that question above is important to interpret and analyze data. Okay, also helps in data application. Okay, data integration is illustrated in the sketch. Give one reason to support your answer. Okay, several features are merged on the same paper or area. So you can see this one was separated, and then there are some lines on this map. So they are all merged and they're all appearing here. So you can see this one is separated from this, and later it's put in one area. That is in integration, trying to interpret or to put the data together. You integrate it, you add it onto. So the features are all merged in the same area or in the same part. They are put together, they are integrated together. So that marks the end of the paper. Thank you for listening. See you when we are doing paper 2. Bye.
Please use the link below,
which is a tropical cyclone, and its effect on the South Africa's climate. Because remember, we are looking at the climatic phenomena that are affecting South Africa. Therefore, we observed the migratory cyclone as one of them that is affecting in winter. And therefore, for now, we are going to look at the tropical cyclone, which is another aspect that is affecting South Africa, but this one is in summer. So with the tropical cyclone, we are going to look at the characteristics here, look at the stages, look at how we can manage the tropical cyclone. Therefore, how do we define a tropical cyclone? A tropical cyclone, we shall say that it's a low pressure system that occurs within the tropics, moving from east to west. I sometimes always want to add on that a tropical cyclone is a low pressure system that is basically associated with destructive weather conditions. Okay, it's associated with destructive weather conditions, but you must note with the tropical cyclone that just like a migratory cyclone, tropical cyclone is a low pressure system. The difference is that this one is within the tropics And for it, it is moving from east to west. Unlike mediative cyclone that is from west to east. Hope you get the difference, guys. So this one is a tropical cyclone, which we said it's from east to west. That is its movement, okay? But you must note that it is also a low pressure system. So be it a low pressure system, you remember that the low pressure systems associated with a clockwise movement in the southern hemisphere, pressure decreases towards the center. You understand? All those aspects, we also talked about it having unstable weather conditions, rising warm air, and so on and so forth. So that is the basics of a low pressure system. All right. So we need to also know that what are the characteristics? What can you look at to say that really this is a tropical cyclone? Okay. Number one, they develop in the late summer and the early autumn. Why do we say late summer? We know that tropical cyclone needs that high temperatures. So in the late summer, this is where it is becoming very, very hot, and the early autumn, it is still very hot. So these high temperatures will ensure or will help in the continuous evaporation, okay, which results to continuous condensation, and therefore this continuous evaporation will precipitate the occurrence of a tropical cyclone. So under the characteristic, we must know that late summer and also early autumn. Okay. Another characteristic that they develop between 5 and 30 degrees north and south of the equator. What you must note that why do we say 5 and 30? We must know that this is 5 and 30. This is where we see the tropics. Okay. But also you must note that it does not occur between 0 and 5. Why? Because there is no Coriolis force. How is Coriolis force important? Coriolis force is important because it helps in the deflection of winds. Okay? Either to the left or to the right, depending on the hemisphere. So it occurs between 5 and 30. So when it goes beyond 30, remember 30 and above to 60 is mid-latitude cyclone. Therefore, there it is very cold and it needs high temperatures for it to occur. That's why it is between 5 and 30 degrees north and south of the equator. Another aspect we must note also that they are named alphabetically. What we refer to alphabetic naming, you know the alphabet. For example, we have A, B, C, D up to Z. It is named alphabetical according to that particular season. Take an example, Albia. That means with Albia, A is the first alphabet. Therefore, it's the first one within that summer season. B, Bostia. Because of B, it becomes the second one in that season, and so on and so forth. So it's named alphabetically, looking at the first letter. Okay. We also note that the center of a cyclone is also known as the eye. The eye is the center of the cyclone. But anyway, I'll explain more and we see how it occurs. So the center of the cyclone is the eye. The point at the center is the eye. Okay. Then the Coriolis force must be strong. Like I said, it does not occur between 0 and 5 because there is no Coriolis force, meaning that as you move away from the equator towards the polar region, the Coriolis force is becoming stronger and stronger. Therefore, the winds will be deflected to the east such that we can have its movement from east to west. It is also named, it has got different names in different areas. For instance, Africa, it is known as the tropical cyclone. In USA, that is the United States of America, it's known as hurricanes. In Asia, it's known as the typhoon. When I talk about Asia, I'm referring to Japan there. So those reasons of Japan, it's the typhoons. Australia, it's known as the willy wheel. Okay. So those are the names that are given to different type tropical cyclone in different areas. go ahead and know the conditions that are basically necessary for its formation. The first one is that humidity must be high. What is humidity in the first place? Humidity is the amount of water vapor in the atmosphere. This water vapor, it must be high. Why? Because there is continuous evaporation of warm air from the surface of the sea. So when this warm air rises, it has got heat inside. So remember, warm air is moist. That means it has got a high humidity. So it needs that humidity for it to condense in the upper atmosphere so that these winds can deflect, can diverge to different positions. So there is that continuous rising of warm air, and therefore humidity is necessary. Another condition is that the unstable atmospheric winds. What do we refer to the unstable atmospheric winds? We know that when these winds converge in the low pressure, the moist winds rise. So that unstable atmospheric winds that rises in the upper atmosphere condenses to form clouds, the cumulonimbus clouds, that will form rainfall. But there is that instability in the upper atmosphere because of the continuous rising of warm air. Another one is the low surface friction. We know that friction stops the movement of tropical cyclone. Another aspect that you must understand is that this tropical cyclone travels at a very faster speed. And it is therefore on that note that friction stops the movement of tropical cyclone. Therefore, it must be very low in order for us to have it moving at a faster speed. Remember, we said that it is associated with destructive conditions. These destructive conditions come because of the speed of winds that are supposed to be moving very fast. Another aspect we must note that ocean temperature must be above 27 degrees Celsius. So in this case, that the temperature of the ocean must be very hot. So these hot temperatures or the high temperatures allows the continuous evaporation from the surface of the ocean. And remember, the water that is rising has got latent heat inside, which latent heat will be lost in the upper atmosphere at a condensation point or at a dew point level to form clouds. Therefore, we need temperatures to be above 27 degrees. This is hot temperatures. The Coriolis force must be strong. Of course, we named this one and we said Coriolis force, what is its value? It's for the deflection of winds. Okay. We also must know that tropical cyclone basically occur on the eastern side of the continent. So this is the east. So we expect this to be the eastern side. Okay. And don't forget that we said it is moving from east to the west. You see that it is occurring here on the warm water body. Remember, the eastern side is warm. Why is it warm? Because we have got ocean current that is blowing from the tropic, from the equator to the poles. So here you have the ocean, which is warm, Mozambique warm ocean currents. So when these winds blow over these warm ocean currents, coupled to the season, which is summer, the temperatures now here on the water body is going to be 27 and above. This encourages the occurrence of a tropical cyclone. Okay. And another thing, you must know that because it is affecting this eastern side, the area that is mainly affected is this Mozambique side. Okay. Then you see that it occurs within the tropics, and this is the tropics we are referring to. Okay. And it is starting from somewhere here, not exactly at the equator, somewhere here, because that is 5 going down, it is 5 plus. Remember 5, 30, and so on and so forth, going down. So that is the tropics, and here is the ocean. We also see that it is moving from east to west. You can see I'm trying to show you the movement. This is the movement away from the equator. In that direction, it is moving towards the side. Okay. We also see it moving, passing Madagascar. Okay. Then coming to Mozambique and then affecting some of these parts. So I want you to understand that sometimes the tropical cyclone has less effect onto South Africa, because South Africa, in one way or the other, is shielded by the Madagascar island. So as it is moving from here, within 5 years, it's the starting point. Therefore, the eye is not that visible, no strong winds, no rainfall, no clouds. But as it is continuing away from the equator, closing the ocean here, coming to the side, it affects these regions of Mozambique mainly. Okay, so, and then when it reaches this other side, it's now, remember, it is moving away from the equator, meaning that as you go down this way, the latitudes are changing. Eventually, when it reaches 30 degrees, it now changes direction and it moves, it turns eastwards at 30. Okay, turns east at 30. And therefore, that means it starts to die out. Why? Because as it is leaving this region, there will be no moisture, no warm air, and then friction will be too much. Okay, that is the characteristic. Then you look at the stages of development. Okay, and stages of development, what do we start with? We have the first stage here. The first stage here is what we call the initial stage. What you must note with initial stage is that the pressure is still above 1000 hectopascal. What is pressure? Remember, I told you that pressure is the force that air exerts onto the Earth's surface. It is still above 1000 hectopascal. Okay, remember, this is southern hemisphere. What is the rotation? The rotation is clockwise. That's why you see these arrows are showing the clockwise rotation. Okay, this is clockwise rotation. And the pressure here is still above 1000 hectopascal in the center. Okay, and in this case, you can see it above 1000. Okay, we got the next stage in the southern hemisphere. Within the next stage, we can see, we call it the immature stage. Okay, and within this stage, the pressure is now starting to drop. You can see that the pressure is now below 1000, that is 992 hectopascal. It is starting to drop, therefore, the low pressure in the center is intensifying. But don't forget that the rotation is still anti-clockwise in the immature stage. We go to the second, another stage, which is the third stage. And the third stage is what we call the mature stage. Within the mature stage is the pressure where the pressure is well below the 1000 hectopascal. You can see 956, and that therefore it has dropped further. We also have the worst weather conditions being experienced within here. This is where we call it the left quadrant. But now I want you to look at this and understand. Someone can wonder, why do we have it here? Okay, and we don't have it maybe here in the north or here. Remember, this is southern hemisphere. In the southern hemisphere, the air is rotating in this clockwise direction. But we also know that this system is moving from east to west. East to west. Okay. And the rotation is clockwise. Hope you observe there, guys. The rotation is clockwise and the movement is east. So around this area here, we are going to find out that we have the rotation and the direction of winds coinciding. So because of the rotation and direction of wind coinciding within this area, that is why we are in position to have, that's why we are in position to have the left-hand quadrant located here in the southern hemisphere. It is the opposite to the northern hemisphere, because the northern hemisphere will be located around there. Why? Because as in the northern hemisphere, the rotation is anti-clockwise, okay, but the movement is from east to west. Therefore, the coinciding point is going to be around here in the north. Okay, hope you guys understand. Now, in this case, we are looking at the southern hemisphere. Therefore, in the southern hemisphere, we have the left-hand quadrant located here. That is where we have the worst weather condition. In other words, very destructive winds, severe weather conditions, wind speed is very high, and so on and so forth. Then we have the stage number 4, and stage number 4 is what we refer to as the dispersion or the dissipating stage. We can call the disappearing stage. And what happens here? That the pressure rises again. Yes, you can see that the pressure is now starting to rise again. Why? Because the wind, maybe the cyclone has reached the cold region. Okay, maybe it has now reached 30 degrees. So it is now starting to move eastward. Okay, it is now starting to move eastward. It was moving westward, but now it's starting to move eastward. Therefore, when it moves eastward, it is now being changed and it is now influenced by the westerly winds. Therefore, the pressure is rising again. It's now starting to be above 1000. Remember, when it goes beyond 30 degrees, there it is reaching this the anticyclones or the subtropical region, whereby it is now air descending, making it cold. Therefore, it is a dissipating stage, or we can say that it is dying stage. All right. Then a tropical cyclone, will look at also its impact. Having seen the stages, the characteristics, and so on, we need to focus on its impact. Okay, but this impact should be categorized in the what you call human impact and environmental impact. So the ecosystem being damaged. And when you look at the ecosystem being damaged, we look at the fact that this system is associated with destructive winds, okay? Very strong winds, sometimes going above 120 kilometers per hour. Imagine it is the shear or the winds are traveling at that 120 kilometers per hour. Imagine a car that is traveling at 120 kilometers per hour. What will be the speed? So the destruction is going to be very much or very high. That means the ecosystem where animals, reptiles, and so on are living is going to be damaged. So in this case, you're going to find out that this is environmental impact. Then tourism. Sometimes I always want to put the ecotourism is going to be disturbed, like tourists who come to visit the area. This is human. People who are going to come and visit the area to see what is taking place or what is there are going to be disturbed because the winds are so strong. It becomes very difficult for them to travel or to move from one point to another. In the same area, it is going to be very heavy rainfall. So the tourism is going to be disturbed. Floods will occur. Why floods are going to occur? Floods are going to occur because it is going to have heavy rainfall. Heavy rainfall. So these heavy rains, okay, they are going to result into floods. Okay, so the floods are going to have its other effects like destruction of the farmland, affecting farmers in the long run. Okay, or sometimes we shall see bridges damaged. We can also find out that the farmland is also damaged and so on and so forth. In the same line, we see that floods can even wash away the topsoils. And when they wash away the topsoils, they are going to affect the fertility of the soil, which affect productivity of crops, as we shall see forward. Okay, winds that are very strong can uproot trees. That strong winds, it's not only blowing out away the houses, you're going to find out that even the trees are uprooted because the winds are very strong. Imagine they are blowing at 120 kilometers per hour and above. What do you expect? Nothing will survive on planet Earth or on land. Okay, that's why where it occurs, the damage is very, very, very much. Okay, so people are also injured or killed because of the strong winds, because of the floods. People will be killed, people will be injured, and that is another dangerous impact. Storm surge, okay, storm surge or abnormal rise in the sea level. you will find out some such will lead to abnormal rise in the sea level because there is going to be too much rain or water, and that will rise the sea level with its other effects. Okay, people are going to become homeless, loss of homes because of the strong winds that are going to be blowing, the floods and so on. Homes are going to be taken away. Communication links are going to be damaged. Take an example, bridges, roads are all going to be washed away by this heavy rainfall and winds. We'll also look at the waterborne diseases. Okay, why? Because when flooding takes place, all the materials or other things are going to be taken into water, dams are going to be silted, and therefore the water is going to be damaged. And people are drinking that water, which eventually is going to cause waterborne diseases like cholera. Okay, it's going to be in place. You find out people are going to get diarrhea, etc. So coastal flooding, and this will damage structures, boats will be damaged, okay, and so on and so forth. So those are some of the impacts that are going to come up because of tropical cyclones. And in the same line, we also have the management strategies. How can we manage tropical cyclones? Excuse me. How can we manage tropical cyclones? Number one, the public must be informed. Please inform the public of what is going to take place. The government has to take the initiative after seeing or after monitoring how the tropical cyclone, the path the tropical cyclone is going to take, the intensity of the tropical cyclone that is likely to affect an area. People must be informed. We inform them using radio stations, we inform them using TV stations, newspapers, magazines, and so on and so forth. So people must be aware, and therefore they prepare in advance in order to avoid the damage. We also go ahead and say that we need to monitor the path of a tropical cyclone. In other words, you can use satellites to monitor the path, to know when it's likely to occur and which path is it going to take, so that people can be evacuated, people can be informed, people are aware. If you get to know them, to monitor the path of a tropical cyclone, people can be told to relocate, leave those areas such that we can avoid the damage. Okay. Another aspect we have there, we can say that prepare evacuation plans. Like you can say that it's going to affect area A, so please leave that area. But you just don't need, people just don't need to just leave and then they stay homeless or they become homeless. These people need to be given an area where they are going to stay. And this becomes the responsibility of the government to assist people and get them where they are going to stay. So if you get them where they're going to stay, what do you need to do? You need to build them shelters. Come up with tents, temporary shelters where they can stay such that they are not much affected by the influence of a tropical cyclone, okay, or its occurrence. Then we also don't need to build in low-lying areas. Encourage people, tell them that the low-lying areas are susceptible to flooding. So because of the heavy rainfall, the flooding that will take place will affect such low-lying areas. Therefore, people must be told to avoid settling in such areas. Okay. We also see that in the same line, avoid crossing strongly flowing rivers. Okay. Remember, when it rains heavily, that water flows into the rivers so that it can be directed into the oceans or into other areas. So people must be told that such areas, when the rivers get full, they flow faster, they flood, and therefore they should stop crossing such rivers when they are flowing rapidly like that or strongly like that, in order to avoid losses of lives. Okay. Small boats and fishing crafts should return to ports, because in the same line, we have strong winds, we have the seas getting full, the rivers getting full. So such small boats can easily be turned upside down, or they can easily sink in the water. So they should avoid such areas using such small fishing crafts and boards. Okay. Now, we also need to look at the satellite images and how they are effectively tracking the tropical cyclones. Okay. For example, this is the influence of the satellite image. And somewhere here, we have the numbers that are showing stage 1, stage 2, or different phases, 1, 2, up to the different areas. Now, this becomes the path. Okay. This becomes the path of a tropical cyclone, meaning that if maybe it's going to affect this area, people need to be informed that please, it's going to take that path. So people are aware of where it is going to pass and how it's going to take place. Therefore, data is received and it is real-time data. You must know that satellite images are very effective in tracking because there is real-time data that is acquired. It has acquired immediately and it is accurate. Okay. You don't need to first store it, interpret it. No, immediately it is acquired. You can easily interpret it. Okay. Data can be easily monitored every hour so that you know what will happen the next hour, and then you will know what is going what to do. It determines the intensity of a storm. It predicts the path, and therefore large accessible areas can be monitored. So people are going to be, or the government is going to be using this information to ensure that we control areas that are being affected by tropical cyclone and we reduce the damage. Okay. Now here we look at the different aspects. For example, somewhere here we have how to manage tropical cyclones. Okay. Here the satellite images or the satellite imagery that are acquiring data on the Earth's surface. Okay. You can also use the remote sensing to acquire data. And therefore, you have observed that this is where the eye is. Okay. And therefore, if you observe that, what do you need to do then? Okay. Prepare the emergency rescue services that are in the helicopters. So if this is the area that is going to be flooded with all this water, some people might remain in these areas. They need to be taken away from such areas using the emergency rescue system or emergency rescue people. So those people are going to come there, get them from those areas. You might find that they are still there lying, or their bodies are lying there if they have been affected before they are even get to see the damage. Okay. You also need to have housing, okay, on the stilts. Strong materials are going to be used to build such houses in case such areas are going to remain with people. Use very strong materials such that even when the strong winds come, those houses will remain intact. Okay. We also need to have what we call flood proofing. In other words, some areas can be flood prone or some areas can be affected by floods, but if such areas have got proof to flooding, then you are going to avoid the damage. Good communication system. The satellites are there, the radars are there. You are going to communicate to people through using radios and so on and so forth, such that they can be aware of what is likely to happen when the tropical cyclone is about to occur. Besides that, you might have clear evacuation routes. You see, the routes are very clear so that if this area is affected, you can easily rescue them, take them to different areas. Then have evacuation centers that you know that if I take those people from these areas that are maybe affected by tropical cyclone, I can put them in here where the effect is not going to be so much or where they are not going to be affected. Okay. Then have extensive medical systems or paramedics to provide assistance. You can have hospitals. You can see here that if they are taken from there and they are damaged or they are affected by tropical cyclone, take them to the hospital. So such things are supposed to be in place. Okay. You can also have those storm warden patrols. People should, those ones are going to be patrolling these areas that are likely or that are affected by tropical cyclone, so that you will do damage control in such areas. So that is basically what we refer to as a tropical cyclone. So in this case, I'm trying to recap the whole topic of a tropical cyclone. What do we need to know? We said that it is named alphabetically. For example, Andrew, Bonnie, Carol, Deborah. In this case, the first letter of the alphabet is A, that means it's number 1 in that season. B is number 2, C is number 3, D is number 4, and so on and so forth. Then we must know that tropical cyclone originates from the ocean, okay? Not near or not between 0 and 5, it does not occur, okay? But from 5 and above, it occurs. That is the tropical cyclone. What is its movement? It moves from east to west, okay? Away from the equator, it turns east when it reaches 30. What happens? Destruction. We look at the fact that they have got strong winds, very, very, very hard rainfall or heavy rainfall, and it's associated with flooding. Then you look at the conditions that are occurring in the eye. You must note, learners, that we have got two aspects. Number one, we have got the eye, okay? We have got the eye vertex. This is the eye wall. This is the eye wall, okay? And this is the eye. So what happens when warm air rises? It is rising here along the eye wall. Remember, it is warm air. It has got moisture embedded in and latent heat. So when it reaches the upper atmosphere, it condenses at a condensation level, okay? Condenses. And when it condenses, it forms clouds. So these are the cumulonimbus clouds. We shall name them as the CN, cumulonimbus clouds. So when clouds are formed, therefore there is loss of latent heat, and this results into heavy rainfall. We see heavy rainfall on the eye wall. Can you see that, learners? Heavy rainfall on the eye wall. But don't forget that when this warm air, when the warm air rose, it rises, it condenses to form cloud. That means it loses the heat that was embedded inside, the latent heat. So there is divergency in the upper atmosphere. Some cold air moves opposite direction, but some other air descends. As it cools, it becomes heavy, and therefore it descends within the eye of a tropical cyclone. So within the eye, what are the conditions you expect? There is descending air, okay? Remember, descending air hits adiabatically, okay? And therefore, when it hits, what will happen here? We shall have, as it is descending, cold air descending, we shall have clear skies, okay? Clear skies. In the eye, we shall have clear skies, okay? No rainfall. No rainfall in the eye, no rainfall or no rains. Remember, we said here it is heavy rainfall around the eye, but within the eye, no rainfall at all. Okay, no clouds or clear skies, no rainfall. Calm weather conditions are all here within the eye. Why? Because you have got cold air that is descending within the eye. So learners, I want you to note that the climatic conditions or the climatic conditions, the climatic or the weather conditions that are experienced within the eye are totally opposite or are totally different from what is experienced within the eye wall. So the eye wall has got unstable weather conditions. It has got heavy rainfall, very strong winds, okay? That is the eye wall. But within the eye here of a tropical cyclone, what do you expect? We expect no winds or calm, clear conditions. That is within the eye. Clear skies or no clouds at all. No rainfall at all. Calm weather conditions. All these aspects in the eye, we say no. But when you're looking at the eye wall, we say yes. What shall we have? Eye wall, strong winds, cumulonimbus clouds, heavy rainfall. So we say yes. Okay? These are the weather conditions. Before the eye, we shall have during the eye and after the eye. So before the eye, during the eye, and after the eye, what do you expect? So within the eye, you expect this. Before the eye, that is the eye wall, you expect the opposite of what happens in the eye, and so on and so forth. So here we have the dissipating stage. So in the last stage, what do you expect? It reaches the land. when the tropical cyclone reaches the land, it dies out. Why? Because on the land, there is too much friction. Okay? No warm air rising. No moisture over the land. No moisture. Remember, it needs that moisture content for it to be formed. It needs warm air, and it is forming on the sea surface or on the sea area where there is continuous evaporation and less friction. But when it reaches the land, these are the conditions you expect. No moisture, no warm air, and friction is very, very much, and that determines it's starting to dissipate or dying out. We also have another aspect here, which we call the management of a tropical cyclone. The management of a tropical cyclone. We said you can use sandbags. What do sandbags do? Remember, if you're near the coastline or if you're near the sea and that sea rises because of the heavy rainfall, what will happen? That water will start flooding inland. Therefore, you can manage it by getting sandbags, put them, pile them, and therefore, when you are piling them, you are creating an embankment to stop the flooding into the inland. Then early warning systems. When we talk about early warning system, what do we refer to? Let the people know. Use radio stations, use newspapers, use magazines. You can use TV. Let the people know that this is likely to happen. And therefore, if you let them know, you are trying to control the damage, to reduce the damage that is likely to happen. You can also track the storm, know the path. When is it likely to happen? What is the intensity, the speed, so that you can know and people will be informed of what is likely to occur. We also have another one. We say in the same line, we must inform people, let them know, okay? Then provide services to them like medical services, food. There you are trying to manage the system or to assist the people who have been affected. And lastly, we have the evacuation plans. So within the evacuation plans, you must have where to put them. Okay. Now, learners, I want to see if really we can try to answer the questions that can be asked. Here, I have one of the examinable questions. And in this case, we said in USA, it is a hurricane. In Africa or along the eastern side of Africa, we have a tropical cyclone. Okay. I don't have Australia here, but we can see that Australia is somewhere there. So it's known as Willy Willy. Okay. Now, under this line, we have what we call the equator. Okay. And therefore, the equator, there is less Coriolis force, yet we said it needs Coriolis force. We have the warm water, okay, because the equator is very hot, therefore we have the warm water and moisture content is high. Tropical cyclone moves eastward. It moves from east to west. So it moves westward, not eastward, sorry. It moves westward. Okay, tropical cyclone is part of the easterly belt, therefore it moves from east to westward. Okay, then we also have the fact that there is land, like for example here, no warm water, and there is too much friction, which stops the occurrence of a tropical cyclone. Okay, then there, in this examinable question, I would like to see question number 1, give one similarity between a hurricane and tropical cyclone on the map. Okay, what is the similarity between a hurricane and a tropical cyclone? The similarity, the one similarity that we can see, that it occurs on the eastern side. Can you see? This is Africa, and therefore this is the east. This is Africa, and this is the east. Can you see that? I mean, this is USA, this is the east. This is Africa, this is the east. So this is east, this is east. The number one similarity, that it occurs on the eastern side. The second similarity, when you look at the arrows here, it moves, as it is moving away from the equator. Can you see? It is moving away from the equator on the eastern side. Okay. it is part of the tropical easterlies. Like you can see, it moves from east to west. Can you see that? From east to west. As it is moving away from the equator, is taking the east, it's part of the tropical easterlies, therefore it's from east to west. Okay. Another thing that when it reaches the land, it dies out because there's no warm moisture and so on and so forth. The influence of the Coriolis force is less near the equator. Those are the similarities, but they only want one. So anything you can give here is right so long as it's a similarity. Okay. Number 2 is explain the point of origin of both hurricanes and tropical cyclone on the map. The point of origin, where does it start from? Okay, you can see it starting from east to west. Okay, we can also say that as it is originating from east to west, it is moving away from the equator. All right. You are explaining the original point, the point of origin of both hurricanes and what? And tropical cyclone on the map. So it is originating from east to west as it is part of the tropical easterlies. Okay. Number 3 is why do these cyclones move from east to west? It moves from east to west because it is part of the tropical easterlies. Tropical easterlies, just like you hear it, tropical easterlies, originating from the tropics, and it is moving from east to west. That's why it is moving from east to west also, because learners, I want you to understand, if you are sitting in a bus that is traveling from west to east, you are also moving from west to east because you are sitting in that bus. In the same way, tropical cyclone occur within the tropics, but within the tropics, the winds are moving from east to west. Therefore, the system of tropical cyclone is also meant to move from east to west. That is why it is moving from east to west. Hope you understand, learners. Number 4, why do tropical cyclones weaken as it reaches the land, or when it reaches, or it as they move over Madagascar? Madagascar is land. Can you see that? So because Madagascar is land, what happens? There is no warm water. There is too much friction. There is less moisture. That's why it weakens when it reaches the land. You know, friction stops or it reduces the speed, and tropical cyclone moves faster when there is no friction. Lastly is why is the impact of a tropical cyclone more severe in developing countries? Now I want you to look at these, learners. We are looking at developing countries. Why is it severe in the developing countries? When you look at developing countries, they lack a lot of aspects. In this case, we look at developing countries. You might find that someone deep in the village there, in a very rural, serious rural area, or we can call it a farm state. These people do not even have access to electricity. They don't even have TVs. They don't have radio stations. How do you expect to warn them of what is going to happen? Because it becomes very difficult for you to reach them. Yet we can let them know of the tropical cyclone, when it is going to occur, which path is taking, and so on and so forth. Therefore, developing countries are likely to be having this effect, or they are likely to be affected by severe conditions of a tropical cyclone, because number 1, they don't have access to the warning system, the warning systems like TVs, like radio stations, some rural areas. Number 2, that some rural areas have got very poor infrastructure. Because of this poor infrastructure, if the damage has occurred, it becomes very difficult for them to be informed of for them to be evacuated or to be assisted, because they do not have, the areas are inaccessible. They can't be reached. Okay, so that's why it's going to be severe. Another thing that is in developing world, we don't have that better technology of tracking the tropical cyclone. Therefore, you don't know where it's going to pass. They don't know where it's going to affect the people. And under that line, the effect is going to be very, very, very severe in the developing world. Okay, hope you understand, guys. When you explain any of those aspects, it will help us to understand tropical cyclone. Okay, so I expect learners for you to be knowing these aspects now. You can answer questions that come like this. So the advice I can give you here, that find more questions related to tropical.
Okay. Now, let's continue with question 2 now. We're looking at climate and weather, which is question 1. Question 2, now let's look at geomorphology. What content are you expecting to be tested on? The content that you expect to be tested on will be the content that you expect to be tested on would be stream patterns, stream order, long and cross profile, fluvial landforms, stream piracy or river capture, and rejuvenation. Now, let's start first by looking at the typical examination questions. This one is on types of rivers. Now, here's the question. The river illustrated in the sketch is a permanent or periodic river. So you need to look at the sketch now. You have to check what's happening with the water table there. This is what is shown here. This is what is shown here. So that is your through flow. That is your water table. So this river here is permanent river. And why are we saying it's permanent river? Because we can see that the water table there is in the riverbed. The riverbed is crossing through the water table throughout the year. So for dry season and for wet season. So you refer to this water table in the rainy season. There's water table in the rainy season and water table in dry season. So at both instances, the water table is always above. The water table is always, or the riverbed is always below the water table. The riverbed is below the water table. So the water table is above the riverbed, which means now there's always going to be a source of water throughout the year. So during rainy season, this river will flow because it has got two sources. Number one, it has groundwater as a source. Groundwater, it intercepts through water table. And number two, there is precipitation. And during dry season, there's only going to be groundwater that is supplying the river. So this river is going to flow permanently or throughout the year. The question says, state two characteristics of the river system evident in the sketch. Now, what is it that you see in the river? Give evidence from the sketch that the surface runoff is greater at A than at B. So this is A and this is B. Give evidence from the sketch that surface runoff is greater at A than at B. So we have to give that. We'll look at the answers there. Which one of the cross sections Y or Z represents the river at point C? So the river at point C, which one? Is it this one, Z, or is it Y that represent the river at C? And then give reasons for your answer. how will a decrease in precipitation affect the following water table or type of river? Now, let's look at this. We said the river is permanent, and now the question is, what is it that you can see? State two characteristics of the river system evident. What is it that you can see here? What is it that you can see? You can see the dendritic pattern. Can you see the dendritic pattern? Here is the dendritic pattern there. Can you see it? What else can you see? The volume of water increases from source to mouth. Now you can see the line here. There's the source. You can see the line here is getting darker to ensure that the water is increasing, and here the line is thinner. So that's what you can see there. What else? There is high water table. Tributaries are divided by interflows, second order streams, low drainage density, permanent. So how do you tell low drainage density? You can see there are few streams there. There are few streams there. That's evident that you can see. The river is permanent. The river intercepts the water table in wet and dry season. And there is gentle gradient. There is gentle gradient. This gradient is not so steep. What else can you see? The tributaries are joining the main streams at acute angle. Just because we said the river is dendritic, now those are the characteristics of dendritic pattern. Let's go to the next question. Give evidence from the sketch that the surface runoff is greater at A than at B. Now, how do you tell that it's greater at A than B? There is less vegetation at A. More tributaries feed the channel at A. The channel at A is wider. Higher volume of water at A. A is in the middle or lower course, higher stream order at A. So these are the characteristics that you should know, that volume of water will be higher there than volume of water will be higher at A than at B, because the volume of water increases as the river flows towards the mouth. And then, which one of the cross sections, Y or Z, represents the river at point C? Now, there is your river at point C. Which one will represent the river at point C? Is it Y or is it Z? Now, how are you going to look at that? Answer there says Z. How do you determine that it is Z? So at Z, this is at the lower course where the river where the volume of water has increased, and now you can see that the water table or the riverbed, the water table rather, yes, it is above the riverbed. The water table is above the riverbed for both seasons, for both wet season and for both dry season. Which one? Give a reason for your answer. You give the answer. I've already given the answer. Is because the water table is above the riverbed for all seasons. How will a decrease in precipitation affect the following water table? Now, this question can come in number of ways. This question can come in number of ways. In this question, it says, how will decrease in precipitation affect the following water table? Number one, water table. If there is a decrease in precipitation, the water table will be lower. And how will that affect the type of river? The type of river will change from being permanent to being periodic. Now, if the question is not saying decrease, when the river says increase, now you're going to give the different reason now. Let's say examiner does not say how will a decrease. It says how does the increase in precipitation. Now it's what will happen to water table. Water table is going to go higher and the river will flow throughout the year. Now this is application question. One of the question could be, how will prolonged drought, let's say, how will prolonged drought impact on water table? So drought is also going to result in drop in water table. It is also going to result in a river becoming periodic. Now, sometimes they can ask you, how will the extraction of a well, like something that we are going to use to extract groundwater, how will the extraction of well impact on the water table? The well, because water is going to be now used from the ground. Groundwater will be used. Now it means now the water table will also go lower. So this is an application question. It can take any form and direction. It can ask you about the increase in rainfall, a decrease in rainfall, or it can be, again, how will the construction of urban settlement, how will the construction of urban settlement impact on the water table? Now, you can decide, okay, when we do urban settlements, what do we increase? We are going to increase surface runoff. Now, when we have an increased surface runoff, it means now there's going to be less infiltration, and therefore the water table will also drop because there is going to be more runoff and less infiltration. So that question can take different application strategies. You could be asked to apply a number of ways here. Now, let's continue with our question. One of the questions that, one of the topics that you must know is your dendritic, not dendritic, is your stream patterns. Now, we are looking at the most common patterns here. We have radial pattern. We have this one as radial. You can see the streams are radiating from the high point. And then what is important when you do drainage patterns? There are three questions that you need to know. Number one, you need to be able to identify a pattern. The question is, you need to be identify drainage pattern at A, identify drainage pattern at B, at C, and at D. You must be able to identify. That's number one. Number two, you need to explain the underlying rock. Underlying rock simply refers to where is this drainage pattern found, or where can this drainage pattern develop, or yes, where could this type of pattern be located. And number three will be, you need to give the characteristics. You need to give the characteristics of each pattern. So these are the main questions that you should know when you're talking about drainage patterns. Your questions, or how does so the question could be, how does the underlying rock influence the flow? So now, how the question could be, how did the underlying rock influence the pattern here at the radial pattern? It's because the high-lying area make water to radiate. So it is application question. You need to be able to apply the knowledge that you have studied in class. Except for you knowing that it is dendritic, you must know dendritic is found where rocks have uniform resistance to erosion, and it does not look like a tree. It looks like the branches of a tree. It looks like the branches of a tree, not like a tree itself. And then trellis pattern, mainstreams are parallel to each other. It has short tributaries. And then this one, you should know the tributaries here are acute. Here, the tributaries here are 90 degrees. So the difference that you should know about that. And here, the tributaries are shorter. And then with the rectangular pattern, you must know that the streams follow the joints or the bends in the main river. So what is common with the two patterns, with the trellis and rectangular pattern? What is common with that is that the tributaries join the main streams at 90 degrees. The tributaries join the mainstream at 90 degrees. But with dendritic, the tributaries join the mainstreams at acute angle. So that's the difference. And those are the differences and the similarities between the three drainage patterns. And then let's continue with our drainage patterns. So you should be able to identify them from the maps. So an examiner could just take a portion from the map and say in block A1, block A2, identify this drainage pattern in block A1 or A2. So you must be able to identify the patterns in looking at the particular block. And then this one over here you can see is trellis, and then the development of trellis pattern is where there is hard rock. You can see this one is hard rock, and here you have the streams. It shows the rocks here are softer, hard rock. So the rocks is hard rock, soft rock, hard rock, and that is that, which is different from the dendritic pattern. Dendritic pattern, you can see the type of rocks here are the same. So it means there is similar resistance to erosion. But here you can see there's varying resistance to erosion, because at one point the stream and the rocks are harder, and at one point the rocks are softer. And this is radial pattern. You can see we have a high-lying area, and the streams are flowing away from each other. And then what do we have here? We have igneous rock, but we can see the igneous rock have got cracks. So the streams are following the cracks in the igneous rocks. So that is your rectangular pattern. You must be able to answer those questions. So these are the characteristics, and as you studied them throughout the year, you're looking at the diagrams. You should be able to identify these diagrams, and then you must also make sure that you are able to differentiate between the different patterns. And then there is another pattern here that is missing here, which is a parallel pattern that looks more like the dendritic pattern, but a dendritic pattern that is a little bit more straighter. That's your parallel pattern. So you must be able to identify different patterns. And then how do we describe the dendritic pattern? You say it looks like the branches of a tree and tributaries join at acute angle. And then where is it found? Where rocks have got similar hardness or similar resistance to erosion. Then you have the trellis pattern. The characteristics of trellis pattern is that you have parallel main streams, and you have tributaries that are short, and they join mainstream at 90 degrees. So where is it found? The underlying rock is gently sloping alternating layers of hard and soft rocks. Sometimes you can also say it is fine where you have your inclined strata, And now radial, like the name say, radial, it radiates from the high point. It looks like the spokes of a wheel viewed from above, and river flow away because it radiates. The river flow away from a central point. Then what do we have there? You have a rectangular pattern. So with a rectangular pattern, we can see again, like we said, the mainstream have got 90 degrees bend, and the tributaries join the mainstream at 90 degrees as well. And we have centripetal. Centripetal is opposite. Centripetal is opposite to radial. The streams are flowing towards the low-lying area. Streams flow towards a central basin, such as marsh or lake. Then we have this pattern, which is called deranged. The name say is deranged. Small streams that have no specific pattern. The streams flow into the lakes, out of the lakes, like that. So it doesn't have a definite pattern. And we have parallel pattern here. You can see the streams will look more like the streams in a dendritic pattern, but the streams will be parallel. They will be flowing parallel to each other. Usually it's going to happen where we have ridges. They will occur mostly where the area is very steep. So that's where you're going to get your parallel pattern. Now let's look at Let's look at your, let's continue with this. What's happening with my slide? Okay. Now, here's a short activity that we can do based on a string pattern. String patterns. So what do we have there? Indicate whether each strange pattern A, B, C refers to landscape 1. So you must be able to show which landscape will result in which straight pattern. So there they are. We can see which one develops there. This one is a radial. That's the radial there. Now you can see here they have got bends. So that's your rectangular. And here you can see the parallel mainstreams there. You can see the parallel mainstream, the hard and resistant rock. So that will be the example there. And this is coming from a previous question paper. Now, drainage density. So when you speak of drainage density, you must be able to define what is drainage density. So density, we're simply referring to the total length of streams divided by the total area of the drainage basin. So when you're looking at these two, when you divide this, you can see here at the bottom here, we have fewer streams. And then when you're looking here, above here, we have more streams. So when you have more streams, we have higher density. So there are two processes that are responsible for drainage density. There are two processes that are responsible for drainage density. The processes that are responsible for drainage density, number one is infiltration. And the second one is runoff. These are the two processes that influence drainage density. These are the two processes that influence the drainage density, runoff and infiltration. So runoff or surface runoff is the flow of water on the surface, and infiltration is the absorption of water by the earth's surface. Now, when you're looking at this question, there are factors that are going to influence drainage density. There are factors that are going to influence drainage density. Number one, it will be vegetation. Now, if you get a question that says, explain how did vegetation influence the drainage density at A? So this is A, and this is B. If the question says, explain how did vegetation influence density at A, you will say at A there is less vegetation, and therefore there is more at A there is less vegetation. As a result of that, there is more surface runoff, which results in higher density. And there is less infiltration because you can see a lot of water is flowing on the surface. And then at B, how did vegetation influence the density at B? How did vegetation influence density at B? Then you can say at B, there is more infiltration at B. There is more infiltration, and therefore it's because now there is more vegetation at B. Because of more vegetation at B, it resulted in more infiltration and less runoff. That is why we have lower density. So when you're looking at the factors that influence drainage density, number one, remember you have vegetation. Number two, we have gradient. We have precipitation, type of precipitation. We have soil moisture. Now, we've already accounted for vegetation. Now, let's look at this too in terms of soil moisture or type of soil. Now, when you're looking at A, What is the type of soil? The type of soil here, or the type of rocks here, at A, there is hard rock. Because of hard rock, what is happening? At A, there is hard rock. Because of hard rock, what is happening? There's going to be more surface runoff and less infiltration. That's why we have more water flowing, causing high density. And at B, what is happening there? There is a soft rock. The rocks here are softer, and therefore there is more infiltration and there is less runoff. That is why the density is low. And then we also look at the gradient. How did the gradient influence the density at A? It means now at A, the gradient is very steep. Because of steep gradient at A, that is why we have high runoff and we have less infiltration. That is why it resulted in what? In higher drainage density. And now, what is happening here? At B. B indicates that the gradient here is very gentle. Because of gentle gradient, what is happening here? There is more infiltration and there is less runoff. There is more infiltration, less runoff. Hence, we have lower density. What do you mean lower density? Hence, we have fewer streams. We have fewer streams because most of the water infiltrated. But here, most of the water is running on the surface. Is doing what we call surface runoff, or is flowing. And now, between the two, at A, what is happening here? Why do we have high density at A? We have high density because the soil has more moisture. The soil is saturated. Because of saturation, during precipitation, there is less infiltration taking place, but there is more runoff taking place. That is why we have higher drainage density. But when you're looking at B, what is happening there at B? At B, the soil is dry. So there is less soil moisture. That is why during precipitation, there's going to be more infiltration and less runoff. That is why it results in low drainage density. Okay, so these are the factors that are going to be influencing the drainage density at A and B. So you must be able to explain how drainage density is affected by a number of factors. You must be able to, because the question could come in a scenario question saying, how did vegetation influence density at A? Or how did gradient influence density at B? Then you must say at B, the gradient is gentle, and therefore there is more runoff, there is less runoff, more infiltration. That is why at B, the drainage density is low. So that's an application question, and that is how you can answer those application questions. Now, let's quickly look at the activities here that we have. Now, we have these activities. Dense vegetation cover that prevents a surface runoff. So here at B, you can see there is less infiltration. At B, you can see there is less runoff. Why do we say there's less runoff? Because there's few streams. So it means here there is dense vegetation here. There's more trees and grass. There is more vegetation. Therefore, there is more infiltration and there is less runoff. Drainage basins that experience high rainfall. Because of high rainfall, water doesn't have time to infiltrate because it rains regularly. Therefore, there's going to be high drainage density. Drainage density that has mainly clay soil. Clay soil does not allow water to pass through easily. So we have this, what we call aquifer. We have what we call aquifer, and we have what we call aqueduct. We have what we call aqueduct. What is an aquifer? It's a surface that allows water to pass through easily. And what is an aqueduct? Is the surface that does not allow water to pass through easily. Now, a clay soil. Clay soil is an aquifer, and it's an aquiclude, sorry, it is an aquiclude, it does not allow water to pass through. So if the water is not passing through, it's not infiltrating, then it means water is going to flow on the surface. So A is a clay soil because there is more water on the surface. Drainage basin that has mainly permeable rock. Permeable rock meaning that the surface is porous. So it means there are many pore spaces here. It means there are many pore spaces here. And then what will pore spaces do? Pore spaces will allow water to infiltrate. So B has got a high level of porosity. Because of high level of porosity, B will also be permeable. But A is less porous. There are few pore spaces for water to pass through here. There are few pore spaces for water to pass through. So there is a relationship between porosity and permeability. The higher the pore spaces, or the higher the porosity, the higher the permeability. What is porosity? Porosity simply refers to the pore space per unit area. Pore spaces per unit area. So here there are many pore spaces per this area, but here there are fewer pore spaces per this area. So area B has high porosity, and because of high porosity, area B will be more permeable, and therefore is going to allow for more infiltration, and is going to result in less runoff. But A is less porous. The porosity here is low, and because of low porosity, there's also going to be low permeability. That is why we are going to have more runoff here, because most of the water is going to be found on the surface, but here most of the water is going to infiltrate. Drainage basin that has mainly permeable rock, so we can say B has got permeable rock and A has impermeable rock. A river that flows through hilly areas refers to steep gradient. So because of steep gradient, there's going to be more runoff and less infiltration. But here it will be on a gentle gradient. Drainage basin that has porous rock with sandy soil. Here B has high porosity, like I explained, and there is more infiltration and less runoff. That is why we have low density. But now when we're looking at A is less porous, and therefore there is less permeability, and this is clay soil, and there's going to be a high runoff. A river that flows through gently sloping land. River B is flowing at gently sloping land because there is more infiltration because of gentle gradient, and there is less runoff, and there is going to be less low drainage density. Now, let's look at this. This is a similar question to that. Now we're looking at which one has got lower infiltration rate. Lower infiltration rate will be at B. There's low infiltration, there's high runoff. Denser vegetation at A. Higher soil moisture at B. Because of soil moisture, there's less time for water to infiltrate. Developed on the least resistant rock. It's least resistant. A is least resistant, which means the rock is soft. So there's going to be more infiltration and less runoff. Lower degree of permeability. This one has got lower degree of permeability. There is less, this area is less permeable, and therefore high runoff and less infiltration. High stream order, there are more streams order. There are more streams here than here, and therefore it will result in higher stream order. The graph below represents this drainage basin. The graph below represents this drainage basin. Which graph here will represent this drainage basin? So, graph 1 will represent a drainage basin. Drainage basin B, and this graph will represent drainage basin A. Okay, now this is stream order. What do we look at when we're looking at stream order? First, we're looking at the streams, first order streams. All the tributaries in a drainage basin are referred to as stream order 1. Now, when stream order 1 and stream order 1 join, they make stream order 2. But you must be careful now when you look at them. You have stream order 1 and stream order 1, they make stream order 2. You have stream order 1 and stream order, they make stream order 2. But you have stream order 1 and stream order 2, they remain at 2. So when two streams of a different order are joining, the stream order is not going to change. It's going to remain at the highest order. If the highest order was at 2, it remains at 2. If it was stream order number 3, and stream order number, if it's stream order number 1 joining with stream order number 3, it's going to remain stream order 3 here. It's going to remain at stream order 3 here. The order is not going to change. Only if it's stream order number 3 and stream order number 3 that are going to join. Only if it's stream order 3 and stream order 3 that are joining, it will remain in stream order 4. But if you have the highest order and the lowest order, the order remains at the highest point. You can see here, we have 1 and 1, it makes 2, but we have 1 here, then you have 2 here, they all join here, it remains 2. You have 1 here and 2 here, is also going to remain at 2 here, because they are of a different order. So stream order, we're just looking at 1 and 1. If it's 1 and 1, they graduate to 2, and 2 and 2 go to 3. 3 and 1 remains at the highest order. 3 and 2 remains at the highest order, which is 3. 3 and 3, it moves to the higher, it moves to the next level. It's 4. And then 4 and 3, it remains at 4. And 4 and 4 goes to 5. So it goes like that. 4 and 5 is going to remain at 5, and 5 and 5 is going to move to 6, just like that. So it remains at the highest order. But if they are of the same order, they move to the next level. Now let's look at a river discharge. A river discharge, you must be able to define what is a river discharge. Is a volume of water as it passes a specific point at a specific time. It's a volume of water as it passes a specific point at a specific time. Now we have two types of a river discharge of flow characteristic, which is laminar flow and turbulent flow. Laminar, water is flowing in layers. It's flowing on a gentle gradient. And turbulent flow, water has turbulent, it swells like that, and it's flowing on an uneven riverbed. So water flows as a parallel sheet. Riverbed is even, less erosion, lower cost. So this is a river and at its lower cost. And turbulent, there are rapids, there are waterfalls, there are a lot of obstacles along the river course. These obstacles that we call nick points. These obstacles along the river course that we call nick points. They are going to make the river to flow on an uneven surface, and that flow characteristic is called a turbulent flow. Now we're looking at longitudinal profile of the river. What is a longitudinal profile of the river? Is the view of the river from the source to the mouth. Is the view of the river from where it starts to where it ends. That's what we call a longitudinal profile of the river. Longitudinal profile of the river is the view of the river from the source to the mouth. Now we have the stages of the river. We have the upper course. What are the characteristics? It is steeper. Now, it is steeper and water is flowing fast. So the water is very little. There is little amount of water, but the water is flowing fast. Why is water flowing fast? Because of a steeper gradient. And the type of the characteristics of erosion here, or the type of erosion, is downward erosion or vertical erosion. Is downward erosion or vertical erosion. And what are the features that you're going to find along the river in the upper course. It will be your waterfalls, your rapids, your interlocking space. These are the features that you'll find in the upper course. And then the valley, the cross section. So this is a longitudinal profile. This is a longitudinal profile. And now what will the longitudinal profile of a river show you? Longitudinal profile of the river will show you the side view of the river, and it will also show you the length of the river. Now, when you're looking at the cross profile of the river, what will you see from the cross profile of the river? You will see the depth of the river. You will also see the width of the river. Those are the characteristics of a river that you will see from the cross profile of the river. Now let's go to the middle course of the river. Middle course of the river, what are the flow characteristics? The gradient there is gradual. The water is flowing slow. There is lateral erosion, and you are going to find the meanders that are beginning to form, and you also find the space. Remember, in the upper course, you're going to find the interlocking space, but in the middle course, you will find the space. That's what you will find. And now, let's look at the cross section of the river in the middle course. So you can see now the valley is wider. What made it to be wider compared to the upper course? So here we're saying it is U-shaped. It is U-shaped, which is slightly wider than the V-shaped. But why is it wider like that, or why is it a U-shaped? It is mainly because of lateral erosion. So lateral erosion results in the widening of the river. It results in the widening of the river, but when looking at the vertical erosion, it results in the deepening of the river. So what do you see from the cross section? You see the width and you see the depth. So the cross section, what dimensions can you see from the cross section? You see the depth, you see the width. Then you can compare, you say the river is deeper in the upper course, but it's wider in the middle course compared to the upper course. But now, when you proceed and go to the river in its lower course, you will see now the river is at its widest because it is the gradient there is almost flat. It's almost flat. It flows very slow because of a gentle gradient. And then this is the point of the river where the river has the highest volume of water. The river in its lower course, it got the highest. You can see here the volume of water here. Just little volume of water. Here the volume of water has increased, but here the volume of water is at its highest. The volume of water is at its highest. But now, there is more deposition. Why is there more deposition? Because the river is flowing slower because of the gradient is almost flat. And then what are the features that you're going to find? You're going to get the oxbow lakes, the deltas, meanders continue. We're going to have meshes and braided streams and sandbanks. Those are the features that you're going to get at the lower course of the river. Now, this is the continuation of the longitudinal profile of the river. You have the upper course, middle course, and then this area that you're looking at here, this green area, this is what we call the floodplain. This is what we call floodplain. You can see it is nice and green. You can see it's nice and green is because it has got a deposition. You remember we said this is floodplain. What is happening? Floodplain. The way it said floodplain, it calls floodplain. There's a name. So it means now a lot of flooding is taking place, which means there's going to be alluvium there's going to be alluvium that is deposited there, alluvium being the fertile soil. So now this floodplain is very useful for farming. What makes it useful for farming? It is its gentle gradient. Number two, it is access to water. Number three, it is a flat gradient. It's flat gradient, number one, makes it useful for farming. It's fertile soil, makes it useful, and access to water makes it very fertile. But now there's a risk of flooding again there. The risk there is there's a risk of flooding because it's at its lower course where the river volume is higher and the volume, the river, what's this? The gradient is very gentle, so there are higher chances of flooding. So there are a number of factors for and against you using the floodplain. And then here in the mouth, these are the features that we call delta. The delta occurs when the river breaks into distributaries. When the river breaks into distributaries. So the distributaries will be the small streams that break from the mainstream as the river flows into the sea. Remember, the tributaries join the river, but the distributaries break away from the mainstream. So this is a continued characteristics of a river profile. And now what we have there. So because here we can see, all we see here is contour lines showing that the area is very steep. So this will be the upper course of the river. It is steeper, the water is flowing fast. The dominant erosion here is downward erosion. And the features that you are going to find is waterfalls, rapids, and interlocking space. Then we go to the middle course. Here you can see it's middle course because the river is gradual, it's not so steep. You can see there is a lot of farming taking place around here. You can see there's cultivated lands and there are orchards. So there's a lot of farming taking place here. You can see we have orchards there, we have cultivated lands there. Cultivated lands. You must be careful between orchards and cultivated land. So many times people confuse cultivated lands and orchard because of not paying too much attention to detail. So this is the river in the middle course. Then you can, the examiner can ask you what measures have been taken into consideration to mitigate or to reduce the chances of flooding, because in the middle course the river is gradual. So you can see there's a lot of dams, there's a lot of storage dams to reduce the water that could flow on the surface. So these dams here could be used to reduce flooding, or they can also be used to store water to use during dry seasons. Now there is a river in its lower course. So this is a braided stream. Now you must be careful between a braided stream and the delta. So a braided stream is a river. It's going to have the islands like that, the sand islands like that. It will break, but it will also join. The river will join, will break and join. So this is what we call a braided stream. But when it's a delta, the river is just going to have distributaries. The river will have distributaries, and those distributaries will not join again. Those distributaries, each stream will be flowing into the sea. But here, what do we get here? We have a braided stream. So what you can see there, you can see you have your marshes there and flays there. You have your sand deposit or sand banks, sand banks here that you can see there. So this is your braided stream. And then what do you have there? You have a meander. You must know what is a meander. A meander, this is a meander, which is a bend. This a meander is a bend. So a bend in a river course is called a meander. So sometimes examiner ask you what is the what is the feature? What is the feature? So when you're looking at it like that, that feature is called a meander. So Now we're looking at the river, from the side like that. So we have what you call graded and ungraded profile. We have graded. So why is this river ungraded? Because there are obstacles or there are nick points. Why is this river graded? Because it has got a smooth concave profile. This river is graded because of the smooth concave profile. So these are the nick points. These are the nick points or the obstacles. The temporary base level of erosion. We call them temporary base of level of erosion because they can change over time. Now, this is the cost profile of a meander. This is a meander. So in a meander, the outside of a meander is called an undercut slope. The water is flowing faster on the outside. And then because of faster moving water, there's going to be erosion. And on the inside, you can see here, we've got a lot of deposits here because water is flowing slower. So there's a lot of deposition. And what is the name of the inside of the slope? It's called the slip of slope. That is where material is slipping off, and it is deposited there. Now, we have the cross section here. So if you are to draw a cross section of a meander, you must just identify which side of the meander is deeper and which side of the meander is shallow. So if you are able to identify which side is deeper, all you do, you draw a Nike sign. So that is your Nike sign. So if your deeper side is on the side, then your Nike side will face to the right. If the deeper side is on the other side, your Nike sign will take a different direction. So all you do, you put a Nike sign for you to represent a cross section of a river or a cross section of a meander rather. Now that's your features of a drainage basin. You have the river. The source will be a point where the river starts. Then you have all these characteristics. Now let's look at I was talking about delta. So we see the difference between the delta and a braided stream. At this point, we have a braided stream. So you can see at this point, a river is breaking and the river joins again. So that's your braided stream. But with a delta, a river is going to break into these tributaries as it flows into the sea. So these tributaries are not going to join again. So this one will have, both of them are going to have sand islands. They're going to have sand islands between them or between the streams. But here, it's going to join again as the river continues. And now, what do we have there? You have your Oxbow Lake that is going to later on become so this one already we can see that this one doesn't have water. So now it becomes a meander scar. So when it contains water, it is an Oxbow Lake. So once it becomes dry, we no longer call it an Oxbow Lake. We call it now a meander scar. And now that's the development of a meander. Now, sometimes the examiner can ask you, where will the Oxbow Lake more likely to form? At 1, 2, 3, 4, and you can say it's more likely to form at 4. Why? Because you're saying the meander neck. This is the meander neck. So the meander neck here, you can see it is wider. The meander neck here is wider. So at 2, you can see the meander neck is narrowing. It's narrower than at 1. And then here you can see the meander neck has already been cut now. Now we have a Oxbow Lake. So the width of the meander neck is the one that is determining how close is the river from cutting its meander loop. So this is what we call a meander loop. This is a meander loop. Meander loop. So once this meander loop has been cut from the mainstream, we call this an oxbow lake while it has water. Once the water dries out, then it is called a meander scar. So there is your river in its lower course. You can see the gradient is very gentle. You can see the oxbow lakes. You can see the meanders there, but there's no oxbow lake. All you can see there is the meanders that you can see. Now, the river, what you can see here, you can see this will be your oxbow lake, and later on it will be cut from the mainstream. Actually, this is still part of the meander because it is still a join to the river. There's still joining of the river until there is deposition this side, and this is on its own. Then it's going to become your oxbow lake. It's going to become your oxbow lake. But once it's still, so like this one here that is now flowing on its own, you could look at it as the oxbow lake like that, because now this has been completely cut and this one has been completely cut from the main river. And this process will also take place here again as this river will now cut through here. It will cut through here as it goes in a direction, and that part will run on its own and becomes another oxbow lake. Now, another process that you need to pay attention to will be stream piracy. What is stream piracy? Is when an energetic stream diverts headwaters of a less energetic stream, or when a river with more energy diverts the headwaters of a river with less energy, or when a river flowing on a steeper gradient steals water of a less energetic river. I don't want to use the word steal because it is not a geographical concept. The geographical concept will be the water diverts a stream, not steal. I don't see river stealing. So we have, let's look at the process, what is happening here. So for river to divert headwaters, now we have two rivers here. We have two rivers here. We have two rivers. This river flowing on a steeper gradient, and this one flowing on a gentle gradient. Now, when this river flows in this direction, what do you call this process? We call it headwater erosion. What is headwater erosion? This water is flowing in this direction, but erosion is taking place in the opposite direction. The erosion takes place. So what process is going to take place here? We're going to get headwater erosion taking place. And this headwater erosion is going to result in the removal of this watershed. And then that process where this watershed is cut, what do you call this process? We call is this process here. We had watershed here. Now, when this watershed is no longer there, is removed, this process is called abstraction. Abstraction is the shifting of the watershed. So the watershed was this high. Because of headwater erosion, it was this high. Now, because of headwater erosion, it cut through the watershed. Now, we no longer have watershed here. The part of watershed that was here has been lowered and removed. Now, we call that process abstraction. Is the lowering and the removal or the shifting of the watershed. The shifting of the watershed or the lowering and the removal of watershed. That is what we call headwater. That is called abstraction. What causes abstraction? is headward erosion, when the river erodes towards the source. When the river erodes where it's coming from. Remember, water must fall on top here and it flows in that direction, falls on top here and flows in that direction. So this side is steeper, that is why there is more erosion. And then when this erosion continues to take place, this headward erosion, this river joins this river. Now, because now this water, the area here is steeper, water is not longer going to flow towards a gentle gradient. Water is going to flow because of the steep gradient and takes direction. So what has taken place at this point there? At this point, this is a point where we call elbow of capture. That is where river capture has taken place. That is where diversion has taken place, where the river diverts, where the energetic river diverts the headwaters, which is the water from the source. Headwaters is the water from the source. This river is flowing from that direction, going in this direction. Flowing from that direction, flowing from that direction, going in that direction. But now, because this one has steeper gradient, once it joins, water is no longer going to go that way because it's gentler there. It's going to go this way because it's steeper. Then you have this point there that we call elbow of capture. And then now, because this stream has changed direction, it's called a captured river or captured stream. And this one, because it no longer has enough volume of water, is a mass fed stream. It's a mass fed stream. It's not as fit as it used to be. It has lost water. And this one is called a captor stream. Now, what you should be able to do, you should be able to answer or give the characteristics of river capture before and after the process. The characteristics of captor stream before and after. So you must know here, it will be plus, plus, plus. Why it was able to do capture is because it had more water. Why was it able to do capture? Because it was on a steeper gradient. Why it wasn't able to? Because it was moving faster. And this one is negative, minus, minus. Why was it captured? Because it was flowing on a gentle gradient. It was moving slower. And then still after capture, what will happen to this river? It will have lesser water. This one will have more water. This one, after capture, before capture, it had more water. After capture, it will still have more water because you have now captured another river. And this one here, it had less water. And after capture, it will still have less water. And now, you also have to give those characteristics, having less water, and then how will less water influence erosion? There's going to be less erosion, but there's going to be more deposition. What will happen on the side? There's going to be more erosion, and there's going to be less deposition. So you just look at the characteristics of increased volume of water and decreased volume of water. And this area where water used to pass, water is no longer passing here. What is passing here is the wind. So we call this place wind gap. Now, disadvantages will be water shortage, farming, fishing, recreation. But as much as you can look at the impact of river capture for the surrounding, you must also know the impact of river capture on the rivers themselves. The impact that the river capture will have on the capture stream and on the capture stream. We said on the captured stream, there's going to be less volume of water, more deposition, less erosion. Here, there's going to be more volume of water, less deposition, more erosion, high chances of flooding. And then also you must know that the wind gap, there is more gravel at the wind gap and there is less water. Okay, this is another animation of river capture, is the same as that one. Now we can look at the characteristics of river capture. These are the questions that you can expect from river capture. Now let's look at river rejuvenation. What is river rejuvenation? When the river starts to flow faster. River rejuvenation is when the river starts to flow faster, and then you need to look at the reasons why will a river rejuvenate: because of the drop in sea level, because of the land that has risen, or because of increase in rainfall, because of faster flowing water, or because of stream piracy. These are the causes. These are the causes of river rejuvenation. In river rejuvenation, it is important for you to know the features. River rejuvenation, the features of river rejuvenation. How do you tell that a river rejuvenation has taken place? Number one, the features of river rejuvenation that you should know is that river rejuvenation takes place at a neck point. It takes at the neck point. So you must be able to define as a neck point is where there is a sudden change in the gradient of the river. Where there is a sudden change in the gradient of the river. So your neck point can be a waterfall. It can be a dam wall. It can be anything. And then the features of river rejuvenation. You can tell there's a neck point. There's a incised meander, there's terraces, there's waterfall. Now let's look at this terraces. So the river was flowing down there. It was flowing up here before. It was flowing up here. This was the initial valley. Then it stopped flowing, and after some time, it did vertical erosion. So at vertical erosion, then the river flew at this point. So this will be the next valley. And then after some time, the river rejuvenated, then it flew there. And over time, it flew there. Now the river is lower there. So it shows you that a river has got steps. Now these steps of the river are called terraces. These are the steps of the river. So it shows that rejuvenation has been taking place over a period of time. So we can look at that, those are the traces, and these are the incised meanders. So when you say a meander is incised, it simply means that the meander is entrenched, is inside a hole. So it means now rejuvenation took place when the river was already meandering. So what has happened with the meanders? The meanders just got deeper, because the meanders has already started, and the river was meandering, and then it lost energy, then it gained energy to erode vertically again. So when it gains energy to erode vertically again, we call that process what? We call it rejuvenation. So once that happens now, it means now the meanders are going to be deeper. So those meanders that are deeper, we call them incised. You can see the landscape here. You can see the landscape here that the area is relatively flat. The area is flat. So it could be in the middle course of the river. It could be in the lower course of the river. But the river has gained more energy. Now, when it gains more energy, so there's going to be downward erosion. There's going to be downward erosion that is going to make these meanders to be deeper. Because now the process of downward erosion and the process of upliftment of the land were taking place. So the downward erosion was deepening the meander, and then the isostatic uplift was also making the level, the area to go higher because of isostatic uplift. But the rate of erosion was higher than the rate of isostatic uplift. That is why now the meanders got deeper and deeper because of renewed energy of erosion there. Now, another evidence that a river rejuvenation has taken place, it could be a neck point waterfall, which is a point where rejuvenation take place. I think we will stop at this point because we did not prepare more lessons on the Mapwork because of it have been longer session to do both the climate and geomorphology, summarizing them for a one lesson. I want to thank you at this point.
Being shared with you. And therefore, I looked at a lot of things last time, but still, I want to look at more. And this will help us to understand the concepts in Mapwork, to understand everything in Mapwork, that when you're writing, it won't be stressing you. Okay, so in this session, I want us to focus on basically map calculations. Last time, our focus was on map interpretations, how to identify features, how to know the man-made and the physical features. In other words, we did the map orientation and map interpretation. Okay, I remember very well what we explained regarding the scale, the physical features, the man-made features, and so on and so forth, map code and everything. So we did that last time. So today, I want our focus to be on basically calculations. Okay, so dear learners, girls and boys, what you see on your screen is talking about what you need to know regarding calculations. When you're doing calculations, it is important to follow all the steps in order to get all the marks. In most cases, I see learners jumping steps, and when I'm marking, I don't mark the answer because I don't know where the answer is coming from. So in this case, I would like you to know that when you are doing these calculations, you make sure that you follow each and every step while doing your calculations. That's number one. Number two, that on those calculations, on the calculations you're doing, you make sure that you put all the units necessary for you to proceed with your calculations. For example, if you have measured on a ruler, and now you have measured this line here, and you have used the centimeters, okay? It's not a problem when you're writing your units. Let me say you have measured 2 centimeters, therefore you write 2 centimeters. There's no problem. If you have measured 1, you write 1 to show the units of measurements. It even becomes easier for you when you are doing conversions because you know which units you are changing from to which units. Okay, so it is very important for us to know the units in which we are doing the measurements on the map. That's one thing. The second thing is that when you're doing your calculations, you also need to be sure of the kind of map you are using. Take an example. When you read the question and the question says the topographic map, please straight run to the topographic map. If the question says orthophoto map, quickly run to the orthophoto map. Because what you must understand, learners, that these maps have got different scales. And these different scales help us to understand the units in which we are converting the aspects into. Therefore, we need to make sure that we know the units of measurements and the kind of map you're using. Okay. The second thing is that the relevancy of the different calculations. This makes understanding of the calculations easier. For example, gradients. If you're dealing with gradient, what do you need to know? When you're dealing with gradient, you must know that a gradient simply means how steep or how gentle the slope appears. So under that case, you know that when you're calculating the gradient, you need to understand that I need to know how steep or how gentle the gradient is. Remember, when you're dealing with the gradient, we know that the smaller the number, the steeper the gradient. The bigger the number, the gentler the gradient. So by you understanding all those concepts, knowing the value, knowing why you're calculating, then it becomes easier for you to be on track. You will not lose track at all. Okay. Now,
Scales of different maps and the conversion. I think this is what I've just talked about in the previous bullet. I said that you must know the different maps, and each map has its own scale. Take an example. You're dealing with the topographic map. What is the scale? The scale is 1 to 50,000. And if it's 1 to 50,000, you must understand that if I'm changing from centimeters to kilometer, I use 0.5. Why 0.5? Because the map is a topographic map. And the topographic map, 1 centimeter on the map represents 50,000 centimeters on the ground. So in terms of kilometers, it's going to be 0.5. So under that line, you get to understand that regarding the aspects of a topographic map and the orthophoto map, we need to understand which scale is being used. Okay. All right. So if you look at the orthophoto map has got 1 to 10,000, which is the scale. So if it's 1 to 10,000 as the scale, that means 1 centimeter on the map represents 0.1 kilometer on the ground. That is in terms of kilometers. Okay. But the same way, 1 centimeter on the map represents 100 meters on the ground in actual reality. Okay. So meaning to say that the moment you familiar yourself with which kind of map am I using, how important is this map, or what is the scale of this map, it makes it easier for you to understand what you are now dealing with. Okay. Maps are always smaller than the area of the ground they represent. This is obvious, because if the map was at the actual, was having the actual length, or the actual length, the way it is in the ground, it simply means you are not going to be in a position to represent it on the map, on the paper. So it is very important to understand that a scale is used to ensure that the maps can fit on the paper. It is from that background that you know that if there is no scale, or if we are not having scales, it was going to be very difficult for us to represent the distance on the ground and to show the relationship with it on the paper. Okay, sorry. Now, there are 3 ways we're using these scales, or there are different types of scales. I think I mentioned about this last time. Representative scale, fractional, or ratio scale. Actually, when we talk about fraction, you know that the ratio is existing in a fraction format. And then when you talk about the ratio scale, it simply means it's a ratio format. For example, 1 to 50,000 is ratio. That means 1 centimeter on the map, excuse me, 1 centimeter on the map represents 50,000 centimeters on the ground. What you must note with the ratio scale, ratio scales normally will have, in most cases, they represent the same units. For example, centimeter on the map, centimeter on the ground. But it's not a must. We can also say 1 centimeter on the map representing 0.1 kilometer or 0.5 kilometer on the ground. Therefore, that is the ratio. But you know very well that we can convert the ratio to fraction mathematically. When you are converting the ratio to fraction, it simply means if it is 1 centimeter, if it is 1 centimeter representing 50,000, how will we represent this in a fraction? You just have to have 1 over 50,000. It's the same scale, but this is ratio. This one is fraction. Okay. So you must be in position to know that. Okay. So another thing is that when you look at the representative scale, we say that 1 centimeter on the map represents 50,000 centimeters on the ground. When you say it like that, it's a representative scale. Okay, so representative fractional scale or representative racial scale are basically the same. Literally, they are the same, but they're different in writing because they have the same values, the same digits we are using, but when you're writing, it's a fraction, it must be a fraction, a ratio, it must be a ratio. Okay, now, what you must note that when you look at this here, this number here is in reality is bigger than this. Okay, when you look at it mathematically, 50,000 is bigger than 10,000. But in terms of the ratio representation, this one represents an enlarged section, and this one represents a smaller section. However, this one will have more details than this. Let's check. The larger the denominator, the smaller the scale, and the lesser the details it can have. Meaning that this one has got less details compared to what this one has. What is going to happen that this one is larger, it's exaggerated, it's enlarged. And I think you have observed that normally when you get a section from a topographic map and they put it on the orthophoto map, at times you might not be in position to see the street names or the streets on the topographic map. But because that small section has been enlarged, you will see the street names in most cases on the orthophoto map because it has been enlarged and therefore you can be positioned to see exactly. So the larger the scale, so the more details it can have. I mean, the smaller the denominator, the larger the scale. And so more details can be shown on that map. And also a larger the scale is used, large scale is used if the map shows a smaller area. For example, 1 to 100, a lot of details can be seen on such a map. This is what I said, that 100, when you look at it mathematically, is smaller than 10,000. But in terms of details, it will have more details that you will see on that area because it will be larger, it will be enlarged. In other words, it's like it is zoomed out. So you'll have a lot of things to see there. Okay, that was the first scale. The second scale that you're going to look at is what you call the linear scale or line scale. Linear scale is coming from the word line. Okay, so when you look at this word here, a line, this one, it's a line, just like you can see a line. I think you can see this here. Sorry, you can see this line here. Okay. When you look at this line, it has got two sections. Can you see that, learners? Look at it. This line has got this section here, this one here, and it has got from 0 to 9, this section here. When you look at here, here it is indicated meters. Here it is indicated kilometers. What you must understand that from 0 going this way is kilometers. From 0 going this other side is meters. So this linear scale has got two sections. It has got the meter scale or the meter section and the kilometer section. What do we need to note? We need to note that when you look at this from 0 to 100 to 1,000 meters, it's the same as 1 kilometer. But this box here, 0 to 1,000 meters, this meter section, it has got 10 small sections. What does that mean? If it has got 10, the whole box has got 1,000. So when you divide 1,000, when you divide 1,000 by 10, you will find out that you will be having 100, meaning that each box here represents 100. In other words, that means the answer you can get when you're doing calculations with the calculator, you will have to be in position to get the same answer when you put it on a linear scale. I think I will do that in the later stage to show you how we can use a linear scale in order for us to get the answer. Okay. So we know that this horizontal line drawn on a map, which is divided into a number of equal parts. A line scale is accurate and no calculations are used. A line scale is divided into parts. This is what I said. It has the kilometer and it has the what? The meters. Okay. So hope you understand that, learners. But as we proceed, I'll teach you how we use this line scale in order to get the answers. It's very accurate, very, very accurate. Actually, it's accurate more than the what? The calculations that you use with the calculator. All right, but we shall see how we get the accuracy is acquired. The word scale is another type of scale. A word scale is words, and this means that they are said verbally. Okay, it's a verbal statement. Just like the ratio scale is 1, 2 when you're using those dots. Now here you say it verbally. That 1 centimeter, 1 centimeter on the map represents. I want you to look at this word. The word says represents. It doesn't say it's equal to. Some of you learners make a mistake and you write this scale in terms of equal to. That is very wrong. For example, if you say 1 centimeter represents, okay, sorry for the ratio, represents 50 or 500 meters. This is very right, because 1 centimeter on the map is just representing. It is not equivalent to. So some of you write it like 1 centimeter equal to 500 meters. This is very wrong. Please avoid it. It will never be equal to 500 meters. It can't be, but it represents 500 meters on the ground. So understand, learners, that this one is very wrong. It must represent 2. So the right word to use is either represents or ratio. Okay. All right. So here, the scale is given in words. In other words, just like you see the word, this one to say a word scale, because of this word, it simply shows us that the scale is in form of words. Because of the word ratio, the scale is in the form of ratio. Those are the 2 dots. Because of the word, because of, what did we say, a line, the ratio is in form of a line. So from there, you get the details of how you're supposed to use those different aspects in different areas. Okay, so I expect learners not to keep on making such mistakes in Mapwork, because it's costly. You end up losing a lot of marks because of making such slight mistakes, and you can avoid it. Okay. Okay, let's proceed. All right. How do we calculate distance? Remember, I told you that our main focus today's topic is distance. Is calculations. And while calculating, you must know that calculations cover a lot of aspects. For example, under calculations, we cover, let's see here, under calculations, we cover, number 1, we cover distance. Okay, we cover gradient, we cover area, we cover vertical exaggeration, we cover distance, area, gradient. Under calculations, we also cover magnetic declination and magnetic bearing. Okay, then under calculations, we also cover what else? Okay, if you look at all these aspects and you put them in your head, then there's no calculation you will find that will give you trouble. Okay, maybe we shall add on others as we proceed. But I want you to understand that these aspects are very important. So in case you as a child, you're going to write your paper, please make sure that you don't go to a paper minus putting all these aspects in your head before you write. Okay, gradient, area, vertical exaggeration, magnetic declination, magnetic bearing, true bearing, all those aspects need to be put in your head before you go to write your examination or any form of assessment. Now, calculating distance is the first aspect that I want us to look at. So while calculating distance, I want you to know that there are two distance calculations that we can look at. Take an example. We have a straight line distance, and we also have a curved distance or a winding distance. So when you talk about a straight line distance, it must be straight. Like you just put a ruler there, you get the distance in centimeters, you do your conversions, and you get your marks quickly. Now, if we talk about the winding distance, you have to use something that is not stretching, but it can be bent to cover all the widening areas, okay, or the curved areas. For example, you can use paper edge, you can use a thread, you can use anything to make sure that the distance is covered. I want us to look at this, learners. Here we have this line here, this black line here, that is coming from here to the end there. And now the question comes that calculate the distance covered by a black line covering, maybe let me say block 1A, I mean A1, A2, and B1 and B2. So if this is a line, it's a straight line distance, what do we do? Please learners, let's look at the procedure. The first procedure is measure. This measurement is sometimes referred to as the profiles, or you have to measure the distance, the straight line distance, and then the distance you measure, you convert it. Look at this. The first thing is with a line as in above. Okay, let me say measure the distance between these two, between one spot height 1268 and 1282. Now, what do? We first of all measure the distance. Whatever you use is fine, but measure the what? The distance. After measuring the distance, what's next? Let me say you have measured the distance from where, from this, on this map, from here to here. And after laying your ruler along this line here, you have come up with 3.8 centimeters. I think you must be knowing position. You must be in position now. You must be in position to use a ruler. When you're using a ruler has got two sides, or it has got different units. Some of you are measuring, the measurements you're using here is millimeters, because I know some rulers have got millimeters, some rulers have got centimeters, some rulers have got inches. So if you use a centimeter ruler, I normally advise my learners not to use any other units, because it disturbs a lot, because some learners don't know how to convert. So I preferably ask my learners to use centimeters, because when you're using centimeters, it becomes easier for you to know what to convert to. So when you look at this kind of map we're using, it is meant to be, or it is a topographic map. When you know that, when you understand that it's a topographic map, what comes in your head? What you get in your head is that a topographic map has got a scale of 1 to 50,000. Okay, so what does it mean? If you measure from this point here to this point here, and after putting your ruler along with this point, the units you are getting is 3.8 centimeters. So that is your measured distance. So what shall we say? We shall say that measured distance, or map distance, times the map scale. What will you get? You will get the answer there. So what have we measured along this line? We have measured that along with this line, it is 3.8 centimeters. I want you to see you're putting units. Why? Because you measured it in centimeters. If when you measured it in millimeters, you can put in millimeters, but you must be in position to do what? To convert. If you can't convert, it's going to give you a hard time to understand. So it's 3.8 centimeters times the map scale. Since this is a topographic map, what is the scale of a topographic map? Just a pause for a second, think about it. Okay, I'm just pausing for 1-2 seconds. What is the scale on the topographic map? Okay. Yeah, I can see learners are thinking about the scale. So the scale is 1 to 50,000. Okay, and if this is the scale we have, and what shall we do here? We shall multiply by 50,000. Okay, and after multiplying by 50,000, remember, what does this scale mean? 1 centimeter on the map represents 50,000 centimeters on the ground, meaning that this 3.8 centimeters is what you measured on the map, on the piece of paper. So if this is what is on the paper, you must convert this distance to reality distance. What will it be if I go where this map is coming from? But you know that each unit on the map is representing 50,000. So what will I have? And what will it be? What will be the units? So what shall we do? So we multiply. Okay. So after multiplying, what will you get? After multiplying, what will you get? The multiplication is going to be that 3.8 times 50,000. What are you getting? You are going to get 175,000. But this is what? Centimeters. You see that? Meaning that the map distance that you have is 3.8 centimeters. The ground distance or the reality distance is 175,000 centimeters. So that is the ground distance. But according to the question, in this case, the question is saying that the distance, the answer, let me say the answer, the examiner wants the answer in kilometers. Okay. The examiner wants the answer in what? In kilometers. What shall we do? We shall say that this answer you got here, divide it by 100,000. And what will you get? You will get the answer to be 1.75 kilometers. Meaning that this distance you are seeing from here to here, it is the paper or the map distance. But in kilometers, in where this map is coming from, it is 1.7 kilometers. That is one way of getting the answer. But don't forget that if you go this way, you still get the same answer. If you cannot go this way, what do? You come here. I want you to see here. When it is a topographic map, 1 centimeter represents 50,000 centimeters. Also, 1 centimeter can represent 500 meters. The same way 1 centimeter is representing 0.5 kilometers if it's a topographic map. If it's an orthophoto map, the same way, because the scale here is 1 to 10,000. So in terms of meters, we're going to use 100. In terms of kilometers, we're going to use 0.1. So we come back here. And we say, this map we are using here is a topographic map. So when you check here, topographic map, if I want the answer in kilometers, what am I multiplying with? 0.5 kilometers. So I come here, I would say that 3.8 centimeters times 0.5 kilometers. What will I get? The answer you're going to get is going to be 1.75 kilometers. Do you see that it is the same answer, guys? It's the same answer. But now you must understand that here you must have this in your head. That if it's a topographic map, I use 0.5 if they want the answer in kilometers. If it's an orthophoto map, I use 0.1 if they want the answer in kilometers. If they want the answer in meters and you are dealing with the topographic map, please learners, don't forget, we use 500 for the topographic map. We use 100 for the orthophoto map. Hope learners, you won't make any mistake anyway, okay? Because those mistakes cost you a lot. Imagine this section or this part here is saying 4 marks, and then you lose all the 4 marks because of that, or 2 marks, and you lose all the 2 marks because of that. And that mistake can be avoided. So you have two ways. You can either go this way or you can go this other side. Whatever is easier for you, you can use it such that you can get everything right. Hope that is okay, learners. That is for the straight line distance. In scenarios, I want you to look at it in the same scenario here. Can you see? Then check which scale is it using, multiply, and you see that you get the answers here in centimeters. Then you convert the centimeters to meters. Then you convert the meters to kilometers. It depends on how you want to go about it. Okay, it depends on how you want to go about it. But all in all, that is how we do the calculations. Okay, so if it is orthophoto map, I expect learners to be knowing that. Let me take an example here. When you look at this area here, it's coming from the topographic. Imagine, please just imagine. I'm not saying this is the orthophoto map. Just imagine, this is orthophoto map. Okay, and this distance that this line that you are having here is drawn on the orthophoto map. And after measuring this distance here on the orthophoto map, it is giving you 3,8 centimeters. What will it be? So I think you know what to do. There, you just get the 3,8, okay? And you say 3,8 in terms of centimeters. Sorry, it will be 3,8 centimeters times 0,1. Okay, that is if you use this method here. Okay, if you use this method that I put here, it's going to be 3,8 centimeters times 10,000. So the answer you're going to get, you're going to divide it by 100,000. So when you divide the answer here by 100,000, the answer you're going to get is going to be that very answer. Okay, so what you'll get will simply means that will be the distance in kilometers. In other words, 0,38, okay, times 0,1, I think you'll have to get 0,38. Okay, and this is going to be kilometers. Okay, so in this case, if this was orthophoto map, this is what I expect to see. If it is a topographic map, please use the previous one that we used. Hope we understand each other, learners. Okay, so boys and girls, having seen the distance which is straight, we must understand that we use a different approach if we are dealing with something that is not straight. Take an example, the distance for this road here from the beginning to the end. You can see that this road here is not straight, it is winding. Can you see that? So what do? Get a piece of paper or a thread, lay it along the feature you are measuring. Let me say in this scenario, it's this road here, from here to here. So you lay it along this road here nicely. Don't stretch it, because when you stretch it, let me say you are using a thread that is stretching, or anything that is stretching, it simply means it's going to give you wrong measurements. So what do? You don't stretch it, you lay it along that line. Then afterwards, you take this distance to the ruler, measure the distance in centimeters, and then you follow the same procedure to convert. Okay, if let me say this distance here, after laying a thread along this, you see when you lay thread here, you put it from here. If it winds, you also wind the thread. If it changes direction, you also change along this line. So afterwards, you're going to hold the thread that is straight. So that thread, you lay it along on the ruler, and you get an answer in centimeters. If not, you use a divider. I think, learners, you know a divider in your mathematical set. A divider has got two sharp points. So when you lay a divider along that thread, you just put it along the thread and you get the distance. You transfer the divider to the ruler and you get the centimeters. So those centimeters are the ones you convert using the same procedure. If it's a topographic map and they want the answer in kilometers, 0.5. If they want the answer in meters, 500. If it's an orthophoto map, they want the answer in meters, 100. They want the answer in kilometers, 0.1. Like that, like that. So you won't find any challenges at all. Okay. So that is distance, learners. I hope we understand each other. We are at par and everything is okay regarding distance calculations. So if you still have any problem regarding distance calculation, feel free to contact me via Thunder Education platform, or to ask questions via the Thunder Education platform. I'll be in position to reply to you and answer your questions. But learners, I want you to know that Mapwork is very easy. Mapwork is the easiest section to pass. And I want you to understand that in any case you understand Mapwork, it's free marks. If you really understand it, it becomes free marks. So I don't expect my learners that are now going through this lesson to still fail Mapwork. Okay, most especially these simple things. So okay, we are done with the distance, or actual distance, or straight line distance, or curved distance. So that is exactly what can be asked. Let's proceed and look at area calculation. Let's proceed and look at area calculation. Area calculation, in other words, the area is calculated to determine the actual size of the ground on the ground. And in this case, we'll look at a feature or a demarcated area that you're going to look at. Under this line, we are looking at the area that is put down here. And when I look at it the way it is, what comes in my head is that this is a topographic map. And the moment I see a topographic map, I'm thinking of the scale that is now meant to be used on the topographic map. Okay. So what we can do here, or what can we do here? We go back here and say that while looking at the area can also be calculated in kilometers, and also it can be calculated in meters. So learners, I want to electrify something here. When you look at the formula that is now being used here, it is area, which is, it's area which is equal to L times S in two brackets times B times S into brackets. This formula normally in your exams is not what is given. In your exams, they normally say area is equal to L times S. This is what normally comes in your exams. Now, when you see such a formula in your exams, learners, please don't hesitate to expand it. You can have the formula like this in your exam, but just know that area is equal to L times S times into brackets times S, B times S. Sorry, this is L times B. Okay. Now, if it's like this, that simply means you will not forget what to do. You will not forget that I have to multiply everything by the scale. Otherwise, if you go with this here, in most cases, you forget to multiply everything by the scale. Yet, the area we are looking for the area on the ground, actual distance. And therefore, to get the actual distance, you must make sure that you consider the scale that is used and which map is being used. Take an instance that when you come here, when you come here, oh, I want to create space, sorry for that. When you come here, on this area that the part that is given. Look at this. By looking at the way it is even indicated area covered by the orthophoto map. But this must be on the topographic map. The way you see it's in color, you can see the features with symbols. Remember, a topographic map basically uses more of symbols and so graphs and so on and so forth. So these contour lines and the way it appears in color, it simply tells us that it's a topographic map. What are we measuring? We said that according to the formula, we need to measure the L and the B. You come here. When you look at this part here is 7.4 centimeters. This part here is 9.8 centimeters. By you looking at the units or the answer that you got after measuring, it clearly tells you which one is the length. Okay, normally the length is longer than the breadth. So you will find out that the L must be bigger than the B. In most cases, even if this part here is turned upside down and this part is here, this part is up here, you must note that even if it is turned upside down, this line that is longer should be the length. Though I know after calculating, you will get the same answer, but you have swapped the concept. The concept is that length is the longest part than the B. So if you just put this under the length instead of under the B instead of putting it under the L, you will lose marks. Sometimes you will be penalized for that. So please let us try to avoid some such minor mistakes. So when you're given this formula, which is L times B, normally I tell my learners to expand it, write it in an extended formatting. The moment you write it like this, it is going to come into your brains that what is A? A is the what? Is the area, which is equal to L. What is the value for L? L, you have just measured it that it is 9.8. So you will come here and you say 9.8 centimeters times the scale. What is the scale? Which map am I using? I'm using a topographic what? A topographic map. Oh, I'm using a topographic map. What is the topographic map scale? The topographic map scale is 50,000. Put it in brackets. Remember, this is also what? Centimeters. Okay? Put in bracket times. What is B? The value for B is 7.4. I come here, I say 7.4 centimeters times. What is the scale? Obviously, it's a topographic map. Okay, the topographic map, what is the scale? Is 1 to 50,000. So you say times 50,000 centimeters. You cross the brackets. Why am I putting this? Why am I multiplying by 50,000? To convert the centimeter distance, the actual distance in centimeters on the ground. So when you multiply that, what will you get? You will find out that it's going to be 9.8 times 50,000, which gives you 9.8 times 50,000, which gives you 5. Okay, 50,000, 9.8. This is centimeters. Okay, then you go. Sorry. It is multiplication. It is 9.8 times 50,000. It gives you 4. It gives you 4,900. Okay, 490,000. Okay, this is centimeters. Then you come here, 7,4, 7,4 times 50,000, and you get that is 370,000 centimeters. Okay, so I have this, it's all centimeters. Okay, it simply means that the paper has got 9,7, but in reality, where the map is coming from, it is 490,000 centimeters in reality. Just the same way the B has got 7,4 centimeters, in reality, it is 370,000 centimeters. Now, these are centimeters, okay? But according to this, the question wants the answer in kilometers, okay? So because the question wants the answer in kilometers, here, can you see it in kilometers? So what do? I come here, I change the centimeters to what? To kilometers, okay? So that means this divided by 10,000, divide by 10,000, by, sorry, not 10,000, 100,000, and you also divide by 100,000, such that is 4, go with this 4, and therefore I'm remaining with how many? 1 place, I move it here, it becomes 3,7 kilometers. That means this one has changed from kilometers, from centimeters to kilometers. Okay, now I come here, so this is this one, 1, 2, 3, 4, 1, 2, 3, 4. How many places am I moving? It's 1, which becomes 4,9 kilometers. So the answer is going to be kilometer times kilometer. What are you getting? You get kilometer squared. Now 3,7 times 4,9. What do you get? 3,7 times 4,9. What are you getting? You get 18,13. So this answer you get is in kilometer. This is the area if you are using kilometer. So in scenarios whereby you were supposed to use meters, what will you do? It simply means that after multiplication is here, you don't multiply by 10,000, you don't divide by 10,000, you divide by 100. Even here, you divide by 100. Someone can ask me, but sir, where do we get this? Why do we multiply by 10,000? What do we multiply? What do we divide by 100,000? And why do we divide by 100,000? I want you to remember these, learners. Remember this so that you don't forget. Okay. King Henry does not mind drinking cold milk. I just want to deal with what I'm dealing mainly with, kilometers and what? And meters.